everyone, welcome to our Tableau course by Simplilearn. Have you ever wondered how businesses make critical decisions based on data? Now, Tableau is the tool that turns raw data into interactive, easy to understand visual stories. And guess what? In this course, we are going to teach you how to harness the full power of Tableau and take your data analysis skills to the next level. In this course, we will guide you from a beginner to intermediate level, helping you master data visualization, business intelligence. The demand for skilled Tableau users is soaring as businesses rely more than ever on data-driven decisions. As a result, learning Tableau can set you up for success in a rapidly growing field of data analysis, business intelligence, and decision making. In this course, we will start with the basics of Tableau, learning how to set up tool, connecting the data, understand the concepts like dimensions, measures. Then we'll dive into creating dynamic charts, filters, and interactive dashboards that bring your data to life. And by the end of this course, you will be able to build real-world business dashboards and share your insights confidently. We'll also know about the best practices to avoid common pitfalls along the way. So here's a sneak peek of what you will learn. Introduction to Tableau and setup. We'll get familiar with the Tableau interface and tools, installing Tableau for the first time. Next, data visualization basics. We'll create bar, column line, map charts, and start building your first dashboard. Then we'll have a look at some advanced techniques. We'll dive into data preparation, data blending, explore advanced chart types like pie chart, heat maps, scatter plots, and waterfall charts. You'll learn how to build interactive real-world dashboards with live data, understand data visualization, and master the art of presenting insights clearly. Then we'll have a look at the level of detail, LOD, and calculation, where you will master complex calculations like aggregate, table, and row level calculations to make data even more insightful. And lastly, we'll have a look at some Tableau interview questions. We'll also cover the interview questions to make you job ready. Now, before we get started, if you're interested and if you're looking to advance your career in data analytics and generative AI, then the professional certificate course in data analytics and Gen AI from ENICET Academy IIT Kanpur is designed to equip you with the skills you need to succeed in today's tech-driven world. With masterclasses delivered by IIT Kanpur faculty and program certificate that boost your professional profile, this course offers hands-on learning through 215 exercises and 12 plus real-world projects. You will dive deep into data analysis, Python, SQL, generative AI, and AI-powered visualization tools like Power BI, Tableau. With live interactive sessions, you won't just gain expertise in these tools, but also earn Microsoft Azure Data Fundamental certification along the way. So whether you're a fresh graduate or looking to level up your skill, this 11-month course provides you everything you need to stay ahead in the world of data. So what are you waiting for? Hurry up and enroll now. You can find the course link below. Now, before we get started, here's a quick quiz question for you. The question is, which of the following is a feature of Tableau that allows users to display data in interactive and dynamic format? Your options are static charts, dashboards, pivot tables, or data grids. Drop your answers in the comment section below and let's see how many of you got it right.
Tableau, as I said, is also a data visualization or a self-service business intelligence tool similar to Power BI. You're going to see a lot of similarity with Power BI, and you're going to see some differences as well with Power BI and Tableau. To give you comparison of these two tools, Tableau started much earlier than Power BI. Tableau was there in the market quite back, quite earlier than Power BI, and it's very powerful, very good tool when it comes to data visualization. The data visualization capability in Tableau is quite superior, even when it comes to Power BI. It's more superior. Power BI has emerged in about 2015, but Tableau was there earlier in late 2000. Okay, and Tableau very rapidly gained the market share, and it evolved, and it had beaten all the other competitors that were there at that time in the market, be it Click or Spotfire, or there were other enterprise BI solutions. It gained the market share quite rapidly. And even right now, it's among the top players. Tableau used to be an independent organization, that used to be an independent a company initially. And then I believe in 2019, it got acquired by Salesforce. So in 2019, Salesforce acquired it, and now it is like Salesforce is the owner, and you will see a lot of like integration with Salesforce moving forward. Although this is an in like you can also purchase independent licenses, and still it is independently available, but a lot of integration you'll see with Salesforce, right? So for Salesforce, all kinds of BI reporting work, now Tableau is being used quite extensively. So just once again to just give you a quick background about the different components, different tools that we use, not the tools, but let's say different types of career tracks and where Tableau, Power BI, all of these comes into play. So you see this screen or this slide on my screen. So there are these different types of career opportunities when it comes to Tableau. So there are these different roles, and all of these roles would include Tableau. Even Power BI can also be like included in these roles. Do you have understanding of what these roles are? Do you know when we see these roles, business analyst, BI developer, BI analyst, data analyst, BI engineer, does it ring a bell? Do you understand what these roles are? You may be you may have heard about these roles, but do you know what these roles are? What comes under these roles? BI engineer, BI analyst, and BI developer. Okay. Let me give you a gist of the components on the project, and then you will get understanding of these roles as well. So let's just start with that basic, and then we'll deep dive into the Tableau side of things. Let me write this. So we have these roles. Let's go back to the roles. Business analyst, BI developer, BI analyst, data analyst, and BI engineer, right? Let me write these down. Business analyst, BI developer, data analyst, BI engineer, and which one did I miss? Okay, these were the roles that were listed there, right? So many a times organizations nowadays come up with these designations designations, right? So there is a data analyst position in some company, then there is data business analyst or BA developer position. But you need to understand, instead of understanding the designation, let us understand the roles, because what matters is what is your role in the organization. And you'll see many of these designations will have interchangeable or similar roles. So let's understand first the roles part, and then it will be clear where what kind of designation, what kind of roles are needed. And even before going to the roles, we need to understand that these are all part of business intelligence processes, right? All of these roles are part of business intelligence projects. Okay. All of them, all above, are part of business intelligence projects. That's exactly what business intelligence is. Business intelligence is a process, okay? A process or a system that will always be bringing the data, raw data, and it will provide insights from that raw data, so that you don't need to do these things again and again. So you need to, uh, for example, let's say there is a data, okay? There is a data about, let's say there is a, like we have a training program, right? A training program. Now we got the data about the training program. Let's say data is about how many learners were there, how many learners attended all the sessions, how many learners had taken the certification, how many learners have completed all the assignments, how many learners then given this kind of like feedback. All those kind of data is available there. Now there could be a one time analysis that, okay, I need to know like how did this program helped our learners. So someone would just analyze the data one time and say, okay, there were 100 participants which were there. Out of them, 90% of the people attended all the sessions and completed all the assignments. And then you got some other details like these. 80% of the people have completed the certification. Now, this is a one time analysis, right? One time analysis because this is a one time event, one time course, and we got this information. But if I need to have a system where all the trainings that Simplilearn is providing, I am able to get the information about all the courses, and continuously the data for the new courses is getting added to that system, and I'm getting that information available to me with all these insights. So I can just keep on taking the insights from them as and when the new data comes up, right? So so there is a one time analysis that you can do and get the insight, and then there is a continuous process which will keep on taking the raw data as and when the new data appears, and it will show the insights in the form of visuals, in the form of all the different types of ways with which you can show the insights, right? So business intelligence is a set of, or it's a process, a system or process using tools to convert continuously convert raw data into meaningful insights. Okay, now we are talking about system. Okay, system or process, which means that there has to be a defined process to get from the raw data to meaningful insights, right? And the second part which is important here is using tools. So there will be different tools or different softwares which will come, which will enable this business intelligence system. Okay, which will enable this business intelligence system. So once again, let us learn about the different components that will come about whenever we talk about the business intelligence project. Okay, so what are the components of business intelligence projects? Okay, so the first and the foremost thing is data, right? Data. So first component is data, and when we talk about data, we are talking about data like what are the sources of data. So raw data that must be coming from some source. So we are talking about data source here. So where do we take the data from? This is the point of origination of data, right? Point of origination of data is your data source. Now, depending on different types of tools that you use, can you give me example? Give me example in the chat. What can be considered as the data source? Okay, give me example of data source. What is a data source? Example of data source. Don't not the definition, but an example of data source. What can be a data source? Okay, file Excels. Okay, focus on the word of origination. Focus on the word of origination and think critically. When we say data source and the point of origination of the data, we are talking about origination of data. Like database is not the does database base creates data? Does a database creates data, or does a database maintains the data? Is it used for just maintaining the data, right? So when I'm talking, think about any business. Let's say Let's take an example of everyone must have gone to some superstore, right? You may have gone to Walmart or D-Mart or, you know, hyperstore, some store, right? So where does the data gets originated? What is the origination of the data? Very, like, think about these things. So there are data is originated from systems like, let's say there are system called, there is point of sales. Okay, point of sales. Example. So for example, you go to hyperstore, and as soon as you go there, and you did the purchase, you go to the billing machine, right? You go to the um, billing department, and you go there. They enter all the information, what all they swipe. They have those machines that scan the barcode, and automatically the bills are generated, right? So there are these different points where the data is originating. Okay, it can be, let's say, there are these POS systems, point of sale system, right? Point of sales. So all these at the billing counter, all these machines that automatically generates the data, they will also ask for your information. What is your name? What is your phone number? Some other information. All those things are generating data. Okay, so there are these point of sale system that is generating data for sales. Now you may have, let's take another example. Let's say that these also have some online presence, so people are going on the website and making a transaction. That is also generating data, correct? So you make a purchase, that is also, all these data are, these are the data sources. So if your website is generating sales, that is your source of data. That website is the source of data, and depending on what kind of database that website has, that's where that data is getting stored, whatever is being generated. So there are all these different sources. One of you said that there could be surveys. Yes, that is also a way of connecting, getting the data. This is also data source, right? Or you are running some, let's say, marketing event. Let's say a digital marketing campaign is run. So how many people view your ad? How many people clicked on it? How many people then visited the website and made purchase? All of these are generating the data, right? So there is, let's say you ran some marketing campaign on LinkedIn. So your LinkedIn ads is a data source, correct? Or you're running ad on Facebook or Meta, that is your data source, correct? Or if you're talking about any kind of, let's say there is an uh, you have some operations in your business. So all these operations nowadays, there are those electronic machines that also tracks all the activities that is happening. So those are the points where the data is originated, right? So you have point of sales data, you have a website, you have your uh, other operations tracking softwares. All of these are the point of origination of the data, correct? Social media. Okay, so there the data is generated, and sometimes you also generate data manually by some Excel files, that is also there. But think about data source as the first original point of origin of the data, correct? So once data is originated, then organizations need to analyze that data and make some business decisions. So the second part of this is managing this data that is generated in these systems. Okay, there you need to do a system where all these different data is centrally stored. Okay, and that part is called data collection and data also data warehousing. Data warehousing. There is this term called data warehousing. So when you have these different data sources, there must be a way where you can collect the data from these different systems and place it in a common one central place where all the historical data is added, right? All the data is stored there. So you can create a data warehouse, which is a, you can imagine it as a place. Of course, it will be a virtual place, right? So a place where to store all historical data from different data sources for analytical purpose. Okay, we want to analyze the data, but to analyze the data, first of all, you need to have the place where you can store all the historical data, not just 1 day, 2 day, but all the historical data that is coming that you have generated. It should be in a big, uh, there should be a big storage where all of this data is present. And then later on, you can use this data in these data warehouses to analyze the data. Okay. So data warehousing, when we say data warehousing, it can be a big, it's consider this as a big database. It's a big database. So all of these data sources where the data is generated, of course, when we say data is generated, there must be all of these machines which are capturing the data that must be stored somewhere. So there would be, all of these would be having their own databases where the data is stored, correct? But that is, those databases are your databases for these systems. Those are not meant to store large volume of data. They will just continuously, as the activity is happening, they will just store that daily transaction information. And then your data warehouse is where all the historical data and data across all these platforms are stored in one place. Okay. Once the data is stored in the data warehouse, it can be a big, let's say, different types of, you can imagine, let's say, an SQL server based data warehouse or an Oracle server based data warehouse or SAP data warehouse. There can be different types of providers for the data warehouses, or Azure based data warehouse or AWS data warehouse. There could be different data warehouse uh, softwares that you can use. And now, when the data is stored in a central place, you can start analyzing the data. So then comes using the BI tools. Okay, what these BI tools would do? These BI tools will connect to the data stored in the data warehouse. Okay, to analyze the data. These are used for BI tools are used to connect to data in data warehouse for business insights data analysis, right? So which are these BI tools? Tableau, Power BI, all those are these BI tools which then connect to the data warehouse and you analyze the data. Okay. So these are the major components. All the BI projects will have these parts. So there will be data source, there will be data collection and data warehousing process. And then once the data is warehoused, you use BI tools to connect to the data and start analyzing and giving the business insights. Now, there will be different roles within this entire process, and these different roles will come into where you will be, like what kind of work you will be doing. So let's understand these roles. So roles in the project. So firstly, let's talk about BI engineers. Okay, let's understand about BI engineers. They are also called data engineers. Data engineers is also common term that is being used here. Okay, data engineers, BI engineers. So their role is to get this part done, data collection and data warehousing. This part is responsibility of BI engineers or data engineers. Okay, so what data engineers do? Data engineers, they set up pipelines to ingest data in from data sources to the data warehouse. Okay, so there should be pipeline, so there should be continuous data ingestion that needs to happen. Before the ingestion, of course, there may be some need of data cleaning, transformation, all those parts may be required, but this is data, so their role is to make sure that these pipelines are working properly and the data is continuously ingested into the data warehouse. That's what BI engineers do, or the data engineers do. Once the data is stored in the data warehouse, then the role of analysts or data analysts or business intelligence analysts come into play. Okay. Next role is about analysts. Okay, analyst, as the name suggests, they analyzes the data which is now stored, which is ready to be used, right? So they'll use the data from the data warehouse and analyze the data. Within analysts, there can be multiple types of analyst. Okay, so there can be an analyst role, there can be BI developer slash data visualization expert, or what is the other, BI analyst, right? These three are same. BI developer, data visualization expert, BI analyst, they are all same. Their role is to their role is to use uses BI tools like Power BI, Tableau to create, to analyze the data, right? They are all same. More or less the designation names are different, but more or less they are same. Okay. You can also bring, yeah, data analyst can also be added over here. The second type of role that comes here is data scientists. So data scientists and the data analyst that you're talking about, data analyst can fall into both BA part as well as the data science part. You need to look at what the role here is, because they're all data analysts. Okay, so this is mainly, both of them are like, this is part of data analyst. Okay, within data analyst you will have BI side of things, then you have data scientists. So data scientists are more of, this role is, while BI tools are typically used to tell what has happened, why it has happened, those kind of things, but data scientist's role is more of telling what may happen in the future. Okay, so this is for more of machine learning and predictive analysis. Okay, predictive analysis. So anything to predict what may happen, what will happen in the future, that is more of data scientist's role would be. Okay, both can come into the data analyst role. Under data analyst, you can have BI developer, data visualization. That is the first one which uses BI tools, and then there are other which uses predictive analytics, and they use the tools like mainly Python or SAS. Okay, and nowadays there are all these cloud-based. There are existing algorithms that are there which can just be ready to deploy. Those kind of things are emerging, but these are the typical tools that data scientists use. Okay, so this is more about analyzing your data. The first one analyzes what has happened in your data so far. What does it tell you? And the second one is what is going to happen in future, what may happen. Okay, within this there is then another role in the project which is business analyst. So if you see the first role, I did not mention Python anywhere, right? So here you can use the BI tools and you don't need to learn and you need to apply Python here. Okay, this can be done with the BI tools like Power BI, Tableau. Even if you know one of the tool, that is good enough. And another tool that I should add here is I should add this is SQL. Okay, SQL is also important. So if you know these, then you're good for this role, first role. You don't need to learn anything else. Right. So these are the components of a BI project. Okay. So a component of BI project. I'll come to the hierarchy part. I'll come to that. Let me answer that in a while. Once we discuss this, you'll get clarity on this. These are some of, right now we are discussing about different components in. Okay. So we have the data engineering, then we have the data analyst. Okay. So far, these are the one roles which are executing your project. Okay, execution of the project is being done through these roles. Correct. So the third role is more about understanding the business problem. So the other role which you may have also you are also learning, which is the so the third is business analyst. Okay. Now many people get confused with business analyst and data analyst. These are two different roles. So business analysts are the people who analyzes the business requirements. Okay. They analyzes the business requirements and then they plan the execution. Okay. What needs to be done for a for a project, right? So business analysts are work on the project requirements and collaborate with data engineers and data analysts for project deliverables. Okay, so business analysts are these are the ones who don't deep dive into the technical tools, but they need to know both the sides of the project, the business side, like what the business requirements are. So if there is a project, then what is the objective? What is expected out of that project? What kind of what can be delivered? What cannot be delivered? What will be the eventual um, uh, project that you are going to be delivering to the client? What kind of business intelligence reports, dashboards, um, any kind of deliverable? So that is defined by business analysts. So business analysts work closely with data engineers and data analysts to make sure that projects requirements are understood and delivered within the scope of the project. Okay, that is the role of business analyst. Business analysts talk to the client stakeholders, like the clients and They take the requirements, they ensure that everything is what the client requires, we are delivering that. Okay, that is a business analyst's role. Okay, so business analysts often work with the data engineer, data analyst. They guide data analysts and data. Okay, yes, Prerna, what you're saying is correct. So you may have seen opportunities where there are these roles where SQL, Power BI, Tableau skills are required for business analysts. That is what nowadays organizations require, because assume that you are a business analyst. Okay, now if you're working with BI developers who know SQL, BI, Power BI, and Tableau, and they tell you that, okay, this work is going to take 90 days to complete. If you don't know about these tools, even the anything about these tools, you're going to uh, like believe that what they're saying, right? But if you know at least the basics, if you know these tools a bit, you would be able to also think critically and say that, okay, it does not look like you're giving me the right numbers. Maybe this can be done in not 90 days but 60 days. If you know some technical skills, then it will be better for organizations, and that is why organizations also say that you should have these skills. Then you will be able to work better in this role. Okay, that's why these skills are required. Okay, another role that would come here is project management or manager, that may come. Okay, so project manager. So there is a business analyst, and then there is a project manager. Project manager need not to have any technical skills when it comes to the BI part. Although nowadays, like if you have some technical skills, that is always advantageous. But project manager ensures all client expectations are met, right? All clients' expectations are met, be it in terms of the what is um, I would say all the client expectations are met, and ensuring all resources for the project, right? So whatever is required for the project, so all the uh, everything, be is related to the software, be it related to the team members, be it related to the workforce, be it related to overall budgeting, costing, all those things. So all this part, which is more of ensuring everything is met for this project. So that is done by the project manager. Okay. Now, Ron, you were asking about the hierarchies, how the hierarchies are there. So this is exactly the hierarchy would be. So there would be in a team, there would be at the very top, there would be project managers, right? Then below that, you will be having BAs, right? And then below them, there would be data engineers, which will work, which are at the same level, data engineers, data. Okay, so there would be these roles. Now within these, there could be senior, senior data engineers, senior data scientists, and then there would be junior data engineers, data scientists. Those kind of course, that depending on the experience, those kind of hierarchies can also come. But these are the role-wise hierarchy would be. So there will be project manager, then data analyst, then your data. This is how the hierarchy would be. Prerna, for the BA role, if you know the capabilities of the tools, if you know um, what can be achieved with these tools, what kind of uh, tools capabilities are, even if you're not going into much of the self implementation part, even if you know that, that is good enough to start with. But then the more you know, the better you become. Okay. So this is just to give you a context of where everything plays out. Now let's go back to the this course, and here we are talking about Tableau, and let's just understand what we are going to learn about learn in this course. So we are on the data visualization expert or BI developer, BI analyst. All of these are same thing. So we are within that role, we are learning this tool, right? We're learning Tableau for that purpose. So what are the outcomes for this project? What we are for this of this course? You will be able to use Tableau in your work. You will be able to apply Tableau's different types of visuals to analyze the data, different types of um, ways to present the data, okay, different types of interactions, filtering, data blending, all those detailed analysis parts. You will be able to create charts, dashboard stories, all those. But my focus would be here to understand the data insights. So whatever that we do, there needs to be some logical thinking, right? And there needs to be some critical thinking behind what why we are doing this, why it is better, why it is not, how we should be doing. So those kind of things we are going to consider. Okay, so along with the technical learning, we will also understand these parts. So these are some of the course outlines that we have. Now, data visualization. This is Tableau is very good when it comes to data visualization. It's very powerful. And data visualization is, as we have learned in Power BI as well, data visualization makes it easy for the end user to understand what the data is telling you, right? So I'll take couple of more minutes just to give you some feel for it, and then we'll begin to into the actual Tableau side of things. For example, these like if you have gone to historical sites, you will see these kind of carvings in the caves, right? All these depictions, right? So even before the languages were there, even before the scripts were there was data visualization, and this was a very powerful way of telling story. So these are just the some examples of in the like historical times, uh, people used to just put some visualization just to tell the next generation how what they have done, how they used to survive. So these kind of, you will see a lot of these kind of visualizations in historical sites. Like this is this telling you that how they used to hunt, so what kind of weapon they used to do, they used to have, right? All those things. There will be many other details that you will see when it comes to visualization in the ancient time, right? These, for example, these through visualizations, you will see even the people have shared what kind of culture they are coming from. So how they have festivities, how they have, how they hunt, how they, what they pet, how they communicate. There are a lot of things which are depicted through visualizations earlier. Okay, this is a famous visual for created by this artist called Minard Map. Minard was the artist and who has created this one map. And this is a visualization of how Napoleon's march, like how did it, the overall troop size, how they have reduced. So when they started off, there is a timeline to that. Then they started, they have taken some a route, and then as they marched to Moscow, they lost their fleet, they lost their troop in the midway, and you will see this is shown with this illustration. So this is the route that they had taken while they were marching, and this is the route that they have taken while they have come back. And from where how many people went, this is depicted by this. brownish color to how many people survived and came back is shown by this dark black color. So this just one simple visualization tells a lot of details. You don't need to really, this is itself is a story. It tells a lot of things, just one visualization. Okay. So there are many examples that you will find in this. For example, periodic table. Everyone, I believe, from their school days remember the periodic table. This is also a visualization, but see how the elements are put together in this visualization. Correct? Yes. Chemistry, everyone must have seen this. This is telling so many things. You are able to see all the elements that exist. Okay. Then based on their properties, based on their nature, they are created in such a way that it tells you a lot of details just by visualizing. So anything which is coming in this section, they are I think um, even I'm forgetting my chemistry lessons earlier. But you have your metals in the right, in the left hand section, right? You have um, even I'm forgetting. Uh, you used to have your inert gases, if you remember, right? You have your inert gases in the last column, which are non-reactive, right? So they are color coded in a different way. These do not react very well. Then these ones which are in the very left, they are the donors. They donate electrons to make bonds. These are the acceptors. They accept uh, uh, electrons to make bonds. So those kind of details are there, right? All those details are shown in the periodic table. And then you have other information like what is their atomic mass, what is their atomic, all these details, right? So this is also a visualization. And you'll see everywhere, a lot of places you will see the example of visualization. Okay. And Tableau is a great tool to visualize your data. What do we do essentially with the visualization? What exactly we do?
Now, the process of installing Tableau in your Windows. So if you're using Windows operating system, just open Google. And once you open Google, you just have to type install Tableau, and then you will have the following web page. So once you get into this web page, you just have to get yourself registered by adding your first name, last name, all the details, business or personal email. If you're working for an organization, you can add that, size of the company, department, job role, country, etc., phone number, and then you can download a free trial. Once you download the files, you just have to go through the installation procedures and you will be fully ready with your Tableau desktop, which looks something like this. Right, we already have some data here. You don't have to worry. We will restart Tableau and try to import our data freshly. So there you go. Once you get started with Tableau, this is the overview you will have. So Tableau basically has some open source data dashboards for your learning experience. So you also have some tabs here where you can get started with learning Tableau, and you also get some and explore some sample data sets and everything. Now we will be dealing with this particular one, get started with a data source. So Tableau is just like any other data visualization tool which can access data from anywhere. You can get connected yourself to a database, you can get connected yourself to a website, a social media platform, or anything. And if you want your data to be in Excel format, you can also get connected to a CSV or an Excel data file or anything, right? So if it is data, then you can access it. Now we will be dealing with the Excel files, right? So our sales data is present in this particular data set. So we have product data, delivery data, customers data, vendor data. So what I've did is I've combined all those into one complete workbook, which happens to be our sales combined. Let's have a quick overview of how it exactly looks like. So this is how our sales data looks like. The first tab, which happens to be the vendors tab, which is the person who is selling the product. So he has the order ID, order date, delivery date, traffic, leads, etc. Right? So before we have a quick walkthrough about this data, let's try to create a sample data, right? So we are making use of GPT here. So this is the prompt. So what we are writing is we want 4 datasets, each of 5,000 entries. So the 4 dataset names are vendor, customer, order, and delivery, right? So these are the data sets, and we are looking for these columns: order ID, order date, delivery date, traffic, leads, orders, revenue. And here we have another column. So you can see orders in all the 4 data tables. So there is a reason behind it. So this acts as a primary key which helps us to create a join or create a relationship between the other tables, right? And here if you see, we have order date and delivery date together. And here in the last table, last but one, delivery table, we have booking day and receipt day, right? So these are one and the same, but we are maintaining a different name because this will help us in understanding what exactly is data blending, right? Data blending is nothing but the same data in between 2 different tables, shared among 2 different tables, but with different column names. So sometimes if Tableau is able to understand what exactly is happening, then it will automatically establish a relationship between 2 different tables. But in case if it doesn't understand by reading the column name, in case if there is a different column name in different tables, then it might not establish that content or connection, right? So in such scenarios, you can have to go with the custom connection between 2 tables by linking the data columns. So in this case, we will link order date with booking day and delivery date with receipt date, right? And the last table is here. So which will be having product ID, product category, and quantity. So we're also adding some category names here and product names and quantity, right? So how many number of products have been ordered, right? And we are taking this data from a common man's POV, right? So we will quickly copy this prompt and we will drop it on the window of ChatGPT. So we are using a premium version here. So quickly we should be receiving the response. There you go. So we have 2 different responses here. And here you can select any one of those and quickly download in the form of CSV or as a workbook. So we have already downloaded that particular data set and we have clubbed them into one, right? So we have the same data and we have distributed them in 4 different sheets. So these are the ones. So we have every column that we gave into the prompt. And here you can see we have revenue and company. We did not calculate profit, which happens to be revenue minus cost to company, so that we can do this practically on Tableau to understand the calculated fields. Now that we have a brief understanding about our data set, now let's begin with creating storyboards on our Tableau. So there you go. I'll select the sales combined workbook and open it. And shortly we will be having the data set ready. So here we have it. Now, as you can see, we have 4 different data tables. Now to establish a data model or to establish a connection between 2 different columns or to join them, all you have to do is just drag the dataset here and leave it. And after that, whichever table you want to join with the first table, just drag and drop. There you go. You have the first connection. This particular pipeline or a string type connection is nothing but a connection between the 2 different data tables, right? They have established it. And now let's connect this again, this one here. So I think we drag delivery twice. Let's drag product. And the last one, which happens to be the delivery, not the vendor, right? There you go. So there you go. We have a quick, good connection. So Tableau has identified the data. So if we quickly go to the data vision sheet here. So initially we had a booking day and delivery day, receive day, right? So it has understood the format and it has mentioned it as a calendar format here. And order date and booking day are recognized as one and the same. And we have a proper connection established here. Right? Let's say I want to create a join between 2 tables. Let me quickly drag and drop all the tables here. Now, let's say I wanted to create a join. Now, you double click this particular table and now drag delivery here, and here you can see there is a join, an inner join. If you want to modify that, you can also modify that to a full join, full outer join, right join, and left join. And here we can see Tableau has automatically recognized on what basis it should create a join, which is order ID from the first customer table and order ID from the second table, which happens to be the delivery table, right? Now, we don't want to proceed with the join for this particular data set. We will just simply go ahead with data modeling. right? Let's quickly model the data back. I have customers data here, delivery data here, and product data here, and lastly, the vendor. There you go. Our data model is fully prepared now. Now what we can do is go back to sheet 1 and get started with creating storylines. Now let's say I want to identify the total sales based on regions. So what we can quickly do is you can add regions to columns. You can add order IDs to rows. There you go. So what we did is we quickly changed the aggregation of order ID so that it counts the total number of orders present in that particular region, right? So we have 4 different regions here. So it has calculated total orders that we received from all the different regions. So to improvise this, you can also add data tables or data labels. So what you can do is drag and drop order IDs to label, and here the aggregation can also do that. So that tooltip, you just have to add it to the tooltip. Measure should be sum. There you go. Now you have the count of orders from 4 different regions. And in case if you want to make it a little more colorful, you can also add region to color so that each and every region has a different color. So that's the first story that we made, a region-wise sales, so that you can understand which is the highest profit-making region in your country. So here I can see Northeast region is giving us the highest sale here, which happens to be 31,96,296 sales. Now let's create a new sheet, and now let's understand the sales based on category or product, right? Now let me add category to columns and the number of orders that we received based on those particular categories, and all numbers, and you might have to change the aggregation. So here it is, measure to sum, and you have the bar graph here. But in case if you don't want the bar graph, you choose to have something else than a bar graph, then you can go with the pie chart here, and here you can change the standard size to entire view, and you have it here. And just like we discussed before, you can add order ID to label and change the aggregation. Yeah, it already changed. Okay, yeah, there you have. So change the aggregation to sum or count, and you have the total number of orders from a different category. And if you want the category name also to be popped up, you can also add a category into the label. Now you can see we have medical category has so many number of orders, furniture has so many, auto parts have so many, and electronics has so many number of orders. And you can change the sheet name to category wise sales. Right now you can create a new story again. So since you're dealing with American states, so you can also do a state-wise sales report. So where you have the sales number, yeah, you have the sales detail here. You can add it to the columns, and number of orders. Or let's say we will go with traffic. Let's see which country has the highest number of traffic. Now, since we have, you can see that the state thing is visualized as geographic location. You can choose a map here, right? You can choose this type of map or this one. So this is one of the recommended ones. I'll go with this one. And it might take a little while to read the data and give us the numbers. And you can also add the state to text label here, and also some of the traffic. So it's okay, it might take a little while to reflect on this particular map. So that's how you do the statewide sales. And let's go through the dataset once again and see what kind of reports we can move ahead and create, right? Now we have a product reports here. Let's go with the product sales as well. You can drag and drop product to rows, and the leads and products here, and you can choose a map chart, tree map. There you go. So you can also add leads to label. Just drag and drop it here. And now you can see we have medical. Okay, we will also add category, right? Drag and drop, and you can add it to rows. to split the category in 4 different formats, or you can drag and drop categories into columns to make it look like this, right? Now you can see medical is the highest one, which is giving you the total highest number of leads. So you have 34,000 number of highest leads from medical category. In a total, it is more than about 65 or 67,000, right? That's how you can do it. Now let's keep it this way. Now we can term it as category wise sales. Right now, let's quickly create a new sheet. Now, as discussed, let's try to also venture into the calculated fields. Now, if you quickly take a look at the data, we have revenue, we have orders, leads, and everything. And we also have cost of the company and revenue. But if you closely observe, we don't have something called as profit, right? You might be spending around 10 rupees to buy a product and 15 rupees to sell it. So you made about 5 rupees of profit. Now, did you see the column named as profit here? No. How to create that new column header, which is termed as profit. Now, let's quickly double click this and double click this one as well. And go to table type appearance. Now you can see what's the cost and revenue. Now I wanted to create a new column which is termed as profit. Now click this particular option, which is a small arrow kind of thing. And here you can see a create option. Go to a field called as calculated field, right? Now we want this to be named as profit. And if you're unsure about the functionalities it is about to offer, you can have all this here, right? You can work with different data types. Let's say since we already have delivery date and order date, we don't know how many days it took to deliver the product. Let's say you wanted to find out the difference between the delivery date and the order date to know what are the number of days a particular vendor or a particular delivery guy is taking to deliver your product from your end to the customer. You can also do that, right? For now, we want to go with the number one, right? So here we have multiple options. You can go with max, minimum, power, radians, and you can also go with trigonometry things, everything, right? Now I want to calculate. You can access this using the small menu icon here, right? You can do that. So if you don't want, you can just quickly continue. Now here we want to do something called as sum of revenue. Here you have it. You can scroll and press tab minus sum of cost to company, and your formula is done. So in case if there are errors, it will say the calculation contains errors. So you might have the error over here. Closing parenthesis. Okay. Yeah, so we did not close the parenthesis to this one, right? This is because we manually typed it. But in case if you had taken the recommendations from Tableau, you could have got something like this, which already has a closing parenthesis over here. Now we want to subtract revenue minus cost to company, right? So again, scroll down and press tab to select, and there you go. Now the calculation is valid, as you can see here. And now you just press apply and okay anything, and you will have a new column called as profit. Now let's understand. Let's remove these both from here. Let's remove this one as well. Now we have a new sheet, fresh sheet. Now we want to identify which category, which vendor. Yeah, let's say we want to identify that one product which is giving us maximum profit. Now what you can do is you can take the product. Let's quickly check the data once. So here we have the product data. Now here we have category and product, right? So we want this particular one, the product, and want to find out which is that one single product which is giving us the maximum profits, right? Now let's go to the product table. Here we have the product. Select the product and drop it around the columns or rows wherever you want. And now we have recently created a new calculated field which happens to be the profit. Search for it. There you go. We have it here, and drop it right here. There you go. Now, if you would like to go with this particular one, which is bubble chart, you can also do that. And you can also have the aggregation of profit to the text label here and change aggregation to sum. There you go. We already have the table here. So you can see tablets and syrups. As we have this here category by sales, so the category was tablets instead of the medical category was the highest selling one. So here obviously we have the highest selling ones are these two ones, right? And something from furniture is not performing well, right? So here we have it, 48,000 happens to be the least one, and so on. Right now, let's quickly do it. Product wise profit. So far, so good. So we have about 4 to 5 sheets, and now we can quickly go with a dashboard with some KPIs. Okay. Now what you can do is just quickly drag and drop those sheets onto your dashboard and make some adjustments to it. You can close show me, and here you can choose standard and the size of your dashboard. You can also program or make your dashboard such a way that it can be visible in phone as well. I don't want the phone now. I want to go with the default one. And here you have size of the canvas. You can increase the width and height of your canvas or decrease it. There you go. So far, we have installed region-wise sale. You can also, change the size of your charts here. Drag and drop state-wise sales, and you can drag and drop category-wise sales, product-wise profits as well. So there you go. So after making some adjustments, right, in the width-wise or the length-wise, you can adjust the dashboard. And one thing which is missing here is the KPIs. So we created a new sheet here and added a KPI termed as leads. Similarly, add another sheet, and this will be your revenue. Add revenue to rows or columns, and you can choose a table here, just like we did before. And you can add to tooltip, and similarly, you can add orders and graphics as well. And this will be named as orders. This will be named as traffic. So drag and drop traffic to the rows or columns, select table, and add traffic to tooltip. Similarly, orders, drag and drop orders to rows, and this should be a card, and orders to tooltip. There you go. Again, we will go to dashboard, and here you can drag and drop the cards that you recently created. So I want the leads to be here. Don't worry, we can adjust the cards. There you go. So after making few adjustments to the title, we can get the last one, apply. This particular one as well, let's keep it as 10 so that the numbers are visible. And lastly, this one. So you have the KPIs, region-wise sales, state-wise sales, product-wise sales, category-wise, and product-wise as well. So this was supposed to be product-wise sales. Here we have product-wise and category-wise, both, not a problem. And here you have, if you close the show me icon, so here we have the filters and slicers. So in case if you wanted to check for the sales happening in only Mid-East from category of chairs and product chairs and the category as furniture, there you go. So you have the total information on that front, and if you can just quickly release all the filters, you have that. And if you wanted to know the sales of dining table, here you have it with all the related information to that particular item. So that's how you create a completely interactive dashboard in Tableau.
Okay, so everyone, please go ahead and download Tableau Public. I've shared the link here. Once you land on this link, it'll ask for some details, right? This details you need to put in. Okay, just mention these details. It does not matter if those are accurate, exactly accurate. Like like your role, you can put any role like student. You can put your location. Just put all these details and start downloading. Let me know once you have downloaded. Installation is very straightforward. Don't do anything customized, just do the standard installation. Okay. So I'll allow you to do this part and let me know everyone. I want everyone to give me a confirmation once this Tableau Public is downloaded and installed on your machine. All right. So when you open Tableau Public here, it'll open like this. You will be able to see a screen, right? So at the center, you will have, currently it will be all blank for you. But for my case, it is showing some of the recent files that I had worked on. You have some section at the right hand side, some uh, links, some tutorials, some other favorites, some other links available over here. Then you have the data connection options at the left. Okay, so in Tableau Public, you have these file type connection options. So you can connect to the Excel, text, JSON, CSV, um, Access file, those kind of files you can connect to. And then you can connect to some servers like OData that we have seen, and only these Google Drive. These are the only connections that are available in Tableau Public. With Tableau Desktop, if you are working on Tableau Desktop, all this entire area would be filled with all sorts of data connections. So there are many data connections available. With Tableau Public, you would be able to see all. With Tableau Desktop, you will be able to see all those. Okay, here, all different types of data connections. You can connect to all types of databases, some systems, some other types of platforms that you can connect to. Okay, so to connect to any data, we can just use these connect option. So from the data sets that you have downloaded, there will be a file called Global Superstore Data. Can you all see that Global Superstore Excel file in the downloaded data? And in the in-class data sets, you should be able to see, sorry, there is the file name is Sample Superstore Data. Sample Superstore Data. Okay. So we'll connect to this global sample superstore data here from with Tableau Public. So what you need to do is, this is an Excel type data file. So you connect, click on Microsoft Excel connector. Okay, go to Microsoft Excel connector. Then you search for this file and click OK. When you connect to the data here, you will be navigated to this screen. Okay, this is where you are able to see all the tables. So within this sample superstore, you will be able to see all the underlying sheets as separate tables. Okay, so you can see these sheets over here. Okay, you have these sheets. Okay, all these are coming from this one connection. Okay, so this is the connection that you have made. Within that connection, all the sheets, if you're connecting to a database, it will show all the tables which are available there. If you're connecting to a file, it will show all the sheets which are there. Okay. Now, whichever table that you need to analyze here, you can simply drag that table, select, drag, and drop it on this section. Okay. Drag orders, for example, drag orders and put it in this section. Just drag and drop it over here. Okay. Drag and drop it over here. Now let's see what all is there, what is all of these sections. Let's just segregate and understand these sections, what are there. So here, this pane is your connections pane. This is connections. Then this is your, this section is also called as the logical phase Okay, this is your logical phase. You call it logical phase or your logical layer. Logical layer. Okay. Then whatever data that is there inside this table, you can see the preview of that data in this section. So there is this data preview. Okay. Let me pull this slightly up. This is the data preview. Okay. This is the data preview. In this data preview, you are able to see all the columns that are there. Okay. So you have the column name. Okay. Column name, all the column preview values. Okay. So not the complete data, but just the preview. And it shows you at the top that how many rows you are seeing in this preview. So currently 100 rows are being displayed. Okay. If you want to increase more, you can do so. But at the moment, these are showing 100 rows of your data, top 100 rows. Okay. Here we can see the column name and we can also see what the data type of the column is. So you have the column name and you can see the data type. How can you see the data type? You see these symbols, these icons. This is telling you what the data type of this column is. So data type hash means that this is a number data type. Hash is a symbol for number. ABC stands for text. So if there is a text data type similar to Power Query, if you remember, Power Query we had ABC 1 2 3, right? So ABC denotes text. This calendar like icon, this denotes date. This is a date data. Ship date, this is also a date, and so on. If you want to change the data type, you have this small drop down next to this. Okay, sorry. If you have to change the data type, you can click directly over here, not the drop down, but you click over here. So you can see all the different data types that exist. So number, whole number, decimal, date, date time, string, boolean, those kind of data types. If you ever want to change the data type, you can do it from here. Below the data type, you can see the table name. So these all, everything is coming from the orders table. So the table name. And below the table name, you have the column names. Okay. So you can see the data preview. Then next to this data preview, there is this metadata section. Metadata. This section is called metadata. Metadata. Okay. So metadata is, yes, this is data about data, which means whatever data that you have, some information about that. So some basic information like not actually going into the data level, like the actual data values that you have in the table, but just the overview of your data, like what is the name of the table, what is the name of the fields, what are the data type of those fields, whether this exists on the physical layer or not. So it says that this is physical, as we see, logical, sorry, this is logical layer, but this is physical table. So we have actually added this table. So this is the physical table. Then there are remote fields. So remote fields is if you are adding any other aliases to their field names, some other names, then that kind of data is added. So basically your table name, your data, all the column names, the data type of the column, those kind of information is your metadata. Okay. So that information is available over here. Okay. Okay. Your connection interface. This is how it looks like. Let's say now you are okay with what data you have and now you want to analyze this data. You want to start analyzing the data. Okay. So in analyzing the data, you can go to here, you see, go to worksheet. So here in Tableau, we have the concept of worksheets. So to do any analysis, you need to go to worksheets and then start analyzing the data. Okay, it says that go to the worksheet. Currently, this is the data source uh, view that we have. If you click on this sheet one, okay, this will take you to the worksheet. Okay, this is your worksheet. In the worksheet, you do the data analysis part. Okay, so here the data analysis would happen. Exact. Okay, we'll deep dive into the worksheet part. But before going to the worksheet, let me show you just a few features that you can use while you are in the data source page. So we'll come to the worksheet later. Now let's get back to the data source. What all we can do here. Now let's say I want to look at this data preview, and in the data preview, I want to just see whether I need to use any columns or remove the columns. So I want to see this in more, like I want to see more of this data. I can just collapse this metadata part. So just this small arrow, just collapse this. And now you have this table details, right? Or the data preview. Okay. Now in this data preview, uh, here I can choose if I want to hide or unhide any columns. Okay. So whatever columns that you're keeping here, that will be visible in your worksheet view. So if you go to the worksheet view once again, table columns, all the columns are displayed over here in the left. Okay, you will be able to see all the columns over here. Now let's say that you don't want some of the columns to be visible over here. Those are not required, not will not be used. Then you can simply go and hide those. In Tableau, we cannot delete the columns. That is a drawback. Okay, so if your table is containing that column, like we have in Power BI, the good part about Power BI is that you have Power Query where you can delete anything that you do not require and only those data gets loaded. But here we cannot delete them, but we can hide anything if we don't want. Okay, that you can do. So any column, if you want to hide, you have this small arrows. Let's say I don't want to see let's say I'm not interested in looking into this uh, postal code or region column. Those I do not really require. Okay, so I can go ahead and from this small arrow, I can click on hide. Okay, postal code. Let's say I'm hiding the postal code. Okay, now postal code is gone here. It is hidden. Remember, it is hidden. It is not deleted. It is not deleted. It is just hidden. If I now go to the sheet, okay, sheet, now here I no longer have the postal code column. It's not deleted, but it is hidden. Okay, I can hide multiple columns here, but if I want to bring them back, if I need to bring it back, if I need to see all the hidden columns, I need to go to this setting, this gear icon over here. You see the gear icon, click on the gear icon, and here you have the option of show hidden fields. Okay, you can click on show hidden field. It will bring back the postal code. But you see, after unhiding that field, it is still coming in this gray text. So this is grayed out. This is still not fully unhidden. Okay. If you still go to the sheet, this will still not be visible. Okay, it will not be visible. Okay. To completely unhide it, you need to from that column once again in this drop down, you need to once again click on unhide. Okay. If you click on it unhide once again over here in the column, then this become completely unhidden in the worksheets. So when it comes to unhiding, you can show the hidden field on this table view, but those will still be hidden in the worksheet. But if you want this to be visible on the worksheet as well, then you once again unhide it in this column properties. Okay, now if I go to the sheet, I'll be able to see the postal code. Okay, this field is available here. So remember, hiding is a one-step process. Just one button, hiding, click and hide. This is one step. Okay, but unhiding requires two step. Okay, this is okay. There seems to be some glitch. When you hide it directly from here, it should just be removed here, but it is maybe storing it in the cache. Okay, anyways, you can unhide and hide the values like this. Please check at your end. Let me know if you have any question. This should be quite straightforward. Okay, so you can hide and hide. Now, if you want, let's say you want to give a alias name to your fields. Okay, you want to give some aliases. You can also go and you can give rename and you can give the aliases. Okay. For example, if I need to rename this over here, postal, let's say I change this postal code. Okay, just double click over here. Let's say I change it to instead of postal code, I change it to the zip code. Let's say I give this name. Okay, postal code now updated to zip code. Okay, this is now updated to zip code here. If I go to the table, if I go to the worksheet, I would be able to see zip code now, the new renamed column. So double click and you can see the, and if let's say you have renamed multiple columns and you want to see what all columns were renamed, you can go to collapse this table view and see the metadata. Okay, you can see the metadata. In the metadata, you will be able to grab this information. So you see now, this tells you if anything is renamed. So now you can see this field, the field name is zip code, but the remote field, the original field was actually postal code, which we have now renamed to zip code. So you can track this. If anything is renamed, you can see those details over here in the metadata. Okay. Puram, no. So be it any BI tool, if you are using the data, if you're connecting, it does not writes back the data into the source machine, source data source level. It only reads the data. So we are just reading the data from the sources, not writing. Okay. So even all the name changes, data value changes, all the aliases changes, everything that happens in this layer after reading the data. Okay. That is happening only in the Tableau level. So we can change the column names. We can also change these values. So let's say we have these columns now. If I need to give some other names to the values, I can change the aliases. Okay. So for example, you have these regions and you want to change the aliases. If you want to give some other names, let's say you can go to aliases. In aliases, you will be able to see these actual member values. So the unique distinct values that you have in the column. And if you want to give some other name to this, you can give the aliases to those. You can double click on this and you can give the aliases, some other name to those. Okay, so you can change some values. Like this is similar to how we have the replace all, replace values feature in Power Query. You can give different aliases. It's called aliases in Tableau. Okay, for any column, if you want to see more details, okay, I'll cover the aliases as again. Let's say you want to give a specific type of naming to your data. You want to update the data. For example, you have these categories. Now you have categories like furniture, office supplies, and technology. If you go, you can check the aliases. Okay. Or Before we go to the aliases, let me explain you one more thing, then we'll come back to the aliases. You can actually, if you want to see more details about your column, you can go to describe. Okay, go to describe. It will basically give you more information about your field. Okay, so what is the name of the field? Some details over here we'll cover. But here, basically, it shows you in this field, these are the distinct values that you have: furniture, office supply, technology. Now, if you think that, okay, it's one of the field name needs to be updated everywhere. Let's say you want office supplies to be changed to a name called office goods. Let's say you want to rename this to this everywhere. Instead of supply, there will be office goods, right? So if you want to do that, you can go to aliases, and where it is office supplies, just rename it to just type office goods. Okay, now you have given an alias to the office supplies. And wherever you have this S star symbol, this means that aliases has been given. Okay, I have given an alias. Now I can like, okay, now this alias has been given. Now you see you have office goods, furniture, and technology. Like I have just renamed this field value. Okay, on this setting, you can also see that you have some sorting options. You can sort the data, uh, any columns, sorting order in the ascending order, descending order, those kind of sorting you can do. Okay, but that is typically no is not done. So you don't do the field sorting like this. There's no need for that. Okay. So for example, just to cover this field sorting, let's say you want to sort the fields in the A to Z order. Let's say I did it like this. So now all these field names, now you see that anything starting with A comes first, then B, C. So it'll come in the sorted order of the field names. Okay. This will help you find the fields easily. That way it can be helpful. So once when it is sorted, if you go to the sheet, if you need to like work on anything, you know if anything is starting with T or X or W, it'll most likely be at the bottom, right? Anything starting with A to A, B, C, D, that'll be at the top. So just finding them would be easy if it is sorted. Okay, that way it is helpful. About the this hiding and hiding part. So one thing that why you were seeing that the hidden fields were visible second time, because this show hidden fields was actually checked, right? So show hidden fields were actually checked. That's why it was appearing. So if you uncheck this, then once you try to hide it, it will not show. Okay, so it's not like first time it will show, second time it will not show. Okay, for example, if I remove the show hidden field, now if I try to hide discount, it will be hidden. It will be hidden. It will not show up. Okay, you need to once again show hidden field, then unhide. Next time, if you once again deselect this and you try to hide this, it'll be removed. In Tableau, you don't have a lot of data cleaning and data transformation features like you have in Power Query, right? In Power Query, you can do a lot of things. In Tableau, directly in Tableau desktop, you don't get that feature. There is a separate tool of Tableau, which is called Tableau Prep. That is like that tool did not pan out that much because that's a separate tool. It does not come as a built-in add-in in Tableau. So that's why I did not picked up that much. But there is a separate tool called Tableau Data Prep or Tableau Prep. Okay, that has much more features of data cleaning and data transformation. And some I haven't seen many organizations using it, because if you're using a second tool, then maybe it's better that you do it at the data source level. You can do that cleaning and transformation. Okay, but here you have very basic things like you can do this column splitting part, some of these parts. For example, this customer ID, here you have a feature called you can do a column split. So if you want to do a split, you can create a just do a split or a custom split. For example, here you have a delimiter, right? So you have the customer name, the first name and the last name initials are here, and there is an unique customer number splitted by the delimiter. You can simply click on split and it will automatically identify the delimiter and it will split the column into these two columns. The customer first name initials, first and the last name initials, and the customer name. It automatically identified this. Okay. So wherever there is a clear delimiter that you know that should be uh, separated, there is only one delimiter, then it will automatically do this, right? That is feasible. Otherwise, you can also go for a custom split. So when custom split, you go to custom split, you specify what the separator is wha- from which separator do we separate all the instances or first or the last. You can do all those. So you can define more customized way of splitting the column with this custom split. Okay. The fields which are calculated. So even though we are doing some transformation, but whatever field which are calculated, you will be able to see the that indication over here. So any field which is an output of a calculation, you will be able to see this a calculation text next to it. Okay, this way you can identify anything which is a calculation. Okay, although we are doing a just one button based split option, but actually there was a calculation that has happened and that calculation resulted into this output. Okay, so how do we know any field which is a calculation? There are two ways with which you can know. One is it will have this text calculation, number one. Number two, even the data type that you have, the data type will have this equal to symbol, and after the equal to symbol, you will have the data type. So whenever you have equal to symbol and then the data type, it means that this is a calculation, and after the calculation, the data type is given to this. Okay, equal to and then ABC123 or equal to then hash. Okay, this is the calculation. This is how we can see the calculation. If you go to the worksheet where the data is visible for you to analyze, even there you will be able to see this field with this data types and equal to and data types. So from here as well, here the calculation word is not written, but just by looking at this, you will be able to identify that there is a calculation. Okay. Now for anything which is calculated, those can be deleted. So I can go and delete those. Anything which is a calculation that can be deleted. Anything which is coming native from the table will not be deleted. So these can be deleted. Okay, now these calculation are deleted. So how did we do this? Let me repeat once again since you are asking. You go to this option, you have the option of split. Just do direct split. You do a split, it will identify some delimiter on its own and it will split the values. So it identify this dash as the delimiter over here and split it. You can rename these column names as well, right? We learned this. Okay, so see, for you, when you are splitting it, it is coming at the end. So this is because you have not, I have done this data sorting. You remember on this setting, I chose the data to always be column to always show in this order A to Z. Okay, since your data is not in the any order, that's why it is coming at the end. Any new column is coming at the end. So change this to the A to Z sorting, A to Z descending or ascending sorting. Then it will come next to it because the initials would be same alphabets. So it will come next to it. Okay, if you have created, even if you have created multiple columns, everyone, you can just select multiple columns and delete those. Okay, just select multiple columns and delete. So all these calculated columns will be coming at the end, right? So you can just do a control and click. This will select all the columns. Make sure that you are selecting only the calculated columns, not the existing one. Once you select multiple calculated column, right click on the column and click on delete. It will delete those additional columns. So this split is very simple. This is one button click, right? Just a button click, split button. It will just create new column with this calculation. Okay, so there is a calculation which is going behind these new columns. And we're going to learn more about creating new calculations later. But there is a calculation which is happening and we can edit those, modify those calculations. There is option. So if you just want to see what is that calculation, you can go to this and you can go to edit. If you go to edit, it will actually show you what exactly the calculation was to do this step. So this is the calculation which is happening. So there are this trim function, split function, all those are being used for this automated step to happen. Okay, so you can do edit those. Here, like in Power BI, Power Query, we have the merge columns option as well. But here directly, we don't have that option directly in the columns to merge multiple columns. We can split, but merging directly is not possible. For that, you need to write a merge formula, which will merge the columns, multiple columns into one column. Okay, that you cannot do. Calculation, again, calculation is if you want to create a new calculation using the existing fields, those are called calculation. Okay, so calculation would require you need to write a formula and then whatever formula driven new values are coming, those are calculations. Okay, in Power BI, if you need to understand this, we used to use DAX for the calculations, or in Power Query as well, we have the calculation feature, right? Where we can create new column, new measure, right? Those kind of things. Here we don't have that distinction that create new column, create new measure. Those kind of segregation is not there in Tableau. It's just a new calculation, new field calculation. That's all. Okay, new field calculation. Okay, now let's go back. I'll just delete these new calculations, column split, and now we'll just take a look at the window in the worksheet and what exactly do we have in the worksheet and what all different sections are there, what do we do everywhere. Okay, so first let's open the worksheet, go to the sheet 1 over here. This will open the worksheet. This is called worksheet or sheet here, as you can see. Okay, now what do we have here? There are many options, so let's just call out these options. What do we have here? So we have at the very top, we have this menu section. This is called your menus or drop down menus. Okay, drop down menu. Then you have a pane here in the left hand section. This is called your pane. You have your pane, and this is called your pane. Okay, pane. Within the pane, there are two types of pane. One is the data pane that we are looking at. Data pane would show you all the fields, all the fields that you have. If you have multiple tables, it will show all the fields for the multiple tables. And then you also have an analytics pane, which is which helps in the visualization part. We'll cover the analytics pane later. We'll mostly deal with the data pane here. So this is your pane section. Then you can see uh, this section with the different, let's say, first of all, this section, let's call it the canvas. This is your canvas. Similar to the canvas we have in Power BI in the report view. So whatever that we build, whatever visuals we build, we can have one canvas. Everything will be built over here. Here, remember in Power BI, we have a big canvas, and within a canvas, we can have multiple visuals. In the in Tableau, per worksheet, we can have only one visual. Okay. Remember, one visual per sheet. In Tableau, you can have only one visual per sheet. Okay. You cannot have more than that. Then you have your rows and column shelf over here. So whatever that you visualize, there is the concept of rows and columns that will come into play. Whatever is in rows and columns, that will come into play. And this is called your rows in the column shelf. Row, column, shelf. Then you have your cards, which will help you build the visual. This is called your card pane, where you have this marks written. This is called card or marks card. Marks card. This helps you in creating your visualizations, customizing your visualizations. So different types of markings that you can use. You can use different coloring options, size, details, text, all those, which we are going to learn in detail how we can help those. Then you have some other shelf. You have a filter shelf. Filter shelf. So any filters you need to apply to your visual, this is applied through filter shelf. There is a page shelf. Okay. So if you want to apply any kind of navigation that you can apply through page shelf, we will cover this as well. Page shelf. Okay. Then at the bottom, you can see this sheet, right? So we can create new sheets. So at the bottom, you'll see very small few icons at the bottom. Okay. Very small icons. So there are three icons over here. If you hover over on those icons, you will be able to see what they mean. Okay. If you hover over, there is a new worksheet, new dashboard, and new story. Okay. So just if you hover over, you will be able to see. So there is a new sheet. If you want to create a new sheet, if you want to create a new dashboard, and we'll cover what dashboard is. Okay. This is to create new dashboard. And finally, you have a new story. So if you want to create a new story, so that will be over here. I'll tell you what is the difference between sheet, dashboard, story later on, but you can see all these. And then here at the bottom, you can have the data source. We have been seeing this. We can go back to the data source as we require. Okay. There are two more sections which we left, which are left over here. One is you can see a quick access toolbar. Quick access toolbar. So some quick actions that you can apply, like sorting, labeling, pinning, uh, changing the view mode. So there is this quick access toolbar. So you have some quick access tools over here in this quick access toolbar. And then you have this one more thing which is called the show me button. Okay, the show me actually, if you expand this, this will show you all the possible charts that are present in Tableau. So there are 24 these charts over here, 24 charts. You will be able to see those 24 charts over here in the show me panel. Show me panel lets you create the visuals easily. So it gives you some initially some help in creating the visualizations. Okay, so you can use show me panel just to create the visualizations a bit easily. So this is your show me panel. Okay, so these are all the different navigation options over here. Let me just take a screen grab. Right, so you have this worksheet, or let me write interface. This is your worksheet interface. Okay, now let's go back and understand the data a bit more. Okay, so now here, when it comes to the data part, there are these uh, two categories in which your data is. If you see here in the tables, under the table, you are able to see all the fields over here, right? All the fields. Okay. When you go to these fields, you will be able to see two types of fields here. One is your categorical fields, and other is your measures. Okay. So there are this concept of dimensions and measures. Okay. So dimensions and measures. So here, if you see, you have the all these fields, and you will see that there are this some of these fields, and after the fields you will see that there is a very dim gray line between some of the fields. Do you see that gray line? After some field there will be this gray line, right? You can see that gray line. That gray line basically indicates which of the fields needs to be treated as the dimensions and which fields needs to be treated as measures. Okay. Okay, or in short, which fields needs to be shown in the form of aggregated result, and which fields needs to be shown in the don't summarized form, as we saw in Power BI. Okay, so anything that remains as the dimension at the top, okay, those will be displayed without doing any aggregation. Measures, the nature of measure is that measure should always be shown with some kind of aggregation. It will be sum of values or count of values, or uh, minimum of something, maximum or average of something. So measures, so everything that is below this gray line is going to be shown in the form of measures, which means aggregated result. Okay, it will always show the aggregated result. Everything which is above this gray line will show non-aggregated result, which cannot be summarized, which cannot be some, like the category name, city name, country name, all of those. Now, if we look at the data, if we look at the data, and if we see the, let's say this zip code field, although this zip code field has the numeric data, right? Some numbers are there. I can I can choose it to be a numeric field as well, although this is selected as a geographical field. But if I change it to the numeric field, let's say I keep it in the numeric field, then should I keep them as the dimension or in the measure section? Should it be in the dimension section or the measure section? Would you be taking the sum of all the zip code values or the postal code values, right? You will not do it. Even any data which is numeric can still be considered as a dimension, not as a measure. Okay. So you may have non-numeric data, numeric data as the dimension too. Another example of this is a row ID, right? Row ID, this is a numeric data. If you see this is a numeric data, row ID, right? 1, 2, 3, 4, 5, 6. This is a whole number. Yet this is coming in the dimension because I don't want to aggregate it. Now, is it possible if I want to change the natural behavior of this? So whenever when I'm going to visualize this aggregations, this kind of things would come into play that automatically results will be shown in the aggregated form or non-aggregated form. Those will come in. Okay. But if I want to change any of the fields from dimension to measure, measure to dimension, I can do so. I can just simply drag the fields and drop it in the measure sections. You see, as I drag it, and if I go up below, or if I cross that gray line, I get this hovered values, whether you want to keep them under dimensions or under measures. So if I put row ID into measures, drag and drop it over here, it will be dragged and dropped. It will be present. But when I'm going to use it in any of the um visual, let's say if I use it in this visual, it will show the sum of the value. Okay, it will show the sum of the value automatically because now I have converted this into a measure, which is not its natural behavior. That is not how it should be used. So let me delete it. Okay, I didn't want to go to this point right now to show the value, but I wanted to explain this. So row ID, it should be a dimension. So I'll once again drag and put it under the dimension section. Okay, so data. Data will be of two categories here broadly. So there is dimensions and then there are measures. Dimensions are categorical fields, okay, or non-aggregated, which should not be aggregated. There should be a individual value needs to be displayed. Okay, while measures are aggregated quantitative fields. Okay, this will be fields to display aggregated values. Okay, any fields which is to be used to display aggregated values. That will be a measure. Okay. Okay, this part is clear. What is a dimension and what is a measure? So your data would be divided into two parts, dimensions and measures. Okay. Now let's let's understand how we can create any visual over here. So here you have this um, okay, before we go into that as well, there is also this colors which indicate what is a dimension and uh, what is a measure. Okay, so if you see Whenever I'm selecting any fields over here, you see the color of that is appearing over here. So here, if you see, if I'm selecting this, this is all coming in the blue color, correct? If I select any of the fields over here, see the color of this, these are all coming in the green color. Okay. So this is also a distinction that you can identify whether you are selecting a dimension or whether you are selecting a measure. Okay. Blue will be dimensions, green will be measures. Green pills, sorry, blue pills, green pills. Why I'm calling it pills? It looks like a pill, right? The shape looks like a pill. So blue pill is your dimension and green pill are your measures. Okay. To visualize data, you have to use these shelves. Okay. You have to use these shelves. So we have the column shelf and we have the row shelf over here. Okay. Now this row and column, this basically this tells you how the data will populate once you select the fields in the row or the column shelf. So as next to this column and rows, you can see this lines. So in the column, you see these vertical three lines, and in the rows, you see the horizontal three lines, right? You are able to see those lines, these lines, everyone. Okay. So what these lines indicate, horizontal and vertical, is that whenever you are going to add anything in the column shelf, right? Data will be read like this. Columns are created when you have the columns. Data will be read like this, in this way, vertical. Any field that you put in the column, they will be appearing like this. But like I'm giving you a bar example, but they are, let's say if I put the region in the columns, they will come in separate region in this column wise. Okay. Anything that you keep in the rows that will appear in the row wise. So if you keep anything in the row shelf, this will appear like this. You will have the data coming in this order, rows wise. Okay, let me show that to you. Once we select fields, it will be clearer. Let's say I want to show the sales by category. Okay, I want to show sales by category. Okay, so what I will do in sales by category, I want to see my categories in the columns. Or let me keep my categories in the rows. Let's do it that way. So what I'm going to do, categories in rows, category, drag and drop it in the row shelf. Okay, you see categories, as soon as you add it in the row shelf, your values are appearing in the row wise order. Okay, if you had selected this in the column, the values would have appeared in separate columns. So each of the category is coming in one column. When you select rows, these are coming in the rows. Okay, now I have just added the category name, and just against this ABC is coming. So this ABC does not mean anything. It is an indication that I'm trying to create a table over here. This ABC does not represent anything else. It's just that I'm trying to create a table. But I want to show sales by category. Sales by category. So pick the sales measure and drag and drop it onto the columns shelf. Okay. Can you do, all of you do that and tell me if you're able to see the visual like this? Now here I am able to see these three categories and their sales values. Now currently this is showing very, yes Neha, those are x-axis, y-axis, those are symbol for x-axis, y-axis, similar to that. Now, currently, I am able to see my data in this view, right? Now I want to see this table showing in the entire view. I want to use the entire view of my sheet, entire canvas to view this. So at the top in the standard selection view mode, change the view mode to entire view. Switch it to entire view and you will be able to see the visual covering the full view. Okay. Now at the moment, I'm able to see the sales for each of the category, but wouldn't it be easier if I keep my data sorted? Wouldn't it be easier for me to understand which is the highest, although there are only three categories, so I can say that quite easily that technology has the highest sales, then furniture, and then office goods. But if this data were in sorted order, it would be even better, right? So we can always sort this, and in the quick access toolbar, you have this sorting shortcuts over here. So this first one will sort it in the ascending order. We want it to be sorted in the descending order. So the highest value at the top and then lowest at the bottom. So select this option and view the data in the sorted order. Okay. So click on this button, sort order. Now I also want to see the values on these bars. I want to also see the data labels. Okay. So it would be easier to know the exact sales values if I know this data labels to appear. So if you click on this part, there is this quick access option of turning the data label. Click on this and see whether you are able to see the value of the sales on the bar. Okay. So we can turn on the data label. Okay. Now, these are the some standard things that you should always do whenever you are visualizing anything, which is adding the data labels. Secondly, sorting the results. Whenever you are showing any kind of data, always show the data in the sorted manner. Okay, always give these data labels wherever feasible. That will help you view the numbers easily, compare the data easily. And finally, you should always give title to your visual. Whenever there is a visual, you always give a title. So for giving the visual title, you have this title actually at the top. This sheet one, this is the title. So what happens in Tableau is whatever title that you give to your sheet at the bottom, that title automatically becomes your chart title too. Okay. So if I go here at the bottom in the sheet, I rename it to, let's say, sales by category. Okay. Automatically at the top, my title also changes to sales by category. If I want to further format my title, I want to make it bold, I want to change the color of this, then you double click on this title and you get this edit title option. So currently this is coming as a parameter. So there is a parameter of sheet name. So it will by default sheet name parameter is taken as the name of the title. That's why automatically the sheet name is coming. If you want to increase the font size, if you want to change, make it bold, if you want to change the color of this, you can do all these kind of formatting in the edit title. Okay, I'll leave it to this the moment and let's create another sheet. Okay, so let's create another sheet and this time just click on the new sheet. It'll open a new sheet over here. Click on new worksheet. You will get sheet 2. Okay. In this sheet, I want to analyze my data over time. Okay. I want to analyze my data over time. So I want to see what my monthly sales are looking like. Okay. what my monthly sales are looking like. So when it comes to the monthly sales you want to look at, now at the moment you have order date. This is one date field. Now you don't need to create a separate field for year or separate field for month. That is not required. Just you can always use the date field, and with the date fields you can simply you can convert them to be shown to be converted into year, month, quarter, all those things. So simply select order date and drag it onto the column shelf. Drag and drop it on the column shelf. Okay, so by default, this dates are aggregated at the year level. Okay, dates are aggregated at the year level. Okay, now if I want to see sales by this, I can drag sales into the rows and I get data like this. This chart automatically becomes based on the automatic design of Tableau. We can always change the chart type if we want to see some other visual. Okay, this chart is nothing but, or this line or this is nothing but this is called your mark. So whatever visual that you see, what marking of that visual would be. So here the marking is, if you see here, marks, and this is the automatic, this is converted into line. If I want it to be changed to a bar, I can go to the mark and I can change it to bar. It will show the marking in the form of bar. If I want to change it to something else, let's say some uh, area, circle, text, I can do all these different types of marking, right? Area, I can make it area, but let it be the automatic line chart that is coming right now. Okay, so this is coming in the line. Now, if I need to understand the insight from this chart, what can I say? So from the previous sales by category, we can see that technology is the highest selling category. But if we look at the sales over time, we can make an inference that the 2016 and 2017 having the highest sales, your sales are increasing, right? Now, in this year, like currently this data is shown in the year level, and we have this hierarchy automatically coming here as well. If I click on this plus button, it will then break my data down into within each year, I'm getting the data by each quarter. So if I click on this plus icon, I go to the quarter level, and now I can compare each quarter of each year. Okay, now I can compare each quarter of each year. So I'm able to see year wise as well as quarter wise. If I click on plus again, I will be able to compare one more detail. It will be quarter, and within that quarter, all the months. But when I have data like this, it becomes too difficult to analyze because of these broken lines. Okay, this is coming in the broken line. So what we will do here is, one is that we can choose at what level we want to see the dates, be it at the year level, quarter level, or month level. And we can choose whether we want to show them as the continuous value. So what I'll do here is I will remove these, go and remove, go and remove this year and the order date that we have. If I go to this small drop down, I can choose at what level I want to show my data. Okay, so I want to show my data here. You have these different types of date parts in which you can show like years or quarters or months or day. So there are these two sections over here. One is your discrete section. Discrete section means if I choose quarters wise, let's say I want to show the data by quarter. If I choose this upper section, then it will just show discretely how many quarters do I have in my data. Okay, what does it mean? Discrete means that whatever unique quarters that I have in the dates, those will be shown, or the distinct quarters that I have, those will be shown. Now you can have any amount of historical data. There are only 4 quarters, right? Q1, Q2, Q3, Q4. The years would be different for those quarters, but if we just consider quarters, there will always be 4 quarters. So if we go with this discrete option, it will show, combine all quarters of all the years into, like each quarter of all the years into that quarter. So Q2 of all the years will be combined together. Q1 of all the years will be combined together. So if I want to see some seasonality based analysis, like, okay, I want to see over the years how my Q1 has performed versus Q2 versus Q3, Q4, that you can do. But normally you don't do it like this. You don't make it discrete, but you want to see them as continuous. So below this line, you can still have this year, quarter, month, and these options, but these will be continuous. So if I select quarter over here in this, it will show the continuous values, means it will show for each year all the quarters. Okay. So 21, 2014, quarter one, quarter two, quarter three, and all the years are being shown here. Okay. So you have this discrete and you have this continuous. Okay. Also remember, when you show the data in continuous, then this field also, this turns green. So measures as well as the continuous data are shown in the green pill. Discrete, if I had this discrete, this will be coming in the blue. So dimensions or the discrete values will be in blue, continuous will be in green. Okay. Now what is your inference from this? Okay. 2017 Q4 has the highest sales. Okay. There is a pattern, there is a trend that you can see. Whenever we analyze data over time, over dates, we always look at some trend, whether the data is following some trend, some seasonality, some patterns are there. So Q4 always becomes your highest in all the years across all the quarters. Q4 is where the sales become highest. So in this business, there would be, now you, if you know which data you are analyzing, which type of business they are into, what kind of uh, uh, sales channels do they have. If you know some more information about those, then you will be able to correlate this more. For example, Q4 has a couple of things. There are festivals, right? There is festivals, like you will have um, Christmas, right? You will have Christmas. Then in the US, you will have the Black Friday, Cyber Monday sales, right? You will have Thanksgiving, yeah. In other parts as well, other places as well, you will have, like in India, you have Diwali, correct? So you will have different types of seasonal periods that comes in quarter four. There would be more promotions, there will be more discounts, right? So the sales is likely to increase. That is there. Overall, also you can see that there is an increasing trend in general. Even if you look at the trend, if you see, this is going in the upward direction only. This is not going in the downward. This is going in the upward direction. So overall trend is positive. Okay. There is seasonality, but overall trend is looking positive. Okay. Also, there is a continuous dip after Q4. You can see that there is a dip everywhere. There is a sharp dip after Q4. So the next year sales always starts with a dip. Now there can be multiple questions that you can ask. Why this dip is coming? Is there um, a reason for it? So that is a question to the business. Why from Q4? Of course, there will be more promotion, more sales, that is there, but the dip is quite big. Dip is even going like it is going below your Q4, Q3 sales as well for the previous year. So all the next year's Q1 is lesser than Q3 and Q4 of the last year. So this is how you can do a, of course, there will be other things that you can see, but this trend analysis, this is always helpful, and you can answer multiple questions over here related to the sales trend and seasonality. Okay, now let's look at one more visual over here, and I'll keep it. Let me go to one more visual, and here I'm going to I'm going to use a map visual over here. Okay, I'm going to use a map visual. So for the map visual, what you can do is you can go to select location field. Okay, so you'll be using these marks card fields. So drag the country field. Country field is a location. The data type is also geographic. If you put it and add it to the details card, so just drag and drop it on top of the details card. Okay, can you do that? And automatically does the map visual appear for you? Drag country, drag it, drop it on the details card. You see the map? Okay. Now I'm able to see just one point over here for United States because all we have is United States data. Okay. So we have added country into the details. Now I want to see the data by states. So you also have states data over here. Add states as well into the detail. Okay. So now we can see different states where the sales have been, and we can see which all states it is coming from. But I want to know that from which state the sales are more, which states the sales are less. Okay. So all these, if you see the mark over here, this is a circle, right? This is a circle, or it is called a bubble. This is also called a bubble. So automatically these are coming in the bubble form, right? This is the mark type, which is coming as bubble over here. But I want this bubble size to be with respect to the amount of sales that I'm getting from these states. So the next that you need to do here is you can simply bring sales and drag and drop it on the size card. Okay, size card, drag and drop it on top of the size card. Okay, does the view change now? Instead of seeing all those different bubbles, now you see only a few. Some are very small, some are bigger. Okay, now this bubble size, let's say I want to increase this bubble size a bit so that I'm able to see more bubbles over here. So go to the size, click on the size, and just expand, make this size a bit bigger so that you are able to see more bubbles. So one, I increase the size of this bubbles everywhere. Okay. Secondly, I'm going to also change some property of these bubbles to make it more visible. So for example, the border of this bubble is in some other color. So I'll just fix that, and you tell me whether that would be helpful in viewing the data better. So right now we are looking at it like this. If I change this sum of sales that I see over here in the bubble, and if I go to, okay, it'll be in the colors actually. It'll be in the colors. Sorry, it'll be in the colors because we are looking at these colors over here, right? So go to the colors, click on the colors, okay? And here I want to make just some minor changes. This hello effect, I'll just remove the hello effect. Hello, just make it to none. Okay, now these hellos are gone. And secondly, the border that is coming, let me make the border as none too. Okay, let me make the border as none too. Okay, now, or let me do this border. I'll put a slight color over here. Border. Let's put a dark gray color so that these bubbles are becoming more evident. You're able to see the bubbles, more bubbles rather than earlier. Okay, so now we are able to see more bubbles. Okay, what did I do? In the colors, I went and changed this effects. Hello, I changed it to, earlier it was automatic. I changed the automatic to none, no hello. And border, I gave this dark black border. That's all. Okay. So now I'm able to see which country I'm getting the highest sales. Can you tell me where I'm getting the highest sales from? Okay, it's California. Okay. So state-wise, I know that most of the sales is coming from the California. Now I can see that. But when it comes to the region, now I can see that my region-wise, my region are more into the east region having more sales than the west. Okay. East region is having the more sales. We have more bubbles over here as compared to the west. Okay. Another thing that I can do here is now I can see the size of these bubbles based on the sales. But I can also see out of these sales, which of the sales are more profitable. Okay. So now drag the profit and drop it onto the color mark. Color mark. Okay. And now see the difference. And now tell me, what does now this tell you? There are many states where you can still see high sales, but they may not be profitable. Okay, so when I added this profit into the color, a color gradient got added. If you see at the right, this is showing the color gradient which in which it is showing. So anything which is coming in this yellowish and reddish color, that is indicating losses, while the blue ones are indicating the gains. So there are, California is also profitable as well as high sales. New York is also profitable and high sales. But there are other countries and other states like Texas where sales is high, but it's not profitable, right? So Texas, Florida, Pennsylvania, Ohio, these are high sales, but less profit or actually loss. Okay. So we are going to keep our learning to this much today. We'll continue more on the visualizations tomorrow. Let's just rename this to sales and profit by states. Okay. We got this. And now the last thing that you all should do is save your file. So always save your workbook. So go to file. Under file, you have this option of go to save. Okay, file and save. Don't save it to Tableau Public because that will publish it online, but just save it locally. Go to save. And here you can just go and save it as, let's say this is your, in the save as type, you can use for going forward, just save it as Tableau packaged workbook, TWBX. Select that and save it. Okay, so let's start with this quick recap. Yesterday we learned about the basics of data visualization and the different roles that exist in the BI projects, right? We learned about Tableau, the different products of Tableau, Tableau Desktop, Tableau Server, Tableau Cloud, and Tableau Public. And we started using Tableau Public. We learned about the interface in the data source interface. We saw the worksheet interface. We saw how we can add the data source, how we can add the data, and what are the properties in terms of just doing the initial data cleaning in terms of hiding, unhiding the columns, doing the data's column split, all those. And then we loaded the data. We started analyzing the data. So we first created sales by category visual, right? We created a sales trend, which is a quarterly trend of the sales. And we created a map visual, which shows the sales by states and colored by profit. Okay. Now, let's also create one more visual here. Okay, it will be, this time it will be, I want to see which region is having the highest sales. Okay, which region is having the highest sales. Okay, so which region is having the highest sales? So here we have the regions. I can bring regions into the column to drag, put it in the, or rather, let me put it in the column. We have the region and I will put sales in the column. Okay, so this will give me regional sales. So in each region, I'm getting the, I can see total sales. Now the standard process that we have always to do. So we will do the data labels. So click on to add the data labels, sort the data in the descending order, make the view to entire view. Okay. Okay. Now this is done. Now I want to see this breakdown of the region by different segments. So I have product segments. I want to see the breakdown of the sales by segment. So what I can do here, I have this color mark under the mark color. I want to segment these. I want to break these down, these regions by the segment. So I can bring segment, drag and drop it on the color. And you'll see all these results are now segmented by, divided by the different segments. So we have consumer, corporate, and home office. I can see the details divided by segments. Okay, this is similar to how we can add legends in Power BI in the visualizations. Similarly, you can do these colors and this will create a legend in your visual. Okay, what did we do here? Let me remove this. Okay, remove. What did we do here? I wanted to see this region, each region. I want to see by different segments how the total sales are for each region. Okay, I want to do this. So for that purpose, I can simply drag segment. Okay, what do we need to do? Drag segment onto the onto the color shelf. Okay, onto the color shelf. You're not able to see the data labels. So we have these standard steps, right? We you learned yesterday that every time follow these steps. always turn on the data label from here, always sort the visuals from here, always change the view to entire view until unless it's not required. You do these steps like 99% of the times. Segment, bring into the color. Now you'll be able to see the different segments and also different colors for it. Okay, so Neha, to your question, yes, you can put region in details too, but you're saying region into details, or you are saying you put segment into details? You can put anything anywhere, right? I'm trying to I'm trying to build something meaningful here, and then we'll learn more about the visualizations, how we should be using all these components. Okay, now let's say I created these worksheets. Okay, I've created these 4 sheets, and now I want to create a dashboard for the end users. Okay, I want to create a dashboard. So individually users can go to these sheets and see what kind of analysis we have done that's there. But I want to create a dashboard as well, one dashboard where I can see multiple visuals together. So in Tableau, what happens is you first create the worksheets and then you use those worksheets to create dashboards. Okay, so let's create a new dashboard. So here in these small icons here, you have the new worksheet. Next to that, you have new dashboard. Next to that, you have new dashboard. Click on new dashboard. Okay, if you click on new dashboard, a new dashboard page will pop up. Okay, now in the dashboard page here, there are these different pane over here. There is a different pane. You have some other options over here: dashboard, size, sheet, objects. Some different options are available over here. So in the dashboard, what we need to do is use these sheets to populate on the dashboard. Before we do any of that, let us always work on the size of our dashboard. What should be my size of this dashboard? So you can imagine that this is your canvas. This is your canvas. And what should be the size of this? So currently this is on a smaller size. I will change this size to, how do we change this size? I'll change this size to a bigger size and an automatic size actually. So there is this size option over here. This is telling me what this size right now is. I want to modify this. So I want to go to this small drop down over here. Okay. And here in the size options, instead of using this range, so this is allowing me to keep the range minimum to maximum. Instead of this range, I keep this size to automatic. Okay. Everyone do this. Go to size and choose the option automatic and tell me if it increases your canvas size to full width. With automatic size, it will adjust. Your size would adjust based on your screen size. Okay, whatever device screen size that you are having, it will adjust according to that. So we'll use that. Okay, we'll go and choose the automatic. Okay, now we have got it over here. Now I need to just add my visualizations over here. So you have these sheets, worksheets over here that we can see. All you need to do is drag and drop your worksheets to start coming on the appearing on the dashboard. So drag, drop it, sales by category. You've dragged it over here. It by default, it occupies the entire space. Okay. So first visual you have added, it occupies the whole space. Then sales by region, I want to keep this next to sales by country. So you drag and now you see, don't leave the mouse, just keep dragging it and keep it. As soon as you go any part of your dashboard, it highlights that part. So it kind of adjusts where I want to put my this worksheet. So automatically it will occupy the space, whether I want to use the left half of the dashboard, right half of the dashboard, bottom of the dashboard, or top of the dashboard. Okay, let's say I use this top of the dashboard over here and dragged it and dropped it. So here automatically when you put visuals from worksheets to the dashboard, it readjusts accordingly. All you need to do is drag and drop. It will readjust accordingly. It will just occupy equal space. Okay, it will occupy that space. So now I can see sales by region coming at the top and sales by category coming at the bottom. Now I want to see the sales trend over here. Okay, so sales trend. Now let's say I put sales trend, drag, and I'll put it at the bottom. Here I'll put sales trend. Okay, so I've got these three, and the sales by profit and region, the map visual, I'll drag and put it in the right half. Okay, so go where it is, the right half is visible. Whenever that is highlighted, now you can drop it and it will occupy that space in the right half section. Okay, so you got all your visuals over here. Now you can resize whichever you want to resize. I can make this a bit smaller. Okay, sales by region. I can make sales by category smaller, sales trend like this, and the region visual like this. Okay, so create your visuals dashboard like this. Prerna, it does not come like this. It will come as per how you will place your visuals. So you can always, you have this, it looks like all this visual and you click on this, you see it looks like a briefcase. Okay, it looks like a briefcase with a handle at the top, right? So if you want to drag and move around the visual, just hold it by the handle and drag it and place it anywhere. So eventually place it as how it appears on my screen. See if you are able to place it. How you will be able to place it? Once you start placing it, it will highlight that area in gray color and it will allow you to choose and show it in that. Once it appears in the gray color, you can do that. Okay. Okay, that's fine. What you can do is uh, the other visuals which are coming at the bottom, you can drag them and put them under the first visual, sales by region, and then it will allow you to adjust your visuals. This is like this. Once you start using it, once you start dragging these options around, you will get much more familiar with it. Okay, so how you can do it even better is, let's say I remove this. Okay, I can just delete, remove from the dashboard. Okay, remove from the dashboard, remove from the dashboard, and remove. Okay, you can bring the sales by region first. So you can bring sales by region first. Sorry, not sales by region, but the map visual, sales and profit map first. Okay, you got the map visual first. Then you can put sales by region in the left. Then below that, you can put the sales by category just below that, right? Just drag and put it below that. You will get this. And then sales trend below this. So if this is easier for you to do, you can do it in this way too. Either way, whichever way you are able to do it, but easy. So you can divide it into two parts first and then put in vertical order. Okay. Now here, let's say we should always try to keep as less clutter on the dashboard as much as possible. Now, if I am using these labels over here on the visual, then I may not require these excess labels, right? This may be just additional information. If my title says sales by region, then I may not even need to put this access title with sales. Do you think it's necessary that I need to put this access title? Do you think it is necessary? Or can we remove that? We have given the title that we are analyzing sales. Then do we need this access title? Right? This is not necessary. We don't really need the access title. So what you can do directly over here in the visual itself, you can go to this access, click on this, the access will get highlighted. You can right click on this and you can go to, you can just deselect the show header. Okay, this will remove the entire access, but instead, let me first show you that I want to just remove the title. So edit access, okay, edit access, and you want to access titles. You can also remove the title from here. Just remove the title. Don't keep any title. So this will just have the access labels, but not the title. If you want to keep the label, you can do that too. If you want to remove the label as well, you can do so. So I'll go ahead and remove this entire header part because I know that I can see this information directly over here. Similarly, I can get rid of this too, show header. In this one, we know that we are showing by quarter only over here. All right. So I can remove this title, but I would still want to see these labels. So I can go to access title and I can just remove this title over here. Okay. Now it becomes slightly cleaner. You can also make changes in the size of the fonts, which we'll come to. Let's say these titles, these are a bit bigger, right? The titles are a bit bigger. You can double click on this title at the top, double click the title at the top, select this sheet and reduce the font size from 15 to 12. Okay. Everywhere double click, select the entire sheet, change it to 12. Okay. It became a bit more clearer now, correct? So it would also be better if we just currently this looks like this, right? You have all these visuals. So just it would be better if you just also add the boundaries around these visuals. That will make it a bit cleaner and segmented. So just select any of the visual. Next to the dashboard, there is layout option. Go to layout. Okay, go to layout. And here you can choose the border and choose border as instead of none, you can choose a solid line. Okay, and see how it looks like. For all of these, just choose the border as a solid line. Now it looks more segmented, better. Now if you see that when we added these worksheets, along with these worksheets, the legends were also added to the dashboard. You can see the legends in the right hand corner over here, correct? The legends are added over here. Now these legends belong to specific visuals, right? For example, this legend of the size of the bubble, this belongs to the map visual. This color coding of profit, this also belongs to this visual. These colors for the segment, this belongs to this visual, right? So when you have dashboards where you have multiple legends, it might be confusing which color code should we refer for which visual, right? Or which legend is actually for which visual. So we should also be seeing how we can keep these segments. These segments also appear like visuals over here. Okay, so one way is that you can go ahead and drag and drop them like handles, right? So you can drag and drop them on the top, on the bottom, like this. Okay, so segment, you can keep it let's say over here, you can keep it like this. Colors, you can drag it. Size, you can drag and drop them over here like this next to the map. Okay, now this size, although this is indicating that which bubble size is corresponding to which type of value, but actually this is not much valuable. You would seldom look at these size brackets like this and see. You would be able to get the idea with these bubbles. So actually, it would not be a bad idea to even drop this from the dashboard, this part. Okay, let me actually drop this, remove it. Just go and remove it from the dashboard and just leave this part. Okay, now what happens here with these legends? Okay, these are also kind of visuals. When you start dragging them, they will occupy the space where you place it. So basically, the way these default setting is for all these visuals is that they appear as tiles, individual tiles, and the tiles do not overlap. Tiles do not overlap. So if you have seen creating visuals in Power BI, Power BI, everything can overlap on top of each other, right? Two visuals can overlap on top of each other. The default setting is like that. In Tableau, the default setting is that everything would be tiled. They would not overlap. Even if I try to drag and drop it on top of it, it will appear in the right hand side or the left hand side or the bottom. It will be tiled. Okay. So I don't want these to occupy unnecessary space, these legends. So I will, for these legends, I'll make them from tiled to floating objects. Okay, floating objects. Floating object can float over another visual. So you see here object and you have two options, tiled and floating. Okay, tiled and floating. So you can convert an object to a floating object. Just select this, make it a floating object. Okay. Okay, it will not get converted from here. You can actually go and make it from here. More options, make it floating. Okay, just make it floating. Okay, floating. As soon as you convert it into floating, it can now overlap on top of the visuals. Now it would be fine if I just put it inside this map visual, occupying some space. Okay, it will not harm anything. It will be within on the map visual. Okay, so just click on the visual. There is a small drop down in the legend for more options, and from there you can make them floating. Float. Okay, and then you can drag and drop it anywhere on the visual that you want. I will make it like this, make it smaller and wider for these segment names to be properly readable at the top inside the visual. Two legends as floating objects and added them inside the visuals. Sarban, are you able to do now? Just make them floating. There is more option over here. Convert that it to a floating object and then show. Okay, business intelligence tool that I'm developing. That means that I should be able to analyze the results. So we are trying to analyze the results and we can see the sales by, okay, we can see the sales by region, sales by category, sales trend, sales and profit on the map, right? Now in Power BI, if you remember, everything is by default interactive, correct? Everything is interactive. If I click on this technology over here, it should, it filters the other visuals. If I click on furniture, it filters the other visuals. So that happens automatically in Power BI. In Tableau, it does not happen. So these are not all interactive, right? So here I want to make it such that I should be able to interact. So what I want here is I should be able to filter the other visuals based on one visual. So if I go to the sales by category, if I select this visual, you see some options over here. One of the option is this use as filter. use as filter. So just enable this use as filter. If you enable this, this will become, this will get highlighted. And now if I select any of this category, let's say if I selected technology, I'm able to see the trend for the technology, sales of the technology over map, the sales of technology products across the region, across the consumer segments. So this works as a filter. I'm able to see filtered result in all the visuals. Okay. Same thing I would also want to do with this region and the segments. So on this visual as well, you can make that as well use as a filter. Okay, now this is also used as a filter. Now, let's say I want to see the consumer segment in the West region. Okay, so in the consumer segment, I can see the sales by technologies, sales by categories, trend, where in the West region the sales are high, low, all those information coming over here. Okay, so this is much more interactive now. Users can slice and dice, view the results as they require, wherever they want to focus on. Okay, so South is the, for example, South is the lowest selling region. So we can see in South specifically, I can select multiple fields in South. You can select by clicking on control and select. So you can see the entire South region and see what is happening in the South, where am I getting most sales, which is the better one, which is not. Okay, so mostly South does not look too good. Most of these big ones are actually loss making states. Okay, so overall results for the South is not looking good. Even if you look at the sales trend, this is also quite flat over the period. Just off late, it has picked up a bit, but it has been flat throughout most of the time. Okay, so we can analyze the data, start analyzing as we require here. Okay, if you want to have much more just controlled view, you can go to this full screen presentation mode, click on the presentation mode, and it will appear on full screen. And now you don't see all these other disturbances, other settings, all those things. You just go into the analysis mode directly over here, right? So you can go to full screen mode, presentation mode, and you come back from the presentation mode from this right corner. So this is how we can create a dashboard. This is our first dashboard. All right. Now let's work a bit more on the data preparation side. Okay, data preparation side. So far we have just looked at the very high level data source, so setting some of the options, then the fields, and just creating some visuals to analyze the data, and some standard practices in analyzing the data and creating a simple dashboard. Now let's understand a bit about the data preparation, some options that you can do while preparing the data. So for that, I want you to open a new file. Okay, open a new file. So you can directly go from file and you can go to new file, new. Okay, it will open a blank Tableau file, a blank one. Okay, so now let us understand this with a bit more of example. So here, let's say for data preparation, I want to do a bit of, let me go to just a second, data preparation. So data preparation in Tableau. So as we learned that there is also a separate tool called Tableau Prep, which has much more features in terms of data cleaning, data transformation, but that's a separate tool. We are not going to cover work on that. Here we are going to see directly in Tableau how we can do some data preparation. And here when it comes to data preparation, it is mostly related to how we can work with multiple tables and how we can use them, how we can combine them. Okay, so similar to how we learned about combining the tables in Power Query, similarly we can also do the combining of the tables in Tableau. Okay, so when it comes to combining, there are two ways in which you work on the combining data in Tableau. One is when your data is or your tables are coming from a single source. Okay, from a single connection, from a single source. If you are getting multiple tables, okay, so there is, okay, combining data. In combining data, when tables from single source, okay, single data source. So when you are using single data source, you can do joins. Okay, you can do joins, you can do union, and you can do relationships. Okay, there is joins, there is union, there is relationship. Okay, so this join union relationship, you would also see this similar to how we have learned in Power BI as well. So when it comes to joins, then joins are similar to merge query. So joins are similar to that. Join means that you are physically joining the two tables, and for joining you need to use a field to use as a join. So there needs to be some level of detail at which the join happens. Okay, some level of detail at which the join happens. For example, there is a one table for the employee, let's say the employee attendance, right, with having the details of employee ID wise information. And then you have another table which contains employee salary information. Once again, you have the employee ID and the details. So these two tables can be joined because there is a level of detail which is same, which is employee ID in both the tables, and with it can be used to make relationship, or I should say joins. So joins means you are physically bringing the columns from other table into one table. Okay, that is join. Union, on the other hand, is like append. We learned about append query. So whenever you want to do row wise addition of the data from multiple tables, then you can use union. Union will combine multiple tables into a single big table. Okay, so you can do joins, you can do unions. And then the third type of combining appears, which is relationships. And relationships is you are making just the relationship between the tables by using some field. And in the relationships, you are not physically joining the tables. It's just logically the tables are related, and you can use them when you start analyzing. You can use that relationship when you start analyzing. So when it comes to relationships, you will have the cardinality, those kind of things. So these are the types of combining that you can do when you have the tables coming from a single data source. Other type is when tables come from different data source. Okay, when tables come from different data source, when tables come from different data source, then you cannot do joins, you cannot do relationships. That is not feasible. In that case, you use another feature in Tableau which is called data blending. Data blending. Okay, this is a very powerful feature and one of the most important feature in Tableau, which makes it like unique. Data blending. So data blending can be performed even when the level of details into tables are different. Okay, level of details are different. or there is no relationship with them, but still you can use blending to combine two different data sources in when you are visualizing them. So at the time of visualization, you can blend the data. Okay. And it lets you, let's connect or not connect, you combine the data on the fly while visualizing. Okay. We'll see the example of this. It will be more clearer on this. And in blending, you may have two tables at two different level of detail. One in one visual, you may have data uh, which is showing daily result. In another table, you have monthly, but you can still combine those when visualizing it, and it works. Okay, so we'll look into these with some examples. Okay, so let's look at this. So first, let's look at one of the examples. So the new workbook that you have created, open. Okay, we're going to connect to we're going to connect to an example. Let me look for the example. So there is a joins example. Are you all able to see the joins example file in the data, right? Okay, so let us connect to that. So we'll go to source, connect to joins example. Okay, now look at this data. Here we have two sheets. One is customers, other is orders. Okay, one is customers, other is order. So if you want to just look at what the content of these two tables are, you can see this small icon within the table, view data. I can simply click on this and I can see a preview of the data. Okay. So customers, I have this information. Customer, the city of the customer, customer name, customer ID. Okay. So I have 4 customers over here with unique IDs, the city and the name. In orders table, let me close this. Similarly, orders table, you can view the data here. So we have the order information, order date, which customer ordered, how much they ordered, what is the order ID. So information like this. Correct. Now I can join these two tables to bring the customer name from the customer table, customer city from the customer table, and join it in the orders table. Okay. So I want to know which customers have ordered. Okay. So what I will do here is first I will bring the orders table over here, drag and drop orders over here. Okay. So we added the orders over here. Okay. Now I want to do the joining. So in the data source, in the data, um, this data source settings, you have the data at two levels. You have the data at two levels. We looked at this level. So what you see here right now, this is the logical layer. If you remember logical layer. Okay. And then there is also a physical layer. Okay. Physical layer. The joins happen in the physical layer. Joins and unions, those happen in the physical layer, while relationships happen in the logical layer. So we want to physically join these two tables. So we want to go to the physical layer. So what you need to do here, you go, okay, and go to open. Okay, click and open. Once again, go here and open. Open means you are going into the physical layer of this table. Okay, you are going to the physical layer of this table. So first you need to go to the physical layer, and then whichever table that you want to join, just drag and bring it next to this table. Don't bring it. If you drag and put it below this, it will automatically perform union. If you put it next to it, right to it, it will perform join. So drag and place it right to it, and it will automatically do a join. It has performed a join over here. So this is an inner join, right? Inner join means it will only keep the data which is common in both the tables, and based on which field. So if you just click on this, it will tell you the details. So there is an inner join being performed over here with the first table, orders table. We are using customer ID field equal to the customer ID field in the second table. Okay. So customer ID field is being used to make the relationship, to make the join. So this is fine. Okay, customer ID is the right field with which we should be joining. But here, instead of inner join, I would recommend using a left outer join, because I want to keep all the orders information. I don't want to miss out on any of the orders if the customer ID is not present in the customer table, right? I want to have all the orders, if even if the customer ID table does not have full information. So I can go and choose left outer join. Okay, left outer join, and automatically this color code, this symbol here is also changing to show that we are performing left outer join. Okay, and we are good. So left outer join is being performed over here. Output of that join can be seen here at the bottom. Once this left outer join is performed, so we can see the order ID, the customer ID in the orders table 01, 02, 05. Okay, now if you see in the customers table, once again going to the view data, in the customers table, we had customer ID 01 as 101, 102, 103, 104. Okay, there is no 105. Okay, so in orders table, we have orders from the customer 101, 102, and 105. So there is one customer which is present in the orders table, but it is not present in the customer table. So that's why when we did the left outer join, it gave me rows for this 105 customer as null, right? The customer ID, customer name, customer city, everything that is coming from the customers table is now coming as null. Okay, with the left outer join. If we had continued with the inner join, it would have simply skipped that entry. 105 would have been skipped because it is not present in the customer table. Okay, if we go with the right outer join, then it will keep everything that we have in the customers table, right? Everything from the customers table, all the customer 101, 102, 103, 104, irrespective of whether we have the orders information or not for those. And if we go with the full outer join, then it will keep all the records. So all the orders information, all the customer information. Wherever data is not available, those all will be coming in null. Okay. If my intention is to have all the orders information and only the matching customer information, then I can continue with the left outer join as we discussed. Okay. So we'll connect left outer join. Now this joining is done. Okay. And I can close this. We now came back from the physical layer to back on the logical layer. And now in this orders table, this is indicating that there is some thing happened in the physical layer. So they see there are the two physical tables, orders and customers, which are being used here. If you want to see more details, you can double click on this. Even that will take you here in the physical layer and see what we had done here. Okay. So you can do your joins in the physical layer like this. And now we have come to this logical layer. So here now you can see, let me show this once again what we did here. Double click on this. What we did, let's say I want to remove this. We had the orders table. We first added the orders table. We double clicked, we came to the physical layer. Now I want to join it with the customer. So drag customer table next to the table, just next right to it, and it will perform a join. Change the join type to left join because we want to have all the orders information and the matching customer information. Okay, so now join is being performed. We can close this, and now you have this orders table. Now you will see the name of this orders table has changed to orders plus. If you see, the name of this table has become orders plus. Okay, if you want to rename this table to something else, let's say this is orders, let's say you want to give some other name, orders. Let's say I just gave some name here. Let's say I change it to orders full data, right? Now it has all the customer information. Now if you go to this using this join data, if we go to sheet one, now you will see we are able to see both the tables and the columns coming from both of these tables. So what is coming from the customer table, what is coming from the orders table, and we can analyze the data, okay, with this join. So if I need to know how much order amount we got from each customer, I can bring customer into the column. I can bring order amount into the rows. I'm able to see that information. Okay, so there is one customer without any information, the 105. I can see that. So I can start and visual analyzing this data with this join. Now let's take another example, and this time we want to understand the union part. Very simple. Okay, very simple. You can go and create a new file, open a new one. Okay, new one. Go to the data source, and this time once again select the Excel connector, and we will use the union example. Okay, go to union example. Okay, now here you have, in the union example, you have this data. Now imagine that you have the similar data but by different regions over here. So if we see the data over here, so this is region wise orders and sales. So east region orders sales. Similarly, for other regions, north region orders and sales. Correct. Another region, west region, south region, we'll have this orders and sales. So we need to union this data. There is no need for these to be separate tables. These should be combined. So you can start with east table, bring it over here. Okay, we are at the logical layer. Go to the physical layer because that's where you can do the junior union and joins. So double click or go to open. Okay, it will take you to the physical layer. This is the physical layer, and in the physical layer you can simply bring north and drag it below this. If you drag below this, it will union. So now there are two tables which got added. If you see here at the bottom, you got result of east region table and the north region table combined in the row wise manner. If you add south as well, union that too, it will be added. More data is added here. Okay. If you add the west, you will get all these four regional data over here. Okay. So here we have got all the data. You can rename this to, let's say, instead of east, you can call it regional, let's say regional sales data. Let's say I give this name, right? And now I can go to the sheet and I can start analyzing the data. Okay. Now here when you are doing union, you have noticed that there are new columns which are added, which contains the sheet name and table name. Sheet name and table name. So these metadata fields also becomes column fields here, right? These metadata, like name of the table and name of the sheet, they metadata also becomes column. You see that you have this. This is another property that happens only in Tableau, right? So it also create a column with the table name. and sheet with the table name. Now here we don't require both of these because we already have a column for the region name. So the sheet name, table name is not required. But whenever you want to just distinguish, you have anything, any table references to be used in visualization, you can keep these columns or you can choose to hide these columns. Okay, so we can go ahead, we can hide these columns if we require, and now we are all good analyzing this data region wise, sales information, right? So all of these data combined together and we can analyze. Okay, so this is how you can perform union, very simple. Okay, now let's learn about the third example, which is how we can do the how we can use relationships. Okay, relationships. So for relationships, we'll go to uh, another example over here. This time uh, we are going to use the sample superstore data. Okay, sample superstore data. Okay, sample superstore data. So another one, you can open another one, go to file, go to new, okay, and go to data source, Excel file, and we'll go to sample superstore data again. Okay, now in sample superstore data, we have orders, we have people, we have returns information. Now let's say I don't want to physically join these two tables. I can utilize the relationship between these two tables, and with the relationship as well, uh, I can analyze the data. I am able to visualize the data. So wherever it is feasible, where you can use relationships, you should always use relationships. That is better in terms of performance. So let's see if we can use relationship here. So select orders first. Okay, this is the orders data. Okay. Now I want to use, along with orders, I want to use people information. So people has information about who are the people manager in respective regions. Okay, so we have 4 region in our data, and these are the regional managers in each of the region. I want to be able to analyze my data for these regional managers as well. Okay, so I can make a relationship. I don't need to physically join these two. I can make relationships, and relationships are added in the logical layer, not on the physical. So joins and unions are on the physical layer, but for relationships directly on the logical layer, you can drag, and if you see, this line would appear as soon as you bring the other table in the logical layer. Okay, so this line is indicating that there is a relationship between these two, orders and people. So if you hover over on this line, it will tell you the relationship. So what is the relationship? Relationship at the moment is there is many to many relationship. Okay, and there is fields that is being used to make the relationship is region from the region table, and region from the people table, region from the orders table, and region from the people table. Now I know that in the this table, the people table, I will have only one person per region. Okay, I know that this is always going to be one person per region. This means that when we use region to make relationship with the orders table, then I can make this relationship one to many. I don't need to keep it to many to many. So by default, it is coming as many to many. In Power BI, it automatically looks at the tables. It automatically makes that decision whether the cardinality is one to many or many to many. Here, it will let you decide what will be the cardinality in future as well. So it recommended that there will be many to many cardinality, but if you think that it should be one to many or one to one, then you can change that cardinality here. And where we can change this is in this data model, sorry, this place where we can see the metadata and other information. Okay, so here we have some information, some learning material, how relationships differ from join. You can learn about this. Okay, so here the relationship is created with region field is equal to region. Okay, and in the performance options, we can go and decide the cardinality. So cardinality here should be many records from the orders table. Many records from the orders table would match with one record from the people table. So I can choose it to many to one. Many to one cardinality I would want this way. Okay. And I can keep it to this cardinality. I can choose what type of cardinality it should be. Okay. Here in Tableau, you can create relationships using more than one field too. So if there are more than one field which relates with two tables, you can use those two. Okay. So you can add more fields and make the relationship stronger. Okay. So you can use multiple fields to make relationship, and you need to specify the cardinality of it. Okay. So we have made relationship with the orders table, people table. This is many to one relationship. Okay. Now we also have this third table, which is returns. Returns has information. Yes, Zilda. So person is manager. So you have the regional manager information, and you want to know, you want to use that in your analysis. You want to know the name of the person, and by the name of the person, you want to see the sales, all those details. So that's why we are joining it with the region table. Okay. Now here we have the returns table too. Returns contains information about the orders which got returned. Okay, which got returned. Now here you can see the order ID and the returns. Okay, so we know which orders were returned in this, and I want to make a relationship with this as well with the orders table, because I want to know from the orders which were returned what is the detail about those orders, which product were there, what kind of location were those ordered in. So all those details, those are present in the orders table. So I'll make relationship with the returns with the orders table using the order ID. Okay, so once again bring return, and this time make another join with the orders table here. Okay, now orders table is linked to the people table. We specified the cardinality, we checked the relationship. Now you can go to the returns, and you can see this is currently being related with the order ID. There is only one column with which you can make the relationship, so this is fine. So whenever the order ID is equal to this, then you use the relationship. Okay, now here as well, in the returns table, you will have just one value, yes or no, right? Whether it is returned or not. So there will be only one row per order, right? So even here in the returns table, you can use the cardinality many to one. Okay, many to one cardinality can be used here too. Okay, and now you can use this relationship to analyze the data. Okay, now if we go to the sheet, if we go to the sheet, I am able to see all of these tables. So there is orders table at the top, then you have people table, and then you have returns table. Okay, now with the relationship, I can analyze the data. So if I need to know by the regional manager, let's say the person, if I want to see how much sales were those from this person, I can bring person from the people table and sales from the orders table. and see the result. So for each of the regional manager, this is how much sales was generated. So we are using the relationships now to analyze the data. Similarly, if I want to analyze the data for returns, which orders were returned or how many orders were returned, okay, so I have that information too. So you have this return, okay, and there is also one field which automatically gets created in Tableau, which is the count of rows. So if you see for all of these tables, there is one measure which is just the total count of rows. So I got this field as well. So if I need to know how many orders were returned from each uh, category, okay, how many orders are returned. If I need to know that, I can do that very easily. I can bring category into the row, or let's say in the column, and I can bring the return count into the rows. So I'll know that, okay, most of my returns are from the office supplies. Okay, most of the returns are from the office supplies category. Okay, so we can use these fields coming from the relationships directly in the visualization. Normally, like if you are asking for an example of operators, normally you use only the equal operator. In most of the scenarios, you will use equal operator. You don't use the other operator, but this is these are options which are available. Okay, these are options which are available. Let's say you want to make a relationship where the uh, if you are making any relationship, it should look for matching the relationship from one table where the values are lesser than this. For example, you have one table having the daily data, another table having the monthly data, then you would know that the daily results would always be lesser than the monthly results. So you can make a relationship based on the sales value in the daily table will always be lesser than the sales in the monthly table, right? Those kind of relationships you can make, but those are all weak relationships. Those are all weak relationships. So always look for making stronger relationships. Okay, this means you have not unioned all the tables. You have not unioned all the tables. So in this data preview, are you able to see all the four tables unioned here? You can see the data preview, all the data for all the regions. You may have not unioned the other tables. So similar to how you unioned north, union the west and the south too. Let us look another example, which is when we use data from two different sources. When you have two different sources, then how do we handle that? And that is actually done through data blending. Okay, data blending. So let's open another file. Okay, open a new one. Open a new one. Go to the data source. And in this one, first we'll connect to the product sales table. Okay, go open the product sales table. Okay, product sales. If you want to see the preview of this, you have data like this. So each product, name of the product, region, sales, and month of the sales. Now suppose this company for which you are analyzing the data, they are into two different line of business altogether. One is in the electronic products, right? In the electronics product, and another is on the uh, some other non-electronic. Let's say some non-electronic. Let's take example of some uh, uh, food products. Let's take that example. Food products, completely different. One is electronic goods, another is food related products. Now, these two are two different categories altogether of the business. You will not be tracking the business having the electronic sales along with the food product. There will be separate stores, there will be separate data points where those will be connected. There will be separate tables from which those are coming. But if you want to just see these two businesses, performance of these two businesses together in one dashboard, you can do that using data blending. So one data will have this electronics data. Then there can be one another data which will be having these product names would be related to some food related products. Okay. Product ID would be completely different. Everything would be different. Product names would be different, right? Different types of products. It's just that I want to know over periods, over months, whether the what kind of uh, sales both of these businesses did. Okay. So you have this now. Let me see what example do I have. So first of all, you can go to the sheet, okay, and you can see the product sales over here. This data is appearing over here. Now, I want to have one more data added over here. So what I will do here, there is this option of add new data source here. I want to add a new data source over here. So click on this add new data source. Directly a window will appear to add a new data source. Okay. And once again go, and this time, okay, I have the regional targets information. Let's say I have the regional target. This is another example. Let's look at this regional target. What is this data? Okay, now a separate data source is being added. You see a new window has appeared. You now have this regional targets. What kind of information do I have? This is another example. So here we just have the region, all the different regions and the target information. What is their total target? Correct. So you have the regional target over here, monthly target. Okay. Now this data, we are not going to do any changes. We'll just once again go to the sheet one. Now in the sheet one, now you can see these two connections that we have, two data sources, product sales and regional target. You can choose which one you want to analyze when. You can analyze these separately. If you click on product sales, you see all the tables data related to product sales. If you use regional sales, you will have the data related to region wise sales information, right? Those data you have available. Now, let's say I start my analysis and I went to the product sales and I want to look at what my region wise, let's say I drag region over here and I want to see what my region wise sales, monthly sales is. Okay, I got this information. Region wise, what is my total sales? And from the other table, if you go here in the other table, as soon as you now go, when I made any selection from the first table, okay, first of all, I would want all of you to do till this part. Let me know if you are all here till here. Let me give me a confirmation if you are all able to see what I'm seeing here. Same information, right? Yes, I opened a new new Tableau public, new Tableau workbook. Okay, now I have selected data from the first table. Now, if I need to bring data from the second table and it should show the related information, then if I go to the second table, I can see that there is this linking option is appearing. This kind of a link clock is appearing over here. Okay. What it does is it gives you an indication whether you want to blend these two tables using the region field. Okay. If you click on this, okay, then these would be related. If you don't want to click it, it will not be. So it says that the relationship, there is a blending which is available through the region field. Okay. Now let's say if I bring monthly target into this visual along with the sum of sales and I put monthly target in the column next to this, okay, it will show the related information. So the region field is actually coming from the first table. The monthly target is coming from the second table, but it is showing the correctly monthly target for each region. And that is because it has this, it created this blending. Okay. Now you can see that there is these two table have this blue and the red ticks. This is indication that these two tables are using blending feature and the data is blended through the region field. Okay. Through the region field. If I remove this blending link, see all the results would be same. So it will not do any kind of filtering for the monthly target for each region, right? This will not do. But if I leverage this blending feature, it will give me results filtered for that. So what this is doing is without you joining two tables or making relationship between two tables, it does not matter what kind of data first table has, second table has. If there are two fields where the relationships could be created, and it does not matter if the cardinality is one to many, many to one, whatever. If the for that visualization, if this would work, then you can use the blending. For example, we are aggregating the total sales at the region level, right? So for that aggregated result, this blending would work. It will give you the correct visualization. And it's a very powerful feature only available in Tableau. Okay. You can bring two data from two different businesses and you can analyze the data by based on one of the field which is blended. There are a lot of examples, Prerna. One of a few of the examples I gave, you have two different businesses and you want to analyze the data for two different tables. Let's say you have the sales information for um, uh, electronics business, sales information from the food business. You can compare those two side by side just using the month fields, which will be present in both of them. So you will just use the relationship on that, make the blending based on that, and you analyze the data. Secondly, blending is visual specific. Visual specific. If there are multiple, depending on the type of visual you choose, if there is a different field you want to blend the data for in one sheet, you can use that column to blend. If there is another column to blend in another visual, you can use that. Okay. So you can do all of that. Okay, so in each of the sheets, you can use different fields to make this blending and you get this output as per the blending is working. Okay, for example, if you have one table which is having product wise sales, now you have the product name, you have the month name, you have the sales. Okay, now in another table, you will have information like, uh, let's say the product wise, month wise, region wise, you have budget information, right? Now, if you want to aggregate the data over the just the product level, if you want to show the summary, you can use the relationship just based on the product, and you can make sorry the blending based on the product, and you can view the result in one tape. In another sheet, you can use the blending based on the months, and you can show the results by months. So there is all this can be done for individual worksheet. If you go to the new worksheet, Once again, you can use a new blending option and you can visualize the data based on the new blending option. Okay. Another thing is that, let's say you have one table having the day level information, right? Another, and the second table is having the month level information. Now, day and month, you cannot make any kind of joins with those. It would not be possible. You cannot make any relationship with those. But just based on the blending, you can do so. So you can blend those and you can date, you can show the results at the month level when you choose the date, right? Like we saw in the first, this example, right? In the sales trend, I chose this relationship to be at the, sorry, the visual at the quarter level. You can show this date at the month level, and the other result, which is already at the month level, you can use that. Okay. So blending is much more versatile. It does not matter what kind of level of details two tables have, as long as the visualization requires that aggregation level and there is a field with which you can blend those two tables, you can use blending. Okay. And it's quite like commonly used when Tableau is required, especially when you're using two different data sources, then you go for blending. Because even if you are not having, even if you have same level of detail as well, when you're using two different data sources, you don't get those option of uh, joins and the relationships as well. If you see here in the example, you're using two different data sources. One data source is this. If you go to the data source, we are on the regional targets data source. This is separate. Here you don't see the other data source that you have the product sales, right? So here all these joins relationships, that is related to one data source only. If you go to the this, and if you go to the uh, data source here, regional target, we saw product sales. If we need to go to the product sales, it'll take you to the product sales, and here you don't have the regional target, right? So this is blending is, you need to use blending whenever two different data sources are there. You can have the logical, you can have the relationships, you can use the logical layer as well for two tables. You can use blending as well. One of the most important difference here is that you cannot use relationships joins when you are using two different data sources. So when you connect to a data source, and if you're using two different data sources, one is coming from an Excel. For example, let's say one data is coming in an Excel file. Another is coming from a SQL database. These are two different data sources that you're connecting to. You cannot do any kind of relationships or any kind of joins between these two data sources. There you need to use blending. There is no other option. Okay, so we learned about combining the tables. We learned about the joins, unions, relationship. We learned about that, and we learned about data blending, right? So whenever you are getting the data from one source, you use the joins, relationship blending, right? So whenever you use, when the tables come from a single source, you can do joins, you can do relationship union, you can do relationship. When tables appear from two different data sources, then you can use data blending. Okay. Data blending. In terms of the transformation, we learned a few transformation, like you can do a split column that we learned. There is one more transformation that you can do in Tableau, which is you can do pivoting and unpivoting. That is feasible. Actually, you can do unpivoting. You don't have pivoting option. Okay, let me show that to you here. So we'll open a new workbook. Okay, we'll open a new workbook and we will use this example called pivot and pivot example, right? So this is the same example which we also learned in Power BI. Okay, so here revenue by year, for example, we have the data coming like this. So you have year wise revenue for zones, and you have these revenue coming in multiple columns, right? So we learned in Power BI, if you remember, that these can be transformed. We can get these into single column, and we can have one column for the year, one column for revenue, right? So this is called unpivoting. You can do unpivoting of columns. So that feature is available in Tableau directly. So how you can do it? Just select multiple columns here by pressing the control key and select. So I have selected these four columns here, and I can do a pivot. Okay, pivot. If I click on pivot, it will now just do the pivoting of your fields, right? So you got this pivot, you got this column here, right? Pivot. Now we need only the year part from it, so that we can handle. We can go to split, okay, and we got this year part from the split. Rename this to year, rename this to revenue, and you can keep this field, or you can hide this field if you require. Okay, you can go ahead and hide it. So you'll get, you can do this way, you can get the data unpivoted. You connect it to the pivot and unpivot example file, and we selected this revenue by year table. Okay, so this has these years, yearly revenue coming in multiple columns. We need the year in one column and the corresponding revenue in another column. That's how our data should be. So here you can unpivot the columns. That is feasible, which means if you have data in multiple columns, you can unpivot them and bring it in one column. So you can select the columns which you want to unpivot. These four columns you have selected, and just go and do a, it will, the name here is pivot. So you're pivoting. Okay. So it will just pivot your data. Basically, in other terms, pivot means that you're changing the direction from rows to columns. Select multiple columns, Prerna. Then only you will see the pivot option. So here in Tableau, you can do this pivoting, but you cannot do the opposite of it. So unpivoting is not available. That is the limitation. Okay, this is available in Power BI. In Power Query, we can do both. But in Tableau, you can only convert multiple columns into rows, but the opposite is not feasible. Okay, now let's deep dive more into the fields, understanding the fields, and learning more on the visualization part. Okay, so once again, open a new file, and this time, once again, we will use the sample superstore data. Okay, so we'll create a new one, and we will use sample superstore data. Okay, open new file with sample superstore data. Use orders data here. Okay, orders data, and you can go to the sheet, open this Tableau workbook with sample superstore data with the orders table. Okay, so in Tableau, there are the fields that we are bringing directly from the data, and there are some automated fields which gets added once you load the data in Tableau. Okay, so there are minimum 3 fields that gets created automatically, and maximum 5 fields that get created. What are those fields? So if you notice here, you have the data and you have the dimensions and you have the measures. So there are these 5 fields that you will see which are not in the data, but those got added here. One is measure names. Now you did not have it in the data, but you can use it in the visualization. You did not have latitude, this is automatically generated. Longitude, this is automatically generated. You have orders count, which is count of rows in the orders table. Orders is the name of the table, and count is basically row count. Okay, so it is giving row count as a separate measure, and then measure values. Okay, so these five fields gets automatically created. So I said minimum three fields and maximum five fields, and here we can see all the five fields. So whenever we have any geographical field, then these latitude and longitude, these two fields gets created. So automatically, if you have any geographical data like this or postal code with the type geographical role, then it will generate the latitude and longitude automatically. Okay, latitude and longitude gets generated. And whenever you are visualizing any data on the maps, it uses latitude and longitudes to create those. Okay, in if you remember, we created the map visual. Let's go back to that map visual. Okay, and if you see in the fields, it actually used these latitude and longitude fields. We did not select that, but it used those fields to pinpoint these dots in the map. Okay, so these are automatically generated fields, latitude and longitude, which we can use. Okay, where if you do not have geographical data, then these would not be there, but at least these three would be there: measure names, measure values, and row count. Okay, measure values and measure names, these fields are used whenever you are specifically you are using multiple measures in the visualization. Then the measure names and measure values fields come into play. We will cover that in a bit. But firstly, remember that these are all auto-generated fields. So if you ever get this question, which all fields are auto-generated in Tableau, then you should know that there is measure names, measure values, row count, latitude, and longitude. These are the five that gets automatically generated. Now, let's say I want to create a visual now, and let's understand how we can create a visual from the scratch. So I'm going to start with a text table. Okay, how we can create a text table in Tableau. So text table, let's say I want to see how um, what is the total um, sales, profit, quantity sold information is by each subcategory. I want to know this information. So what we will do is I want to see this by subcategory. So I'll drag subcategory into the row shelf. Okay, subcategory got added in the row shelf. Okay, now I don't want any visual like a bar chart or line chart, which I get if I select any measure into the column. It will convert into a bar chart. I don't want that to happen. I want to visualize this in the form of table. So in that case, you can use this text mark. Okay, text mark, and you can bring any field from here onto the text mark. Okay, and see if you're able to see sales in the form of table, sales by subcategory in the form of table and not by the graph. So we got this created over here. Now I want to create, I want to have another one, and I want to create a table over here with the name of these measures appearing. Right now it is saying just the subcategory and there is no label for it. It is not giving that label. Like what is this? Okay, so I want this to appear. So for this to appear, we need to use these virtually created, this automatically created fields called measure values and measure names. Okay, measure values and measure name. So what I will do here is drag any other field profit and drag and put it on top of this field. Okay, drag. Let me show this once again. Any other measure, just drag and drop it on the this value section, and you will notice that a lot changes in how the configuration of this visual is. Are you able to see the same output as I'm seeing? Okay. Now you see a lot of things have changed over here. You can see that detail, in the detail, there is in this text, there is measure value has appeared over here. And the list of measure values that we have selected, sales and profit, I can see those over here. The label of the measure names have appeared at the top. So the measure name has appeared over here in the column measure name. Okay, so name all of these measures contains the value, and measure name field is always used whenever we want to display these measure names onto the visual. Okay, measure names would appear over here. And this is specifically used when you want to use multiple measures onto a table visualization. Also, this measure name, this measure name actually contains name of all the measures that you have in these measures list, and it now chooses what we want to display here. How? Because we can see this measures added in the filter pane. Measure names have added in the filter pane. Okay. So what happens here is it has automatically identified that we are trying to add multiple measures, and it has shown that, okay, out of all the measures, I need to display profit and sales. So there is a filter that got applied that measure names only show two measure names here, profit and sales. If we want to see how this is working, so in the profit, in this filter shelf, you can go to the drop down and you can go to show filter. Okay, this filter, show filter. Just by selecting show filter, it will show this filter as what we are showing and what we are not showing out of all the measure values. Now, directly without adding anything from the fields, from this filter of the measure, I can choose if I want to show quantity, I can just select and another field for quantity will be added. If I need to select discount, another one for discount gets added. Okay. So from here, I can choose which field I want to show, which field I don't want to show directly in the measure filter. But the step for creating this would be like this. This is the easiest way to create this whenever you want to display the measure names in the tables. Whenever you have created anything and you see that it is not like you have made some mistake, you want to restart. Okay, you want to restart, you can always go and clear the this. So there is this option of clearing visual in the quick access toolbar. Clear all the visual, whatever that you have created, clear the sheet from here. What we wanted to do, I wanted to do subcategory wise. I wanted to see my measures. So I added sales first of all in the text field. Then I added profit on top of this. Automatically the measures appeared. I wanted to add more. So one way is that I can add now here in the measure values, I can add more. So I can have discount over here, added over here. This will show, or quantity over here. Measure values, I can choose this. Or I can use this measure filter, show filter, and I can choose which one I want to show and hide. This is also changing these measure values over here, what I'm choosing to show and what I am not choosing to show. So this is how you can create a text table with multiple measures. Ron will come to that. We'll come to that one by one. So this is text table. Okay. Now let me create another sheet here. And this time I'm going to create a table with the similar table, but with the some color coding into that. Okay. So once again, the same thing. I added the subcategory here. I added the sales, profit. I added the other measures here. Quantity, discount. I have this. Okay. Now I wanted to do some color coding on these. Okay. I want to do color coding. So I can simply bring the measure values and drop it on the colors shelf. Drop it on the color shelf. Now I have added this color coding. Now, wherever we are putting the fields in on this visualization on whichever mark type, you will see that, okay, this measure value is being selected for two types of marks, right? For the text data, for the colors. And now I want to, in this, for this measure value for the colors, I'm seeing this colors applied on the text. Okay, color applied on the text. So if I want to change the marking of this, I can go and make the changes in the marking. I can select this from automatic to a square. Okay, square. So if I choose the marking to from automatic to square, it will color the square. Okay, it will color the square. Square is basically the background of this cell where this text is. So now I can see the color coding by the all of these measures. Now, can you tell me, is this color coding actually correct? Is this how I should be color coding my data? Zildus, you're saying sorting may be required. Yes, that's good. We should always be trying to sort the result. Problem is one scale applied to all measures. Problem is one scale for all. You have one single scale for the range of all the values and you have applied to everything, all the measures. Each measure, for each measure, your range of values are different. You cannot compete the values in the quantity column with the sales column. They will always be, quantity will always be lesser because sales is quantity multiplied by price. So sales will always be much bigger. The number would be much bigger as compared to quantity. So quantity is all coming in this grayish color because all the values are almost negligible as compared to the sales, right? So that's why everything in really big, like dark blue, is either coming from sales and some coming from profit. But if you talk about discount or quantity, these are very small value as compared to sales. And that's why this range is not telling us much. 567 sorry, not 567 quantity, but maybe 590 5974 is a very good quantity figure for binders, but it is all showing that it's color coded with low value, low scale. So this range, one scale applied for all the measures, is the fundamental problem here. Okay, so what you can do here is you can change this measure value here where the color is applied. Go to the small drop down here and choose this option of use separate legends. Use separate legends. When you go for use separate legends, there will be individual scales for individual measure. New scale for discount, new scale for profit, new scale for quantity, new scale for sum of sales. Now you can choose which color you want it to be in blue color, red color, orange color, purple color, whichever color you go. but now there is a scale, individual scale being applied. Now I know when it comes to sales, then these are the highest one, right? Amongst the highest one above 300. When it comes to profit, then I know that copier are having the highest profit, right? Followed up with phones, then accessories. So I can identify these when I'm applying individual scales. Similarly, if we go to the quantity wise, binders are doing much better, papers are doing better. Okay, so I can see these different scales now. It's much better, and it is telling me the true picture of these high low values. Okay, Sai, so what we did, how did we do? There is an option in the color code where we have the measure values in the color code. You go to the small drop down and choose this option of uh, show separate legends. Right now, this is saying combine legends because we have selected show separate legends. So here there is an option of show separate legends. Click on that. Now for this color gradients that we have, if I want to give some other our own color gradients, okay, let's say I want to give my own color range, then I can do that too. So for individual all of these, let's say for the sales we have this range. Okay, if I want to give it some other color, I can go to this scale and I can go to edit colors. Okay, in the edit color I can choose what type of color range I want. So I can choose first of all the color. Let's say I want this to be shown in uh, green color. Let's say you want to use a green color. So it will create a gradient in the form of green color. You can apply this. Now sales would appear in this green colors gradient. Correct. Similarly, for quantity, if you want to apply some other color, you can go edit color. Let's say for quantity, you want to go with some other color. Okay. You can go with any other color. Let's say I go with blue color. Okay, so it will appear like this. So you can give your own color ranges for each of these legends. When it comes to profit, we would know that in profit, there can be scenarios where your values can be less than zero and greater than zero. Now you would want to identify those specifically that whenever it is less than zero, it should be in some other color. If you just put gradient, then it may not be able to do that. So what you can do is you can go to edit color here and you can specify whether you want to have, let's say you want to have a range and whether anything negative and positive can be specifically identified. So you can have a color type, let's say this is the range and you want to give a midpoint here. So you can go to advanced and you can give a center. Let's say center is zero. Okay. And there should be center needs to be identified and it should just give the values below zero in some other color gradient, above zero in some other color gradient. Okay. Similarly for discount, you can also do the same thing. Okay. So this is called your highlight table or table with conditional formatting. Both means the same thing. Okay. Another way with which you can use the highlighting is when you have too many data points and you want to use, you cannot see the values as such, but you want to see a heat map. Okay. You want to see a heat map. So there you can use the colors as well to just highlight what kind of, whether this you have some good values, bad values, those kind of identification you can do. So we'll go to the new worksheet and this time I'm going to use, um, let's say I want to use how the performance of subcategory sales are across all the states. Okay. So what I need to do, I want to use, say, states in the rows. So you'll have all the states over here. You'll put subcategory in the column. So you'll have all the subcategories in the column. And I want to use, let's say I want to see profit, how profitable I have the subcategories. So I'll use profit here and I'll put it in the color mark, profit in the color mark. I'm able to see all of these, just the color. I have not added any value, anything in the text label I have not added, just the color. So no values being displayed over here, just the color indicator is coming. Now I want to see the full range of values here as well. So I can go my view, change it to from standard to entire view. It will show the entire view. Now, is this something that is whenever you want to see a more detailed, like just very high level information about the how your um business is doing across the different region, I can get some high level idea directly with these kind of heat maps. Okay. For example, if my question to you is look at this heat map, first of all, create this. Now, let me just with this answer my question, which is the state where you are seeing consistent profits across the subcategories, states where you have consistent profit across subcategories. Yep. So we can identify just by, even if we don't look at the numbers, we can identify these kind of details with the heat map. I can, with the heat map, if there is something popping out, I can see that very easily. For example, if I need to know which subcategory is not performing good in most of the areas, which are those according to you? Which subcategories are not performing good, right? So these color codes are telling us which is not performing, where the profits are negative or positive. In copiers, I don't see any negative profit anywhere. Okay. White color indicates that there is no sales, there is no data point. Okay. So we can identify these informations. We can identify which is the worst state, which is the worst categories, which subcategories, which is consistently low across, which are good in most of the areas, but in some areas. For example, if we talked about two states, California and um California and New York. In both of these, all of the categories, subcategories are positive, except for the tables. Okay, let's look at this in the next example. So here, so I'm going to use the map visual here. Last time we used the bubbles on the map. This time we are going to use the filled map. How do we get to that? So first is any kind of detail that you want to see on your visual beats, any kind of categories, you can bring it into the details shelf. This will add some values on your uh, worksheet. So remember, to visualize anything on the map, you can go to this, you can select country on the details, and automatically this will appear on the map. Now what it did is, because it identified that country is a geographical data, so it can use this latitude and longitudes. Okay, these are dynamically generated latitude, longitudes, and it pointed it on the map. Okay, it pointed it on the map. Now, this gave me one default map visual that is there that we had here. If we now need to change it to some other map visual or any other visual, another way that we can go about it is this show me panel. Okay, show me panel we haven't covered so far, but it is very powerful, very useful. not powerful, but very useful when it comes to creating your visuals. So if you expand Show Me panel, it tells you the 24 visualizations that are there. It gives you all of those. It gives you detail about all of these visual, how many dimensions and how many measures are required to build any visual. If you hover over, for example, this text table, if you see at the bottom, it tells you one or more dimension, one or more measures are required for you to use this. Okay. Then heat maps, you need to use one table, okay, and one dimension, one measure minimum. Then highlight tables, you need to use one dimension, one measure. For this symbol maps, you need to use one geographical dimension that is required and zero to more measures. So right now we have not selected any measure, we have just selected one dimension. That's why it is appearing. So for all of these different types of visuals, it tells you which dimension, how many dimensions, how many measures you require for you to use it. Now, when we selected country in the details, it automatically created this latitude, longitude, and it gave me this map. But I want to use this filled map, other map. So the only way that you can go to the filled map is through this show me. And now you switch your visual to this one, filled map. Okay, filled map. What this do is now it fills all the region with some color. Okay. Now I want to add more details over here under country. Let's say you add state as well in the detail. So go add state to the detail. Okay. Now you have the states appearing here. All of these boundaries are now coming by state. You are able to see state. But at the moment, these states, all of these are just without any further details, just the label of these states with a default blue color. I want to highlight this by the profitability, which is more profitable. So go to profit, give color to this, and now it will tell you which state is more profitable, which state is less profitable. So similar way how we have created earlier, we gave the color coding, but that time we used the this symbol map where we can use some shapes, and the default shape was circle, right, or the bubble. And here we are talking about the field map. Now in the field map, we can also add some more details. Like I want the labels to appear over here. I want to have some labels. So this mark is for you to show label on the visuals. Okay, label. So let's say if I want state to be labeled as well. So you can go put it on the label and you will have the name of the states appearing on the chart. Let's say you want to also see the sales for these from these maps. You want that to be appearing here as well. So you can bring sales, add this to the label too. Now you will have the sales as well as the name of the state, and the color coding is based on the profit. Now you see that with this way, this some of these labels are not appearing because of the size is too big. Your text size is big. I want this text of the states to be smaller. Okay, it should occupy less space. It should be smaller. So you can go to this label mark. Okay, go to the label mark. And here, if you click on it, you get the formatting option of the label. Okay, one of this is decrease the font size. So we can go and decrease the font size to, let's say I decrease it to 8, right? We decrease the, okay. If we want to decrease further, we can type and decrease it further as well. If I want to decrease it to 6, I can type and enter, and this will be even lesser. The text that is appearing over here, this text is appearing like you have the state name come, then the sales is coming. If I want this appearance of the text to be slightly different, then I can go here in 3 dots and I can choose how this should appear. If you want this uh, state name after the sales, you can do that. So this is how it is coming. So if you want to add some more formatting over here, you can do so. Let's say before the parameter, which is sum of sales, you want to have that just a label that we are showing sales. You can type sales, put a colon, something like that, and apply. So it will also show that sales is equal to this much so that you don't get confused. But you should always avoid having too much of text on the visual. Now the sales is being repeated in all of these states. I don't like this. So for the users who know that we are displaying, we're using sales, they'll get accustomed. You can add this detail, but repeating the same information is always not recommended, but you can do so. If you want the font size of the state smaller, name of the state, but the font size of this measure sum of sales bigger, then select only this part and increase this font size of this to 8. And now the sales value is bigger, but the name of the state is smaller. Okay, so these kind of label formatting you can do on the visual. Right to your question, only few states and their sales are appearing on your map. That is because of the, if you have too big text size, then it will not show all the value. If your graph is small and your text size is bigger, it will not show. Okay, do one thing, look at this in the full screen. Click on it and look at this in the full screen and see if you are able to see more states and the values. Result is for the color coding, we selected profit and selected and dragged it and dropped it on the color mark. Profit on the color mark. Okay, you need to change the map type. You need to change the map type. So go to show me here. Instead of this map, use this map. Okay, use the filled map option. So we learned about how we can create the stack bar charts. Let's just once again look into that. Okay, now here I would want to see how my regions are performing. Okay, and within the region, what is the contribution of each category within that region? Okay, I want to see that. How is the contribution of each category within the region? So we have this region. I can bring that into the rows. I can bring sales into the column, right? I can make the view as entire view. I can add the label, correct? Now I would want to see the breakdown of each region by the category. Okay, so I can bring category into the color mark. Okay, now I can see what is the contribution of each category within that region. So this we use the this option data label, not the tooltip. So use the data label option. Select this option for the data label to appear. Okay, now I'm able to see the values of these all the categories by the region. But let's say I want to see these values in the form of overall percentage of total values. How much do these values are? So in Tableau, there is a feature called table calculation. Table calculations, those are just easy calculations that you can apply on top of the results that you see on the sheet. Okay, so for example, this is the result that I'm seeing on the sheet. Now, instead of showing this in the form of numbers, I want to see this as a percentage of total values. Each of these is percentage of total. So this measure that we have here You can go to this small drop down for the measure on top of the measure. You can go here and you can move to table calculation, and you can go to a quick table calculation, and you can change it to show the percentage of total. Percentage of total. Okay. If you convert this to a percentage of total, you will be able to see all of these in terms of percentage like this. Now, out of all of these, we can know that, of course, West is having the highest sales, but actually, the biggest sale for the category, any category, is in the East region, which is technology. Technology in the East is having the highest amongst all of these, 11.5%. If you want to show both the values as well as the percentage of the overall total, you can do that too. Okay, so what you will do, sales, you drag it on top of the label. So you want to see the sales in that label. Now what happened? In the label, you are only seeing the sales value, not that table calculation. Table calculation is for the column value. Now this is only displaying this axis here, but the label is being shown in the form of the sales. I want even the label to show the percentage of total. So you can add sales once again in the, sorry, you don't need to add it once again. You need to first change it to table calculation quickly here in the display. Change it to table calculation. Now this is modified to show as a table calculation. And now on the label as well, you see this value. And to display sales as well as the figure, once again add the measure over here. Okay, so now you can see the percentage as well as the actual values both coming on top of the on the visual. Okay, if you want this to just appear below that, you can change the sequence. Region wise sales, show entire view, add data label. Okay, now if I want it to be sorted, let me also sort it. Show the sorted result. So this is sorted by region wise total sales. Now let's say for now I want just this sales to appear on the label too. Sorry, I want this to be divided by category. So add category into the color. Okay, category added to the color. This data label is already coming. Now I will bring sales into the data label as well. It will not change anything because sales, we already selected the data label. But basically I want this sales not to be shown as the sum of sales, but as a percentage of total. Okay, so go here and change it to a table calculation, quick table calculation, percentage of total. On any of the fields, if a table calculation is added, you will see this triangle symbol. Whenever you see this triangle symbol next to any field, it means that some table calculation is being applied. This is still shows sum of sales, but we have applied some table calculation here. Okay, this triangle will confirm that. So now another sales label you can add, which is sum of sales, just as it is. Okay, so just do that. And if you want to change the order, you can do that. So the next visual that we are going to cover is tree map. Okay, tree map. So what are tree maps? You have seen that in Power BI as well. What are tree maps? So tree maps allows you to show contribution of, like when you have a any value, it could be sales, it could be orders, any kind of measure. If you want to see what is the contribution of each categorical data into that measure value, and you want to see everything in a single view, you don't need to scroll your visual, just whatever defined space that you have within that. If you want to see all the data points, then you use tree map, and it basically lets you see which are your top contributors and which are your bottom contributors. How will we go about tree map? Here, we need to first select any category, okay, anything that with which we would want to see the distribution of our data. Now, let's say I want to see first the category, okay, first category. So I'll bring category into, I'll select category, okay. Another way that you can do here is, because tree map, you will not get it directly from by adding to rows and columns. That will come from show me panel. Okay, so you'll need to select show me panel here to be able to use tree map. So what you do is you select two fields. So you have selected category and then you select sales. Okay, and press control key and select. So now you see here I've selected category and I have selected sales. Now I have selected one dimension and one measure. And in the show me panel, I'll be able to see all of these visuals which supports one dimension and one category. Sorry, one measure, one dimension and one measure. Which are those? Which are those? So table, highlight table, this table, pie chart, these. So some of these visuals support this, which are highlighted over here. We will select tree map from this list. Okay, so go ahead and select tree map here, right? It will create tree map directly. So you should be able to see your data like this. Now, if we need to see the data in more detail, we can add further hierarchy in our tree map. So currently it shows technology being the highest when it comes to sales, about 836,000, followed by furniture, and then followed by office supplies. So in tree map, your always results will be in this sorting from left top to right bottom. Highest value will be over here, lowest value will be over here. Okay, that is how tree map shows the result. Now, if I want to see along with the category, if I want to see subcategory as well, we will add subcategory onto the label mark. Okay, add subcategory to the label mark and see if you are able to see detail at the subcategory level. Okay, subcategory onto the label. Okay, are you able to see the result like this? So you have data for the technology categories and all the underlying subcategory within the technology over here. Okay, within this block, highest would be phones and then lowest will be copiers. Similarly, for furniture, chairs would be the highest selling one, and then furnishing would be the lowest, and so on for the others. Okay, so what did we do really quickly once again? I'll show that once again. So I'll remove all the visual. We selected category, then we selected sales, we selected two of these measures. We can see all the possible visuals that we can create here. One of them is tree map. So select tree map. This will show category wise sales information. Automatically, it has created this sales with the color, gradient color, and size with the size based on the sales as well, right? So this configuration automatically happens once you select tree map. And then we added subcategory into the label text. Now I am able to see these labels here. I'm able to see the labels. So technology, phone, all of these labels are visible. But I would also want to see the actual sales values, right? So I can bring sales as well onto the label, okay, onto the label, and we can see the labels as well. Okay. So here in this visual, we add first we have added category, and then we added subcategory. Okay. So in when you talk about dimensions in your data, some dimensions always are hierarchical in nature. Okay, some dimensions are hierarchical in nature. So can you give me example of any hierarchical fields, like the fields which have hierarchy which falls under some hierarchy in this data. Can you look at it and tell me if there are any fields which are part of a hierarchy? Okay, so in this data, I think this is good enough. So when it comes to hierarchy, so you give correct examples. So here we have these fields which are part of hierarchy. Hierarchy, there is a natural hierarchy in the relationship between these. Now, first let's talk about the product hierarchies. Okay, product hierarchies. To give example of category, subcategory. We also have product here. Okay, so wouldn't product be part of the hierarchy too? So product would be the hierarchy as well. So here the hierarchy could be, you will have category, under category, you will have subcategory, under subcategory, you will have products. That is the hierarchy. Then you gave the example of geographical hierarchy. Okay, in geographical hierarchy, what is my hierarchy? Here I have data by country. Then after country, the next hierarchy is state. Okay. Then after state, you have city. Okay. And then in this, we don't have anything more granular than city, but that is our hierarchy. So it will be country, state, and city. That will also be a hierarchy. If you notice, when we select any date related field, Tableau automatically helps us use that hierarchy. Okay. So if you remember, when we select any date over here, let's say the order date we select, here we already have this hierarchy built in. So if you see, this is showing in the year, automatically the year part comes in. And if you see, once this hierarchy is there, you also get this plus button over here. Okay, this plus button. So this basically allows you to leverage this hierarchy just by clicking on this plus button. It takes you to the next level, then it takes you to the next level, then it takes you further to the next level. Okay, so this is how the fields which will have hierarchies defined would work. Okay, now we know that category, subcategory, product are part of hierarchy. So when you have such data, then you can define the hierarchies in your data so that when you use them in any visualization, you can use the this hierarchy feature. Okay. So how do we do that hierarchy part? How we define hierarchy? So here you have, let's say, I go to this small drop down over here. Sorry, not here, but let's say category. Just go to this and do a right click on the category, right click on the category. Okay, and you see this feature of hierarchy, and just click on create hierarchy. Okay, create hierarchy. Now you can define what this hierarchy name would be. Let's say this is called, you can keep it as product hierarchy. Okay, product hierarchy you have created. Okay, now within product hierarchy, now you have category under this. And now if you need to use this anything in the hierarchy, just go select any field which should be part of this hierarchy. How do you go to? How do you do this hierarchy? Now let's say the next one that I want in this hierarchy is subcategory. So one way is just you can drag and put it just below category, and this will come in that hierarchy in that order. Then you put product, go put it just below the subcategory. So now you see this entire hierarchy got created: category, subcategory, and product name. How do we create the hierarchy? Just go to category field, go to this options, and you have hierarchy option. And here you will get option to create hierarchy. Just create hierarchy, name it as product hierarchy. As soon as you have added these hierarchies, category, subcategory, product name, these are part of this hierarchy. You must have noticed that these fields that we have added in this visual, they also have now this plus minus symbols. Okay, now these can be added or removed at the hierarchy level too. So if I need to add product into this visual, I can simply go and go one level down into the hierarchy, and I'll just change this visual at the product level. Okay, now I can directly select one of the fields and just roll over, drill down into the hierarchies easily. Now, every time whenever I'm going to use these fields, this hierarchy feature will always be available for me to use. So this is about the product hierarchy. The other hierarchy that we spoke about was geographical hierarchy. Okay, geography. So uh, let us create the geography hierarchy too. So for geography hierarchy, the highest one would be country, then state, then city, right? And one of you rightly said that we can also go to the postal code level, right? So postal code, yes, that can also be the hierarchy. Okay, so let's do that. You can go to the country and create new hierarchy, create. So this will be geographical hierarchy. Okay, so in geographical hierarchy, you will have country, you can bring state below country, city below state, and then you can have postal code below city. And this also makes our overall view of the data also smaller. Whenever we need to use any of the fields within the hierarchy, we expand this hierarchy. Otherwise, we can collapse. So overall, from looking at all the data as well, this just makes the data more organized. All right, so let's move forward. So I want to now, we looked at the tree map visual over here. I want to now show you another visual, which is called scatter plot. Now, all of you may have seen scatter plot in some or the other way. In like this is a very common chart, right? So basically, why do we need scatter plot? Any idea? Anyone? Why do we need scatter plot? What purpose does it solve? Scatter plot. Okay, scatter plot is not has nothing to do with the geography. Scatter plot is used whenever I want to see some correlation between two measures, like how two measures relate with each other, how two measures are correlated. Okay? How two measures are correlated. So when I say this, we need to first of all understand what is correlation. What is correlation? Do you know what is correlation? Correlation. All right. So correlation is when you have two measures, then what is the impact change in one of the measure would have on the other one? That is correlation. Okay. For example, let's just think about some common examples. For example, let's talk from the point of view of four-wheelers, cars. Okay, they're cars, and you like most of the scenarios you may have seen that the more features a car has, right? More features a car has, let's say more safety features, more advanced features. When there are more features, would price of the car go high or low? So most of you would agree that it will go high. The more features you have in the car, higher in general the prices would be, right? In general, that is how the correlation should be. Now there can be hundreds of different cars that are there in the market, hundred of data point. You will have all the brands, all the models, all of those would be there. But in general, there would be this kind of correlation. Higher the features, higher the price. So this kind of relationship is positive correlation. One thing increases led to increase in other thing. Now let's talk about the uh, when we say, let's say the uh, let's talk about the what mileage your car gives, right? Mileage, like how much it can, how many miles or kilometers it can go in 1 liter fuel. Normally you would see that cars which are highly priced would give lesser mileage because of the other factors. So in general, you are going to see that trend as well, that high mileage, low price, because they will be lightweight, there will be several other things that will make them give better mileage. But in general, that is how the correlation would be. Higher mileage, lesser price, higher price, lesser mileage. This kind of relationship where one, if one variable goes high, the other variable go low, then this will be called a negative correlation, that these two variables are negatively correlated. And then there can be two factors which would be non-correlated, right? Or just neutral. Now they could be, let's say, they could be boot size and mileage. Let's say there would not be any pattern, right? Size of boot increases, but mileage can go up or low. So there could be these variables which will not be related if they don't show any specific pattern. So those kind of correlation would be neutral. There is no relationship. They are neutral. So these are the correlations that a scatter plot lets you explore on the overall data, on the overall all the data points that you have. Okay, and this lets you just understand your data better. Okay, it just doesn't tell you about one of the field or one of the detail, but it tells you overall how your data is behaving. Okay, overall how the data is behaving. So let us explore this and see how scatter plot looks like, and let's look at it on this example. So for scatter plots, we need to use two measures. We need to use two measures. Your x-axis should be a measure, your y-axis should be a measure. Okay, so I'll put sales, drag and put them on the column. I'll put profit onto the rows. Okay, and automatically when I use two measures, one in the x-axis, one in the y-axis, automatically this plot is selected as scatter plot. Okay, scatter plot. Okay, now if you see here, we have this scatter plot selected over here, scatter plot, which is used whenever you use measures. The minimum requirement is at least two measures needs to be used. Okay, and here we see only one value over here, one value, which is this profit and sales. And why we see one value? Because currently the setting is whenever we display any data, this will show the aggregated data. So across all the rows that I have, it is summing the total profit, it is summing the total sales, and it is showing us this 1 point. And that does not help me understand anything. Okay, this does not help me understand anything. So whenever we want to use scatter plot, we need to see this at some level of detail. Okay, some level of detail. So here I can go, and first of all, if I don't want to see the aggregation of the measure, then I can go, and from here in the analysis tab, I can deselect this, that don't aggregate the measure. By default, this is aggregate, measures are aggregated. So I'll just remove this aggregation of measure. Just by removing it, now you see sum of sales, sum of profit is removed, and we see data for each row now. What is the profit that we have? What is the sales that we have for each row? Okay. Now in this one, we'll try to understand this data a bit. So what are we looking at here? So we can see that all of these, each dot here represents a row, the data row that we have. Okay. Within that data row, we are able to see uh, how our data is consolidated, where the this sales and the profit values are mostly lying, and whether we have any kind of outlier from our data. So this tells us a few outliers that we can spot over here. For example, there is this row which is having huge sales, basically highest sales, but it is not resulting into any profit. Okay, it is not resulting, giving me any profit. Okay, what is this about? Okay, what is this about? So you can just identify these outliers from your data using this scatter plot and see where are these outliers. Another one here, very low profit. What is this for? You can look into this, like what is this data point for? Is it specifically for uh, any sales that we discount that we ran, or we gave uh, some freebies? What was it for? That our sales is there, but the profit is negative. And we can go here, click on this, and we can view this data, right? This is the data over here, and we can see, okay. So basically, I can have one more table here, which will have the order level data, and we can see that information. If I need to see order as well over here, then I can add that to the tooltip too. Okay, so order ID I can bring and add it to the tooltip over here. Okay, and I can actually see which order it is. Okay, I'm able to see which order that problem was in, and we can deep dive into that. We can further make it more informative by adding more details to this. Like, I want to just segregate all my positive and the negative, sorry, values of profit into some of the color codes. So I can bring profit into the color, and I will just keep the profit and loss into two different colors. Can go and modify these colors into just not this gradient, but just two colors. So you can change it to step, and in the step you can make the step size to just 2, and you can keep anything negative with 0 with red color, anything positive you can keep it, let's say you go ahead and make it green. Okay, so just these two colors. Okay, now you are able to see only these. So overall on the data, if you want to see any kind of correlation between two fields, you can do that with the scatter plot. Now let us use another example, and this time I'm going to use not this detailed data, but a bit less detailed. I want to see the performance of each region, how the performance of each region is being. Okay, and we are going to once again use the um, scatter plot for this. Okay, so I'll put once again sales into the column and profit into the rows. And this time I'll let it remain aggregated, because I still want to aggregate it, but I want to see the details by the different region. Okay, so I would just go and put region into the color. Okay, region onto the color now, and I'll be able to see these 4 regions over here. Now, just by looking at it, uh, we can tell that which region is performing the best. Let me make it even this colors to not the these bubbles, but the filled color. So let me make it filled color. How we can do that? This color that you have over here, and you have this shapes coming as automatic over here, right? Automatic. Here we can go to shapes over here, shapes part, okay, shapes. And here, instead of these shapes rounded this circle with this just uh, with this hollow circles, we'll make it a filled circle. So use this one, filled one, choose this shape instead, and this will become filled, right? This will become filled. So just, it's better when you want to just understand the color. Sometimes when you have too many different colors, then filled colors would make it easier for you to identify which color we are looking at. We can make the size a bit bigger too. Now we have these four colors for each region. Now within each region, now I want to see within each region which category is performed better. What is the behavior with sales and profit for the category? So I can bring category, which is here in the product hierarchy, category, and I can put them into the shape. Okay, into the shape. What it did here is each category would now be of specific shape. Now, earlier we had a clear winner when we were looking at the data at the region level. We had clear winners, right? So we knew that here in the region, West region is performing the best, then followed up with the East region. Then if you see the South and the West, although South has lesser sales, but profit wise it's better. So then South, and then you have the Central. But once I add category into the details, now the situation changes a bit. Okay. So what has been winning across may not be winning across like entirely in the region, is not winning across all the categories. Okay. For example, West, which is having highest profit overall. But now if you see in West, specifically the furniture category, it's among the lowest, right? But you can see that comparison with like every other region as well. This is on the lowest side only. So all these circles are representing furniture, and furniture is amongst the low performing category across. When it comes to high performing categories, then somewhere office supplies are leading in the West and in the East, right? And then you also have the technology leading in the West and the East once again. So both of these in the West and the East, technology and office supplies are amongst the highest contributor. We can see more details like this. These shapes, we can once again go and change this. If you click on the shape, it will show what shape palette we are looking at. If we want to make it some different palette, we can go and change the default to filled. If you want to see the filled palette, so go change it, make it filled. Okay. And sorry, you need to assign it. Go filled, and you can assign this palette, apply. Okay. So this is another scatter plot. Next up, we're going to learn how we can use pie chart. So pie chart is again one of the visuals that you can only create using the show me panel. Okay, you need to use show me panel. Then you can use the pie chart too. So let's say I want to see what my sales are across the region, and I also want to see what is the percentage contribution of each of these region. So I can go and select region and select sales. Both of these are selected, and go to the show me panel and select pie chart. Okay, so we've got this pie chart. You can make it an entire view. If you want to see all these labels on this for the region, you can do that. You can go and add region to the label. So you'll have the region name. If you want to see also the sales value to the label, bring sales to the label 2. If you want to see sales as along with what is the percentage of total value, so we can apply table calculation on this and see what is the percentage of total. So go with sales, change it to quick table calculation and show it as percentage of total. So we can see the percentage of total sales. And once again, you can bring sales with sum of sales here in the label. Let me know if you are able to see the same result as I can see on my screen. Remove the visual. So I selected region and sales, choose pie chart over here. Okay, make it an tab view. Okay. Now currently this does not show anything on the label. So just add, say, the region name, total sales value, and the percentage of total in onto the label. So we'll add each of them one by one. Region, add to the label. Sales, add to the label. If I need to convert this sales label into the table calculation to show percentage of total. Okay, and now I can bring sales once again. Okay, percentage of total, this is a table calculation. Okay, remember yesterday in the last class we learned about the table calculation. So this measure sum of sales, go to this and add a quick table calculation. What is table calculation? That table calculation is within that visual, if I want to do any calculation on top of it. So all the sales value that I'm showing for each region, I want that to be shown as percentage of total sales. So I choose table calculation, percentage of total. Let us change this view to entire view at the top from standard to entire view. Now I want this labels that we are showing. I want to make these labels slightly smaller. Okay, so I want to fit them inside this pie. Okay, how can I do so? One is I can make these labels slightly smaller. So all these fonts that we have on the label, you can make them smaller. Let's say I make it at 8 font size. Okay, that is one thing. Okay, now let's say I don't want to show these 2 decimal places here for these percentages. I want to show only to 1 decimal place. I don't want to just show it to that much of detail with 2 decimal places. Okay, so if I need to do so, I can just apply the formatting changes on these fields. So here you can go to this one which has the table calculation. You can go click here and go to format. Go to format. Okay, this will take you to this new pane which is on the formatting side. Okay, on the formatting, you can go to this pane formatting, and here you have this number. You can go to number. You can choose, because we are showing this number in percentage, and you can choose the decimal places, move down to 1 decimal. Okay, this will allow you to change whenever you need to increase or decrease the decimal places on the field, or any kind of number formatting you need to update. You can do it on here. Now this is formatted properly. How did we go to format? You can click on any of the measure that you want to format. Go here and click on format. You can go it from here. Also, there is a format tab at the top. But let's go from here. This will open this format pane, the sidebar. Okay, in this sidebar, you have this field name selected, format for percentage of total sum. And here the numbers we are showing here, I want this number to be formatted in some other format. So just go here, change it, which format you want to show it in. This is a percentage, choose the decimal. Next, that change that you can do is you can bring these labels from outside the visual to inside. And this is very simple. Just directly you can click and you see this this option where you see these 4 arrows on top of the value. You can just use that and just drag and put the field wherever you want this label to display on the chart. So if you want this to come inside the
Why? You can do that just by this dragging and putting on top of the visual. Also, right now, if I hover over on this, the label says region name, sales, and then percentage of total sales along table across. Now, this second value that we have and the label name that we have here, for any non-technical person who would look at this visual and try to interpret it, won't that be confusing? The label name that we have, right? The default label name for this value is confusing. So we can always go and format these labels too. So go to the label here, okay, go to the label, and onto the label, you have this text part, okay, label appearance text, and you have these three dots. You can go to those three dots and it will open this label editor. Okay, so label editor, sorry, I'm sorry, not the label we are not talking about the label. Labels are coming properly here. These are the labels. I am referring to tooltip. This is called tooltip, right? This square box that you see, this is a tooltip. So we need to format the tooltip, how the tooltip reads this information. So go to tooltip and directly edit it here, tooltip. So this region is fine. Here, percentage of total sales. Let us just call it percentage of total sales and remove the remaining text directly from here. Okay, and that will be much more appropriate. Just change it from here, tooltip. Now this is region, percentage of total sales, and sales. Okay, much better, much clearer. Now, these are some of the visuals that we learned, and then there are some other visuals that you can also explore at your end. Now let's talk about some of the custom visuals that we can create in Tableau. So in Tableau, sometimes you will see when you look at some existing dashboards created in Tableau, you may wonder that, okay, this visual is created in Tableau, but it is not part of the standard visuals. It is not part of the standard visuals, then how this was created in Tableau. So there are some workarounds with which you can create the visuals which are not natively available in Tableau. Okay? For example, donut chart. Okay, donut chart is not available as the standard visual in Tableau. If you go to the show me, you have pie chart, but there is no donut chart. There is no donut chart which you can use here. Okay, so we want to create a donut chart, and if I need to do so, then how can we do it in Tableau? Let us quickly explore that. So it's not directly available, but there are workarounds with which you can create donut chart in Tableau. So let's look at this. So to start building the donut chart, you need to start with a pie chart. Okay? You need to start with the pie chart. So let's start and use a pie chart. And we'll use the same example. We are going to use sales by, let's say we'll look at sales by category here. Okay, sales by category. So I'll select category first and I'll select sales. Okay, these two selected, and I'll choose pie chart over here and I will make it a standard view. Okay, so far we are good. We created this pie chart over here. Now here there is this workaround that we need to use, and this is a bit custom and you need to learn how this can be done. So the next step would be to add a axis to the visual. Now we know that donuts don't have any y-axis, x-axis. Okay, there is no concept of x-axis, y-axis when we look at pie chart or donut chart. Correct? But here we need to introduce the x-axis axis part because we want to make this donut chart by using the feature of axis. Okay. So what I will do here is in this row shelf, I will just add a zero line, an axis. Okay, how we can do that? Within the row shelf, if you double click, it will let you write a custom measure directly over here. Custom measure. Okay. In this custom measure, I want to just give value 0 here. So I will use this function max of 0, just max of 0. That's it. And press enter. Automatically you'll see that it has this AGG coming before this, and this is wrapping the max function, max. So I'll come to this AGG part. What does this mean? And max 0 is basically we have just used the 0 value. Cannot use the 0 value directly. You need to aggregate it with something. So I use the max of 0, and it created this axis max 0 and just the 0 axis value over here. The first thing is that we do this max 0 0 axis. Now I'll just do one more of this. So just click once again and add again the same thing, max 0, and add another one. So what it did is it added 2 rows in my for this donut chart, right? 2 rows in this donut chart, and both of these are passing through the same axis with the value 0. So it's the center of this big circle is at the same level, okay? But we are getting these 2 different rows, okay? One for this one, another for this one. Okay, now these 2 axes that we have got, I need to use these 2 axes to be able to convert this into a donut. Okay, how do we do so? Now, for both of these pie charts at the moment, both of these pie charts, look at the marks card over here. What does marks card tell you? Marks card is telling me that there is formatting, all these formatting options that we have, all these customization options, that is applicable to the entire visual, which means everything selected, all, under all, everything, all. And then I have these separate formatting for first row and the second row pie. These are the 2 different settings that we can apply. Okay. So instead of applying the next setting to all, I want to apply it to the one of the donut. So just click on this donut. Let's say we click on this first one, and from this first one, I want to remove any kind of color coding from it. So this category wise color thing that we have done, I want to remove it. Okay, it actually got removed from this one. That's fine. It doesn't matter. But now we don't have any of this colors from this pie. Okay, we did this. You can actually remove all of these parts too. Let me remove these measures as well. It will just be a simple dot without having any data. Okay, we do this. Then the next part that we are going to do is we will just make difference into the size of these pies. So this pie, I let it remain of this size. But the second one that I have, where I have the category and the size and all these slices, the size of this pie, I'll make slightly bigger. Okay, now this is slightly bigger. This remains as smaller. Okay, so I do this, and then once this is done, the axis that I am getting for these rows, which is coming in 2 different axes, I will use the feature of combining the 2 axes. So making the chart dual axis. Okay. So what we will do here is on this axis that you see drop down, you have this option of make it as dual axis. So just select dual axis over here, and this will combine the charts. Okay, combine the chart like this. So okay, this is overlapping on this. I want this to overlap here. So I'll just do the reverse of it. Let me add the category pie over here, and sales on the size and sales on the angle. And let me have it this as well. But the second one, I'm going to make the changes here. I'll get rid of these and I'll make the size smaller. Okay, I'll make this size this much. And for the first one, I'm going to make the size slightly bigger. Okay, and now I'm going to make this dual axis. Okay, now these are both of same axis, right? The axes are merged, but because of the difference in the sizes, they appear like a donut rather than a pie. Okay, and now I'll do the last thing over here, which is making this instead of gray, I'll make this a just white background. So the second one that we have here, I can go to color and make the color white. Okay, if I want to make this size even bigger to make this tool more evident, I can do so. Next up, I can add the labels as I require here. Not for the second one, I don't need the label. Here, let me get rid of this. I'll just add the labels over here. So the category label and the sales label. Okay, so that's how we create a the donut chart using pie chart. So this is a custom visual that we can build.
So Sabun, for the values, you add these values always. What are these values represent? By now, you should know what are these values. These values are nothing but labels on your visual. These are labels, and we have a label card. Anything that we want to see on the label, drag and drop them on the label. We want to see the name of the category, drag and drop it on the label. We want to see the value, sales, drag and drop it on the label. So Neha, to your question, when do you use pie chart versus when do you use the donut chart? So although both are used to show the percentage contribution of each of the category onto the total value, but just the representation here changes slightly. So pie chart will show you just that part, but in donut, you can show uh, you can show some additional data too. So here I'm able to see the percentage contribution, that is fine. But at the same time, if I want to see, let's say, some other information too, for example, what is the total value out of which this is total sales is driven, right? So that if I want to see, then I can use the second donut to show that information, right? Now in the second donut where we change it to white background and we are not showing any label, any value. If I just go on that and I add only the total sales on that, just the total sales, right? Total sales as the label. Okay, so it'll show the total sales at the center, which is actually using the second pie chart over here. So we are able to see some more detail with the donut chart. So in very high uh, level, both donut chart and pie charts can be used in almost similar way, but donut can provide some additional details. Also, just from the look and feel point of view, uh, I like donuts more than pie, just because it just does not make your visuals to like overall dashboards unnecessarily filled with colors. Okay, so it's just that the matter of just the donut looks more elegant in terms of the just the visual point of view. Okay, as well as this additional detail. So this is one of the custom visual that we can create. Now let's look at another scenario. We'll create another custom visual, and that custom visual is okay. Before we go to the next custom visual, just one more thing just to cover this entire thing. So now in donut, we have used this axis just to merge two donuts together, correct? But now do you see any use of this axis that we see here, max 0, 0? Does it make any sense when we add this, right? It does not make any sense. right? So ideally, we should just remove these. We should just hide these. Just use it for creating this custom visual, but not beyond that. Okay, so what we can do here, we can simply go to this measure, we can right click and we can just remove the show header. This will go away. Okay, so just hide this. Second thing that you can do here is even this line that you see, which is going through this center, this dotted line, even I don't want to see this. Okay, even I don't want to see this dotted line too. So I can get rid of this too. So for this dotted line, you can go to this, you can go to format. Okay, and in the format, okay, what do we want to go? We want to go to reference lines. Sorry, not the reference lines format. This would be lines. Okay, format and go to lines. Okay, any lines that you have on the worksheet, go to that. Okay, and in that line, you go and make it. You have all these different lines. So we want to have this zero line that is there currently. I want to remove this. So zero line, make it none. Okay, zero line, just get rid of this. Okay. So that's how we have done this final formatting. Now let's look at another custom visual here. Okay, this is called waterfall chart. Have you all heard or seen waterfall chart? What is waterfall chart? Any idea? This is very like common interview question as well. Like if you need to create a waterfall chart in Tableau, how you can do that? Okay, so first thing is we need to understand what is waterfall chart, what is the use case, and then a way with which we can create it in Tableau. So first is waterfall chart basically is a chart which lets you see what is the incremental change on your data with each categorical uh, values contributing to the data. For example, we have these categories. So to the sales, how much business did technology brought? Okay, then just the incremental change that furniture brought to the business from technology, we can, if you want to see that. Then what's the incremental change that office supplies brought from that? Then what is the incremental change that any other category brought? So if you want to see those incremental effect to our data, then we can use waterfall chart. Okay, typically we can use them, these waterfall charts, when we want to look at anything which is having both positive and negative change over time, and we want to know when those positive and negative changes happening. For example, let's take an example of uh, accounting. Okay, accounting example. So you have your, this is your y-axis, this is your x-axis. Okay, in the y-axis you have the cash, cash or cash flow, let's say cash flow. In the x-axis you have months. Okay, so you have things like month one, let's call it January. Okay, January, then February, then March, then April, May, June. Okay, let's consider these first 6 months here. Okay, so in the first 6 months, how the cash flow has been. So let's say we want to look at what happened in the first 6 months, how the cash flow has been for the company. Okay, so in January, for example, in January we had a positive cash flow. We got, let's say we are starting from zero, so we got a positive cash flow into the business. So we got cash in January. Then there was in February, the net cash was low, like cash flow was out. So we get less of cash inflow, but more of cash outflow. So the net effect for February was slightly reduced cash flow from its previous state. Okay. So previously, if it was, let me make it this way. So earlier, if in January the cash flow was high, in February it changed and it just reduced slightly from January. Okay, so it reduced slightly. Then in February, this was January, then it reduced down to this much. Okay, so it went down. Then from here, let's say it went further down. So your cash flow was even lesser in March. So outwards is more. Then in April, you got some inward. Okay, some inward. So something you got inward. So more of inward, less of outward. So you got some outflow, some inflow. So it increased. Then in March, it increased even further from this point. Let's say it increased quite a bit. Okay. And then in June, once again, there is a reduction. So this was the point from which you will have your June data. And finally, your net, what is left after all these changes are this much. This is what you're left with. Okay. So this kind of chart is called waterfall chart. So we are seeing how waterfall works. So from here it increased, then it decreased. We went to this low. Then from here, the last point, it reduced further, went down. Then this would be the starting point. From here, it went slightly up. Then from here, it went further up. Then from here, it went slightly down. And this led to the net is at this level. Net cash flow is at this level. Okay, so this visual actually shows me where were the major dips, where end of the value war is at, and what the final value I'm left with. So this kind of visual is called waterfall. Okay, waterfall chart. Now this is not possible directly in Tableau. We cannot create them, but we can have a workaround to use to make this waterfall chart. Okay, so let's build something like this. So here I'm going to, since I don't have the example of cash flow, we are going to use the same data, but we are going to look at how each subcategory contributed to profit. Okay, how each subcategory contributed to profit. So put subcategory onto the columns. Okay, and the profit onto the rows. Okay, this will make a column chart, right? Column chart over here. Okay, so we've got this information. Now I want to make changes here. I want to make it a the type of this chart to be not a bar over here, but this mark I will change it to here in the mark, change it to Gantt bar. Gantt bar. Use the option Gantt bar. What Gantt bar does is instead of showing it for individual like full bar, just where the maximum is, we are highlighting that where the value is. So we can see those values where these are. Now I want to make this sum of profit not as it is sum of profit, but I want to make it as a running total of the profit. Since I want to show the incremental change, so I'll change it to a table calculation of just a running total. Show me the running total of all of these. Okay, now this Gantt not just shows all the values from 0 to its value, but running total. So how much it was for accessories, then how much increase it did from accessories to appliance, then how much increase did it did for the next one, then how much increase, and then for some, it is also going low. Wherever the profit is negative, it is also going down. So your running total is also going down for some in some instances. Okay, so we got this. And now I want to just fill this gap to make it look like a waterfall. Okay, so for that, I will once again use profit and use that as the size of this Gantt. Okay, this will be the size of this Gantt. Okay, size of the Gantt. So we got this. And now I'm going to make one more change to this, which is I want to invert this size. So this what it did is if my Gantt, this marker, the Gantt marker is at this level, use the line. If the Gantt marker is this level, when and my zero axis is over here, say like this. My zero is over here, right? This is where the zero is. This is where the zero is. So when I added size to the Gantt, it just added more size on top of it, right? It just increased the height. So whatever that bar is, it just added more size to it. So that's why this value, if you see, this is showing the positive increase from where the Gantt was. Gantt was over here. It increased it even further because of this size. Since I want to show this value from bottom to top, I will just invert this Gantt, size of this Gantt. Okay. How do we do so? This sum of profit that we added, just make the sign of this calculation negative. So here you can double click on this and you can make changes to this expression over here. Just simply put a negative on before the sum of sales. Okay. This has become negative. See, this has inverted. What was positive is now become negative. Okay, and now this is coming properly like a waterfall. If you see this properly, accessories increase, the profit was 41.937K. Then additional, we got about appliances, which increased its running total to 60K. Then it increased 66, 96, and so on and so forth. We are able to see this waterfall kind of an effect over here. And just to show what is positive and what is negative in different color, just to show the positive and change in the profit and negative change in the profit, we can bring profit into the color. Okay, we can bring profit into the color, and I can simply make it even clearer by just, you can make this specific just the two color format as well, just green and red. We learned about this, but you can leave it to this as well, waterfall chart. And remember this, these steps, you should be able to uh, explain why we are doing these steps. So on what you display here, that is something that you should always consider when it comes to creating your visual. What your end user would see, that always matters. Okay, so we should always do that cleanup. Eventually, whom are we creating it, these visuals for? These are for the business users. They should not get confused with anything. So it should be, your visuals should be as self-explanatory as possible, right? So all these minor things you should always take care of. Neha, I did not understand what you mean by you understood how to do, but what you want me to ask to show you. Okay, why do we do waterfall? I gave you the example. I spoke for about 5 minutes on why do we require it. Whenever we want to see an incremental change on our on the any data, be it month over month, when at which point we are seeing the decline, where we are seeing the increase. We want to see those kind of data explicitly, then waterfall is a good way to identify those points. As well as I gave you an example of also the cash flow, right? There are how we can identify how our cash flows has been week over week, month over month, uh, business units by business units. Those kind of insights you can find with the waterfall chart. Okay. Now, if you ask that why, if I can not interpret the same using a simple column chart, answer would be yes, you can do that too. Like that is always there, but sometimes you may need to create these with these kind of more advanced charts, and you may be just asked that you need to create a waterfall chart for this. Okay, so then you need to know first what is waterfall chart, how we can create it in Tableau. Okay, so here we can do some cleanup of how the data is, the labels, all those details. Like if you see here as well, tooltip, you have some details which needs to be removed just to be clear on what this is, right? So we can just go to tooltip, we can clean it up. So anything with this negative sum profit, this is not required. We can just go ahead and delete this part. Profit, we are showing a sum of profit. This is fine. Then running total, okay, this you can show, you can call it cumulative profit. This much is sufficient. Okay, now your labels would be just subcategory profit and cumulative profit. Okay, this way. Now there is no negative value in the tooltips. Value, yes, you have to invert the values. Only then your Gantt would start from the actual value, because we are defining the size of the Gantt. You have to do the same step. There is no other way. Yeah. So let's move to the next custom visual. And this is called Pareto chart. Pareto chart. Okay. Pareto chart. Now, do you know how many of you know what is Pareto chart? Pareto chart or Pareto analysis or Pareto rule. Okay. This is very famous theory by the person named Pareto itself. Right. So the name chart is named after the person Pareto. What does this theory say? This theory says that most of the outputs of any effort is a result of very less inputs. Okay, or quantitatively it is also called a 80-20 rule. You may have seen about this, like heard about this 80-20 rule or 80-20 80-20 analysis, right? So what does 80-20 means? That 80%, now this is theoretical, but 80% of the output can be achieved just if you focus on 20% of inputs. And this is a very like famous theory in businesses, that you need to focus on only those 20% of the components, and then you will get just on those 20% of the inputs, you can get 80% of your total result. It can be applied on different types of business scenarios. Okay, and there are many books, many theories on this, and usually you would want to see this rule in the form of some charts. Okay, some charts, whether those chart, with that chart we can also see the same thing, how much percentage of input can give you x amount of output. Okay, now just to give you some more context on this, like when it comes to the 80-20 rules. Now, uh, if you are having, let's say, if there are 100 products that you are selling, it may be possible that 80% of the business or 80% of the sales is coming only from the 20% of the product or the 20 products. Another scenario could be that, um, let's say you are, um, let's talk about um, stocks, right? Stocks. So you may be getting 80% of your return only based on the 20% of the stocks that are giving you those return. Or it can be applied to any scenario. Let's take think about the organization. So there could be in organization, there could be those 20% of employees which are that valuable that they are bringing 80% of the business return, right? Or the customer satisfaction, whatever. But this rule applies everywhere. Overall, from your productivity as well as a person, you can focus on the 20% of the things. If you do those rightly, then you may get 80% of your result, total result, rather than focusing on everything. That's what business coaches also tell, that don't try to do everything, just focus on the ones which are really important, which gives you the most in most returns. Okay, so this is exactly the chart that like the Pareto chart, Pareto analysis is, and we'll visualize this, how we can visualize the same kind of input, same kind of data. Okay, so let's understand this. So let me create a chart. Okay, so with Pareto analysis, I need to first of all, I need to see, now let's say I apply this Pareto analysis on the on uh, let's say I apply it on the category subcategories. Okay, let's again apply it on the subcategories. So I'll put subcategories into the columns, onto the column. Okay, and I want to see how much sales I'm getting from these subcategories. So I will bring sales onto the rows. Okay, currently I'm able to see sales by each subcategory. Okay, all good so far. Now I want to make this sales, this data in the, I want to keep it in the descending order, right? I want to keep it sorted. So I can go ahead and apply a sorting on this. Okay, sorting. Now my results are sorted, correct? Results are sorted. Now I will just bring another sales measure over here and I will show this as a new row, another sales measure as a new row. Okay. So on the first one, we are going to keep the data as it is, which is the sorted order. On the second one, I want to change it based on the cumulative percentage total. Cumulative percentage total. Okay. So how do I do so? So go and change it by applying a table calculation, quick table calculation. And in the table calculation, we'll make it a percentage of total. Okay, so percentage of total. So here, actually percentage of total will give you only the individual percentage of totals for individual subcategories. I don't want to do that. I want to see the percentage of total incrementally. Okay, incrementally. So here we need to do it slightly differently. So instead of directly applying a quick table calculations, I'm going to edit this and I'm going to make it a table calculation and I'm going to make first, I'm going to make a running total. Okay, running total. What is this? This is my running total. So all of this, I just converted this to a running total. I'm able to see the running total. On the running total that I'm getting here, which is in the decreasing order of the subcategory names, I want to do a percentage of total of these running totals so that I would know that this gave me X percentage, but these two give me X plus Y percentage. So I want to see how many categories, subcategories are giving me cumulatively how much percentage, right? So running total, that will be the primary calculation that I did. On top of this, I want to add a secondary. So select this add secondary calculation, add secondary calculation. And on this add secondary calculation, I will use the percentage of total. Okay. So the first is running total of sum and the secondary is percentage of the total. Now you see this is showing me the percentage of total. Phone is giving me 14.37 percentage. But phone plus chair is together giving me 28% of the sales. If we add storage as well, then it gives me 38% of the sales. If we add tables as well, it is giving me 47% of sales and so on. It will give me 100% when we reach to the last subcategory. Okay, so we got these over here. So the above one is showing the absolute sales and the below showing the cumulative percentage sum percentage of total. Now I'll make one more change is that instead of this being a bar, I'll convert this into a line. Okay, so the second one that we have, I'll change this type of the mark from automatic to a line. Okay, this becomes a line. And I can also change the color of this line to something else. Let's say I want to keep this color as color of the line is, let's say, this orange color. And now I can simply combine these two. So we know how do we combine two axes together? We make them dual axis, dual axis. We make them dual axis. Now this color once again automatically changed. Let us fix those once again. So the first one, which was supposed to be a bar, now this became these circles. Let me change it to bar again. Okay. And this is becoming line. So that's fine. We can keep the color as this. Okay. Now let us also add some labels to these percentage values. For the second one, which is the percentage of total, we can add them to the label. I can turn on the data label here. Actually, I'll just turn off the data label. I'll just need the label on this. So this I can put it over here as the label, and I can change it once again to the table calculation, which is first running total, second doing the percentage of total. Okay, now we have these calculation of the label, and I can keep the label size a bit smaller, maybe 7. Okay, and if I want it to be consistently below or above, then I can just do some formatting here, like alignment, keep it always uh, at the bottom. Okay, maybe you can make it an entire view. Okay, so this is basically the Pareto analysis of our subcategory wise sales. Okay, once again, let us interpret it. Phones alone, one single category. How many total categories, subcategories do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Total 17. 17. Out of 17, phones alone is giving me about 14% of sales. What does this indicate? This indicates that, let me write it down. 1 out of 17. What is the value? 1 divided by 17. Okay, if we do it, you know, let's say I bring up Cal C here. That is about 6%. Okay, 6%. So 6%. So here it says that 6% of input gives, input means one of the categories. 6% of all the subcategories, that is one category, is giving you 14% of out. That's how you interpret this. Then phone plus shares is giving you cumulative about 29% of total output. What is phone plus share? So 2 divided by 17. Okay. So if this is 60%, then about 12% of input is giving about 29% of output. And same, if we include the first 6 subcategories, okay, so first 6, so 6 divided by 17, that will be almost 30%. 30% of input giving almost 56% of output. Okay, so if we focus on, let's say, now this can be one analogy, that if I focus on only my 30% of input, which affects 56% of output, then I can do much better in the sales. If I just focus on growing these subcategories, right? Expanding more products, doing more marketing, more aggressively sales, I may get better sales overall rather than focusing on all the others. Okay, this is what this analysis helps businesses. What percentage of input gives you what percentage of output? Okay. Here we are saying incrementally how much each subcategory is contributing to the total sales. Okay. And we are sorting the result based on the top ones first, right? And the bottom ones last. Okay. So this is result is sorted. So my sales, so the highest contributor comes first. Then the second highest comes second. Then the third highest comes third, right? So we are able to see the absolute sales of each of these subcategories in the descending order. This is one part of this visual. Second part of this is how much percentage contribution I am getting as I am increasing these subcategories into my visual, right? Phone alone gave me 14% of the total sales. But as we go to phone and chair, so as we move forward, because this is cumulative, uh, this is percentage of cumulative sum, right? Percentage of cumulative sum. So as we go with phone and chairs, then together these two give 28%. Then as we go to the third one, then together these three gave 38% of sales and so on. And you will see that this curve will always be like this, that it will have more steeper beginning. See, it will have more steeper beginning. Then it will try to flatten out as we move forward with the with the um with the categories which do not contribute much. Okay, so look at this. These after this point, let's say after this point, what all do we have here? We have these six subcategories: paper, supplies, art, envelope, labels, and fasteners. What is their contribution to the sales? Total six subcategories. Six subcategories means 30% of my total subcategories are giving me just 95.40 to 100% sales, which is less than 5% of the total sales. Six subcategories, which means 30% of my subcategories, more than 30% of my subcategories give me less than 5% of my total sales. Now, these are six products, and then these are another six products. These first six products are giving you cumulative 60%, 64% of total sales. Okay. So there are these six products which are giving you 64% of the sales. And then there are these six products which are giving you only 5% of the sales. Now, if you are a product manager, okay, if you are a product manager, where would you rather focus your energy on? These six product or these six product? The first six product, right? Obvious that we need to focus on the first six product. These are the ones which are giving you the bread and butter. These are the ones that you should be focusing on. So that's what the Pareto chart or the Pareto rule says, that focus on the important part, even if they are lesser in total amount, but their impact is much more. Okay. Rather than focusing on everything on your business, rather than equally focusing on 17 subcategories, if your focus is more on the first six categories, subcategories, you will be able to perform better, because those are the ones which are giving you about 65% of total sales. Okay, and that is what we are trying to depict with this chart. And this can be applied to different type of data. Now let's say I just switch this data to, instead of subcategory, I'll just change it to category. So product, just go one level down into the hierarchy, remove this, and look at this data by product. See, now this result come like this. And see once again, what does this trend tell you? This chart, that your important ones will always be at the very top. This chart goes very high, steep initially. And then when you reach almost at the middle point, then it starts becoming flatter and flatter and flatter. And Look at all these products contributing almost nothing to your business. Almost nothing to your business. These are just a waste of your time. You may even consider just stop manufacturing those products and focus on these ones which are actually important for your business. Okay, this is what this chart tells us. Okay, I hope this is the concept wise, this is now clearer. What is Pareto analysis? Why do businesses look into this chart? Now, uh, you may need help in recreate like creating this. So I'll just recreate it once again and then you can follow and build it again. Okay, how we did it. So let me remove everything and build it again. What we did, we wanted to see subcategories, a Pareto created on subcategories. Okay, so subcategory into the column and sales onto the rows. Subcategories are your inputs. Some sales is your output. Okay, all these different subcategories are your inputs and sales is your output. Now you want to see this output of these inputs in the decreasing order. So just sort it in the descending order. Okay, this got sorted. So I'm able to see my sorted result. Now, along with the sorted result, I want to see these cumulative percentage total for all of these. And I want that to be shown and on a separate axis. Okay, one keeping this axis contains the absolute sales values in the dollar values. I need one more showing the data in the percentages. So I'll bring first of all sales onto the secondary axis here in the row, and I'll convert this into percentage of cumulative total. So I need to do some table calculation on top of this. Table calculations are performing on the fly calculations on this context in which this visual is created. Okay, so let's do that. So what I do here, I will first go to the add table calculation. First is I want to do a running total. Okay, so that this is all becoming running total. So one becomes its total, second becomes 1 plus 2, third becomes 1 plus 2 plus 3, fourth becomes 1 plus 2 plus 3 plus 4, and so on. Running total. On this running total, I want to apply a percentage of total value. So add a secondary calculation on top of this, which is percentage of total. Percentage of total. Okay, that's all. So this table calculation is built. We did this, and then we can combine these and make this a dual axis. So make it a dual axis chart. Now, one of them I want to show as the bar and other one I want to show as line. So the first one here, right? First one here, I want to show this as a bar, right? So this bar, and the second one, second series here, this I want to change it to a line. Okay, and on this line, I want to add label. So once again, the same table calculation I can put onto the label. What is that table calculation? Table calculation is running total and then percentage of total. Okay, and I can make this font size smaller, alignment on the bottom of this line just to make it visible clearly. And you can make it an entire view. Okay, next up, Zildas, there is only one step in sorting. What is step by step? Just I clicked on this button. What is step by step here? We have been doing this from the class one. There is this one single button click for sorting. Just one single button. Okay. Nothing, no, nothing complicated here. Very simple. Okay. So I hope everyone has got it till this point. The next step is I want to create two x-axes. Okay. What the second one to show the cumulative percentage sum. So once again, add sales measure into the secondary y-axis. Okay. And on this one, click on this small drop down and add table calculation. Table calculation would look like the calculation type. First one, select running total. Okay. Keep this aggregation to sum running total, and then click on add secondary calculation. And this secondary calculation, set it as percentage of total. Okay. Make this selection to the secondary axis. So now you would see the result like this. Okay. Now we will simply combine and make this a dual axis chart. Currently there are two separate axes. We'll make it a dual axis. So no two rows, but one single row. So just select, make it dual axis. The first one, now we can see these two marks here. Okay, so first one shows the sum of sales, which is the absolute value here, the one in the orange color. I want this to be from this circle marking to a bar chart. So just choose bar. Okay, and the second one, I want to see this one instead of this circle. I want this to be a line. Now, where we have added this line, this represents cumulative percentage of total, right? This is what it is, but it is not showing that on the label. So we'll just show the cumulative percentage of the total onto the label as well. So for that, we need to first add the sales onto the label, but this will show the sales as it is, the sales as it is, the absolute figures. I don't want to show the absolute figure. So I will once again apply the table calculation on this label too. So on this label, the same thing, go to add table calculation, and first calculation is running total and second calculation is percentage of total, and close and see if you are able to see the cumulative percentage totals here. Now we just change this placement of this, and I just reduce the font size because it becomes too big. And sometimes, let me make it entire view too. Sometimes with this bigger font, some of the labels will go missing. You will not be able to see some of the labels because it'll overlap and you will not see. So I can reduce this font size. So we can go to this label formatting, click on this label formatting. I change the font size here, reduce it to 7, 7 and plus enter. I can also make this formatting a bit um, like clean by removing these decimal numbers as well. Actually, these don't make much sense keeping these to two decimal places. I can just keep it to one or maybe without decimal place as well, right? That will be more, data points will be much more readable with that, right? If I need to do so, you can go here and go to format. The same thing that we did earlier. So this number format, go make these percentages with just one decimal or even without decimal if you want to keep it. Okay, because this is an indicative result that I want to just learn. I don't, it doesn't matter if it is zero point 0.7 or 0.75 or zero point 0.8. It gives you a just indicative idea of how much percentage of contribution each of the subcategory is giving, and combine in combination how much top subcategories are giving. This is called Pareto chart. We can once again, we can make changes in this tooltips, make them better. Percentage of running sum of sales. Now, these are some of the custom visuals that we work with. Now, let's dive into some field settings and data grouping parts, how we can do that. Let us understand that. So now, once again, taking the example of subcategory sales, let me take that. So, I'll put subcategory in the row and sales in the y-axis. Okay, and once again, I will, let's say I want to sort it in the descending order. Okay, now if I want to make some groups of my data on the basis of analysis, just based on how I'm analyzing, okay, I can just do it on the fly from the visual as well. Now, what I mean by groups, groups is, let's say I have a field, and in that field I have some distinct values. If we talk about subcategories, this is a field where you will have subcategory names, right? Phones, chairs, storage, tables, binders, all these are different subcategory names. Now, if I want to create a further group of this subcategory, so there is already a group of this which is categories, right? But if I want to do a custom grouping, then I can do that in multiple ways. One is just based on the analysis. So just based on this analysis, which is I'm looking at overall sales and overall sales by subcategory, and I now know which are my top five subcategories are. Okay, which are my top five subcategories? Phone, chair, storage, tables, binders. Okay, this is based on the total sales. So how, and I want to now, whenever I want to analyze the data, let's say I want to look at this as a group. Okay, as a group, I want to analyze this. So I can select these values. So just drag your mouse and start selecting these values from the top five. I dragged my mouse and selected these five. Okay, selected these five. Right click on this and make this a group. Make this a group. Okay. Now, if you see, a new field got created here, which is a subcategory group. Okay. Subcategory group. Okay. And automatically, uh, Tableau did some analysis on top of this, just added this group onto the color shelf over here so that I am able to see my top five subcategories in some in one color and the remaining in another color. Okay. So I directly from the visual, I created this subcategory group. Okay. Now this happened on the fly. I did it. And now I can just modify this group and I can make changes if I need to do. So I can go into this group and I can edit the group. Okay. What are the members in this group right now? So the first five, binder, chairs, phone, storage, table, these got added. And the name of this is also coming like this: binder, comma, chairs, comma, phone, and so on. Let's say I want to give this as name. I want to rename it. So just double click on this. It will allow you to rename the group. Let's say I call it top five subcategories. Top five subcategories. Okay. I've got these. Now, let's say I want to modify and I want to add something else, another group. So I can go expand. What all do I have in the other? I have these, some other, right? And I know that supplies, art, envelopes, labels, fasteners, these are the bottom five. Let's say I want this to be in one another group. Okay. So I can select those one by one here. Supplies, okay, art, control and select, envelopes, labels, and fasteners. I selected all of these, then I can make a group, create a group. So another group got created. Let's say I call them bottom five subcategories. And then let's say you have this as other and you can leave this as other. There can be other grouping that if you want to do, then you can do. So we created this group. Based on this analysis, I'm able to identify which are top, which are bottom, which are then other. Okay, clicked on this apply, and this new group based filtering got up, this color code got applied on my visual. Correct. Now here anyways I'm able to see this top five, bottom five and others directly on the visual. So on this visual it does not make much sense. But now if I want to analyze this in any other way, okay, if I want to analyze this in any other way, for example, these grouping has become permanent. Okay, this will be permanent. It will not be dynamic. So tomorrow, if with more data, let's say binder is no longer the top five, machine became under top five, that won't happen. So this is the fixed grouping that I have created based on the current data. Okay. Now, if I let's say apply another field over here, let's say uh, we have the subcategory. Now let's say I apply the region over here and add it in the row. Okay. Now what I did, I added region to the row and I'm seeing region wise subcategories and how those top and the bottom subcategories that I have would look like when I add some other fields, and I hard coded these groups, but you see that for East region, those top five do not always remain top five, correct? So your top five is different in the East region. So overall, on the overall data, your top five, bottom five would be one. But when you add some other context to your visual, this will highlight that overall, which is my top five, is actually quite low in East. Okay. Or machines, which is nowhere in the um top five, this is other, is actually second highest in South. Okay. And similarly, so I will be able to see this group, how this is changing when we see this with other results. So just quickly, if you want to make some a new field calculation based on some knowledge, you can do so by using these groups. So you can visualize something based on that, you can create group and then you can see how that group looks like. If you have a defined logic for creating group, then you can go ahead and build with that. Or if you want to do on the fly based on what the data is telling you can make groups like this. But this is just a way to create these calculations to group values into groups. Okay, this is how you can do grouping. So one is just by simply selecting the value, or other is on the visual, you drag and select values and create these groups. So this is group, very simple. Uh, Next up, I would want to show you um sets. But before we go to sets, what are sets and how to define those? Let us first understand the filters and some of the ways with which we can apply filter to our data. Okay, so let us learn that, the filtering part. Okay, and we are going to learn the filtering based on um, different dimensions. Okay, so we'll once again take this example of subcategory wise sales to understand this with more detail. Okay, so this is these are my subcategory wise sales. Now I want to apply a filter over here. Okay, so if you want to apply any filter to a visual, you can simply drag and drop the field onto the filter shelf. Okay, this is the filter shelf. Okay, so if I want to just select a particular subcategory, I can drag subcategory, drop it onto the filter. As soon as you drag and drop it onto the filters shelf, you get this different ways with which you can apply filter over here. Okay, so there are these four different different types with which you can apply the filter over here. So first is the this simple list. Okay, so this list. If you want to just filter your results based on any of these just lists, you can just deselect, select whatever that you want. You can do that. Okay, so this will filter your result. Now, another way with which you can filter is using wildcard. Wildcard is you can apply certain conditions like if the category name matches with uh, or it contains or it starts or any kind of these uh, wildcard based filtering. So if let's say anything which contains or which let's say starts with the letter T, okay, so table starts with T, right? So we can just apply and we'll see the result only with this. Or if you don't want this to be filtered based on T, but you want to filter out anything which is based on starting with T, you can use this another one. So instead of include, apply exclude. So just select exclude. Same thing, does not start with apply. It'll just do the opposite of it. Okay. So this way you can apply a wildcard based filtering to your data. Then next you can apply some condition based filter. Okay. So you can go and apply some conditions. Conditions could be that let's say your filter is your you want to keep only the sales which are above a certain threshold value, right? So filter is filter by field, which is sales and sum of sales, which are greater than or equal to some value, right? So how much value do we have? Let's say I want to keep anything which is above 50K. Okay, so anything which is greater than 50K, apply, and we'll see only the result for the ones which are above 50K. Okay, I can do it like this condition, which is just one of the condition, or I can apply a multiple conditions. Let's say I want to use by formula, I can go and apply multiple conditions. So what would be the condition here? So I want to filter it based on the sales. So I can do something like if like condition is sum of sales, this field greater than or equal to 50K, right? And if I want to use another condition, which is sum of sales less than 100K, right? Something like this. If I want to do something like this, I can do this. So I can apply a filtering based on certain condition on my data. Okay, I can do that. And the last one, which is based on the top filter. So if I want to see only the top results. So let's say I want to see the top 10 based on sum of sales. Top 10 based on sum of sales. I can apply this and this will only show the top 10. I can keep this result sorted to. We'll see only the top 10. Okay, so you can go to top 10. You can also show bottom 10 by this. Okay, same as how we did in Power BI, the top 10 and the bottom 10. Here as well, we can do the same thing. Okay, so we can apply this filter to show these results. Okay, so when you add filter, any field to work as a filter, you can simply just choose which to keep, which one to remove. You can use wildcard, okay, which could be based on inclusion or exclusion. You can use conditions, or you can use the top n or the bottom n. This filter that I have, I can just apply this filter and keep it here in the filters. Or if I want to see the result of like what I'm filtering and I want to users to have this ability to use the filter in the dashboard, I can just select show filter. Okay, you can use show filter. Okay, so show filter will actually show what we are doing, how the filtering is applied on this result. Okay, so it is all these limited by the top 10. Okay, if we want to change how this would be, this result would be shown, you have some other customization options over here. You can do those too. Okay, now here we have added only the subcategory. Let's say apart from subcategory, I want to see this result of top 10 based on individual region. Okay, this top 10 results that I'm seeing, if I want to be able to see this by each region, one way is that I can put region into the filter shelf, adding region over here in the filter. Okay, and select apply. Okay, so currently none of the region is being applied. So you can bring it into show filter and you can choose how you want to see the top result based on only one of the region or multiple reasons. You can see your filtered result based on any other field when you add them as the filter. This filter that you see here, you have the option to show this in different ways. Here, I'm showing this in the form of list where we can select multiple and select everything. But if I have any, if I want any filter to be shown as just a single value selector, I can make changes in how the appearance would be. So here in the small drop down over here, we can change it to a single value option, a single value list. A single value list would be like a radio button. Only one can be selected at a time. Okay. Or you can have some other type of filters, like you can have some slider values, which would be more appropriate when you have some numerical data. Okay, so these are different ways, settings in which you can have your filters displayed. Okay, so you either keep for the text type of data, you either keep as this list of values, drop down, or a single value. Okay, a drop down would look like this, where you can just use this drop down and choose whatever you want to keep or you want to hide. Okay, now coming back to the part where we have created groups. So we created group here, which will be the fixed grouping of your values within a field. Okay, then you can create another type of grouping, which is called sets. Okay, sets are dynamic grouping based on some calculations. Okay, these grouping are just simple grouping, static grouping, but sets allow you to create dynamic grouping. So let's do that. So on this subcategory, once again, I'll go and this time I'm going to create a set. Okay, so we created group earlier. This time we are going to create a set. So for set, you get the similar option like we get in the filter. Okay, so here I can create a set based on certain logic. Okay, so this set, now I can create a set based on condition like set, which is the result of this is, let's say you are keeping only, let's say you create based on the top. Okay, top, let's say we want to create a set of top 5 subcategories, so you select top 5 based on sum of sales. Okay, so we create this categories top 5 set. Okay, and click OK. So we got this category top 5 set. Okay, and now I can use this onto the color, and basically when we create set, it will, when we use it as a um, um, as any kind of highlighting the data, then set by default it gives you an option of in or out. Okay, in or out. So if any of these are part of top 5, then they will be color coded in, otherwise out. Okay, that's how you get the output of set. So let me show this set as the field first of all. Set in out. Let me see if I'm applying some filter over here. Let me remove. Okay, this condition is being applied here. That's the problem. So let me remove the condition and only this. Okay, now you see when we create set, then it just lets us see whatever is part of that set or not. Okay, so we created set of top 5 subcategories. Okay, so we see in and out. Now, once again, let me show this subcategory wise sales. Okay, and let me show this set that we have created. If we just color code it by the set. Okay, now this is showing me which are part of those top 5 or not. If I sort it, you'll be able to see this correctly. So this is in or out of this, right? Top 5. Now here in set, if I add region, okay, I need to apply. So here as well, I need to apply this will still show me. I think I was mistaken. I was assuming that this will be filtering dynamically, but this is also understanding the context of the top N that we have applied. So this context would not change. I'll need to apply another calculation to take this context on the region level for it to work. These are the ways in which you can combine data in your fields, okay, in your dimension or by dimensions. Okay, so let's just once again recap on this. So groups, how we can create the groups. So groups can be created by just on the visualization you can go like here on the visualization you can go select whatever that you want to select, and then these ones if you want them to be grouped by a specific combined field value, then you can do a right click and you can group. Okay, so for group there is this paperclip icon, right? So wherever you see this paperclip icon, this means that we are talking about grouping. We did a group based on the subcategory. If you see over here the paperclip icon, so this is indicating the subcategory grouping that we did. How did we did the grouping? We did it based on the top subcategories which we just selected based on the sales value overall, and then the bottom 5 subcategories based on the overall sales, right? And whatever is remaining left into others. So this is how you can do the grouping. Grouping is static in nature. Okay, it does not change. If tomorrow some other subcategory becomes higher valued, like in terms of sales, it will still show your top subcategories as you have created earlier in the group. So this remains static. The main purpose of grouping is like if you want to just, if you know that you want to, uh, if you don't have that uh, grouping directly in your data and you want to do, you want to analyze products which can be grouped together, then you can do the grouping. Okay, so normally this should be applied based on what kind of field values that can be clubbed together. Okay, that you can do for grouping. Okay, another example that we can see on this is, let's say you have these products. Okay, products. If you see the products, let me create another sheet here. Let's say we have these products. So see, we have about 25 2025 products, but it is saying that maximum recommended maximum in this shelf is only 1000. It is not allowing me to just show them as it is. So we can go and let's say if I just apply a specific category filter first, okay, a category filter, and let's say I only am interested in looking at a specific category. Let's say I'm talking about only furnitures. Okay, so we applied a furniture filter, and now I try to add the products here, add all members. Let me add all the members here. Okay, so now we have everything which is there in the furniture. Now, if I think that any of these products which are currently shown as the individual products can be combined together, then those can be combined into one grouping, right? In your analysis purpose. For example, we can see this bookcases, right? Bookcases. So you have two shelf bookcases, three shelf bookcases, four shelf bookcases. If you want all of these combined into one group, which is of bookcases, you can do so. Okay, you can do so. So how you can do here is you can go and create a group on the product. You can go and create a group, and here you can find everything that is belonging to that contains some data. So let's say you have this find option. You can go to find and find members that contains bookcases, let's say, right? So you find all which contains bookcases, right? So it has highlighted everything that contains bookcases, correct? Now you can go ahead and group them into one group, which can be bookcases. Similarly, so all of these which are of the type bookcases are now got combined into one product group. Similarly, here you have some types of refrigerators. If you want these to be combined together, so you can search refrigerator, right? So everything that is refrigerator, you can make a group of them, calling them as refrigerator, entire group into the name refrigerator. So this kind of custom grouping you want to do, you can apply this kind of grouping into your products. Okay. So now you have this product group, you can add it before the product name, and you will be able to see this grouping like bookcases, everything related to bookcases are now coming into this group. And then you have all the underlying values over here. If you want everything consolidated and viewed at the bookcases level, you can do so. Similarly, if you scroll down, there would be refrigerator as well somewhere. Why is it not coming up? Yeah, refrigeration. Okay, this may be because of the filter. If you see, my filter is applied on the furniture, right? Refrigerator should come in the technology. Okay, maybe that grouping did not get applied. Let me check. Okay, refrigerator, the grouping got applied. Let me apply a filter over here and see if I can just condition if the product group is equal to refrigerator. So it did get applied. I'm not sure why it was not coming up because of maybe the samples that we were seeing here. But anyways, we can do this grouping like this too, right? Custom grouping, and then you can view the data at this hierarchy level, a custom hierarchy that you have created. So this is one of the purpose with which you can use, one of the use case with which we can use groups. Around grouping is not permanent. You can always edit it. Okay, you can always edit it. So here we have the product name group over here, right? If I need to edit this, just go and edit the group, click on edit group, and it will allow you to update the existing group by adding either removing or updating any kind of changes you need to do on the existing one. So it's never permanent. If I need to just ungroup this, let's say refrigerator, I don't want it to be grouped, I can ungroup it and this will be gone. So another topic that we covered yesterday is sets. What are sets and how sets are different than groups. So while groups are used on the some dimensions and you give static selection of the items, like what should be the static grouping, you define them static in a static way. In sets, you can create um, you can create sets in both static as well as dynamic way. Okay, it can be in both static and dynamic. With sets, what we do is we define a list of values. We define a list of values based on either certain conditions or by the static selections. We define a list of value, and then your set will tell you whether anything that you look at, whether that is part of that defined list or not. Okay, so set always gives you two values in the output, whether in or out, which means whether the field that you are selecting, whether that is the member of that set or not. That's all. Okay, so it gives you two binary values, in or out, whether it is part of that list, any value or not. That's what it gives you. Let me show you with an example. It will be more clearer with the example how sets work. So let us create another visual over here, and I want to create just I want to see individual orders, and I want to see um, what is the sales and the profit that we see by individual order. Okay, so I'll bring sales into the rows, profit into the columns. Okay, sales here, profit here, and individual orders that I have. I want this visual to be at the detail of individual order, at that detail level. Okay, so you can go and select order ID onto the details card. What it will do, like here, all of this sales and the profit combination, this is now going to be shown at individual order level, right? Okay, so we've got this. Now we can see what is the sales versus profit correlation for all the orders, right? With this scatter plot. And within this, I'm also able to identify which are the orders which are giving me high sales, high profit, low sales, low profit, low sales, high profit, and uh, low sales and high sales and low profit. So we can see all these four values. Now let's say I want to look at which are my top most profitable orders, right? Which are my top most profitable. Let's say I choose these highlighted ones. I just select. Okay, I make this. Okay, now I have selected this. Now let's say I can right click on this and I can make a set out of this. Now this will show me that, okay, these are the six orders that I am making a set of, and these are my highest profit orders. Okay, highest profit orders, correct? Highest profit orders. Now I have applied this, I have made this set highest profit orders. Okay, now this has been defined that in this highest profit order set, it has these in or out values. So this static set, so only these six orders are selected as part of this set, which is part of this, right? Now, if I need to analyze my data and if I need to see, um, let's say I've created this analysis. Now I would want to see for each, uh, let's say, if I want to see data by some other dimension, let's say sales over region. Okay, now let me deselect this and I want to see sales by region. Okay, sales by region. And this highest profit orders that I have just created, if I make this a filter, okay, make this a filter. So this means what it did is when I added this as a filter, it only keeps me the filters which are in this like which automatically, so we have the two values, so whichever from all the list of orders, those six orders are my sets, which should be like this set that I have created that will include those six orders, and rest of the other orders are out of this set. Okay, so what, when I applied this filter, it is telling me that out of four regions, those top six orders actually came from these three regions. Okay, because the other region did not show up. Okay, so those orders were not there in this region. If I want to also add this order numbers over here, if I add the order ID over here next to the region, I would be able to see all those orders over here. Okay, I would be able to see all the orders. And if I put this as a filter over here, show filter, it is showing me all those six orders that are there. And we can see that all these six orders are actually coming from these three regions: Central, East, and West, not from the South region. Okay, so my top orders are actually coming from this. So this is because we have this static set and I'm able to see the value for those static set. Also, if I need to know like which customers have placed those highest orders, if I need to know that, I can do that too. Okay, now if the question is, let me recreate this. If I need to know which are those customers who place those highest orders, so I can go and I can analyze the data by customer into my rows, and I can put sales, let's say the sales from each of these customers, and I can now apply my highest profit orders filter, and I would know that these are the six customers who made those top orders. And since we also have these customer names also six, which means that those orders were from six different customers. Okay, six different customers place those six orders. If I add the order ID next to the customer name, I will be able to see those. Each unique order belongs to each customer. Okay, so please see if you are able to see this at your end. If you are able to see, find the customers who place those highest profit orders. Now, here we have created a static set. So I have predefined that, okay, these are the orders so far that were the highest one. But it may happen that in future we may get some more orders which may have even higher profit than these, but this will not automatically update and it will not show only the highest as of that time. So it will static at the point of analysis you are making these sets. Okay, another type of sets which you can make are dynamic sets. Okay, dynamic sets. So let me give you an example of dynamic set. Now in the dynamic set, let's say I want to know which are my top 20 customers. Okay, which are my top 20 customers by sales, which are my top 20 customers by sales. If I need to know this, then I can create a set for this. Let me go to a new sheet. So you can go to the customer name and you can go to create, create a set, create a set. Okay. And in this set, you can put a condition here. Let's say I put a top condition. Okay. So top by field. Okay. So I want to keep top 20 customers by sum of sales. So put sales, right? And sum as the aggregation. So top 20 by sum of sales and click OK. And also rename this to, let's say, top 20 customers by sales. Okay, click OK. And now my this set is there, top 20 customers by sales. This set is over here. Now, if I need to see which are my top 20 customers by sales, okay, I can put the customers into the visualization. Let's say the row customers on to the rows, sales onto the column. You can sort the result in the descending order, right? So this is whole list of customer by their sales value, correct? All I need to do here, if I need to see my top 20 customers by sales, is using this set onto the filter, drag and drop it onto the filter. Okay. Now this is filtered only for those top 20 customers. And these top 20 customers are always going to be dynamic. Okay. If your tomorrow new customer comes in, which becomes the highest customer in this, that customer will be included, and the lowest customer here will be moved to the rank 21 and will be excluded from this set. So let me know if you are able to see this top 20 customers filtered here. So whenever you need to show top results, top 20 customers, top 10 customers, those kind of result you can do with set as well as with filters. Sally, what is almost the same thing from what? From the previous set, you're saying? No, so in the previous set, we are defining the order numbers, which are the top order numbers, by manually selecting those order numbers from the visual. So we had a, okay, that visual is gone. We had a scatter plot and we are just selecting the exact order numbers and defining them as the top orders, highest orders. But here it is based on the condition that only keep those customers which has the highest sales. So here there is a criteria with which the top customers are shown, right? The set is defined with this criteria. Keep the top customers based on sum of sales, not based on the fixed names, but based on this criteria. That's why this is dynamic. Okay, if tomorrow new customer comes in which is among the top 20, that will be included here in this set. Okay, now with set, one way that you can use here is that you can filter and you can show the result for only the top 20 customers. This could have been achieved by applying a filter as well. Okay, like this filter we have applied through set. If I remove this and if I simply add a customer filter over here, customer name filter, on and that customer name filter, if I had applied the top 20 customers by sales and applied, I would have given the same result with that as well. If without applying set, if I simply add customer name onto the filter and applying that top n customers, that would have also given me the same result. So this result of just showing the top n results, this can be achieved with both set as well as with directly with filter. What you cannot do directly only with filter is that you cannot show the other ones which are not part of this set. Okay, so if I want to just highlight the ones which are top 20 and highlight the ones which are not top 20, then I can use set over here and I can put this set top 20 customer set onto the color shelf. Okay, color mark. So go and add it to the color mark, and now it will show you what is in and what is out of that set based on this color code. If you add it on the filter, then it only keeps in as the filter. But if you put it on the color, it keeps both in and out. And you can see your top 20 and the remaining here. Another way with which you can use the set is if you want to see the proportion of, okay, for example, here now, if I want to see, I have How many customers do I have in total? I have about 20,000 customers, right? 20,000 customers. Sorry, 2,000 customers in this data. Let's say I want to know what is the contribution of sales that my top 50 customers are giving versus the remaining others. Okay. What is the contribution of sales that my top 50 customers are giving versus the other? Okay. So if I need to do this, then let me just modify this existing set itself. Instead of top 20, let me change it to top 50. Let's say I change it to this. Okay, automatically now this will be colored for top 50 and the remaining. Now, if I need to know what is the contribution of sales by top 50 and the remaining, I want to analyze this. I can do this too. I can add another sheet and I can simply create a sales onto the row. And let's say I go to the show me and I choose this to circle, or not the circle. Let me choose. Okay, let me keep it like this. This is the sales. Okay, total sales. Okay, I kept it in the column. We can see the total sales. And I just want to see what is the contribution of this total sales coming from my top 50 customers and the remaining. So now I have this set and I can bring this set onto the color shelf over here. Okay, onto the color shelf. And now I can see that the top 50 customers are giving me this much of sales and the remaining are giving you this much of sales. Okay. If I need to know the percentage contribution of these, then I can bring sales on top of the label, right? And I can convert this into a percentage of total table calculation. So go change it to table calculation, which is percentage of total. Okay, that's all. Okay, so top 50 customers are giving me about 22% of total sales. How many customers do I have in total in this? I can also view that. So I can put just the customer ID, okay, customer ID, and put it on top of the label, right? Customer ID. But I don't want these customer IDs as actually the customer IDs, but I want to aggregate these. So go and convert this into a measure, not just this, but a measure which is count distinct of customer ID. Measure count distinct of customer ID. Okay. So 50 customers giving me 22% of the sales and remaining 743 customers are giving me about 77% of sales, 78% of sales. Yeah, because Neha, did you not change it to top 50 customers? I changed my top 20 customers to top 50 customers. You may have forgotten to do that, right? This is now top 50 customers. Okay, still it is coming like this. Okay, can you share the screenshot of your visual, like the screen, entire screen? You did not change. You still see the number on the in the blue is 20. Do you see 50 written over there, Neha, or 20 written over there for the count of distinct customer? Then you have not changed it to top 50 customers. You are not showing top 50 customers. Why would the count be 20 if you are showing the top 50 customers in that set? What about the others? Are you able to see the same result? Top 50 customers contributing to 22% of total sales. Remaining 743 customers contributing to 78% of the sales. Zaldus, what is the meaning of in and out? So in and out sets are always represented as, when you use the sets, they are always represented as whatever you are showing, whether that is part of the set or not part of the set, which means the set you have created, which is the top 20 customers, whatever data that we are displaying on the worksheet, whether that is part of those that set, which means if we are showing those customers which are part of those 20 top 50 customers, then it will show that this is in. If those are not part of the set, then it is out. So it always, sets always show the data as the whether something is part of that is it a member of that set or not. That's why in or out. Okay. Another tricky question that many uh, in many places it is asked about set is I am, let's say I am able to see my top, let's say I am able to set, I'm able to create top uh, 20 customers or top 50 customers. Then is it also possible for us to show bottom 20 customers in the same worksheet? Okay, so the tricky question here is about the same worksheet, whether that is feasible in the same worksheet or not. Okay, this becomes sometimes becomes a bit tricky. How is that possible? In separate worksheets, we know we can do in one of the, you can create one filter where you show only the uh, top 10 result. In another worksheet, you apply a separate filter which is on the bottom 10. And then you can keep two separate sheets. You can bring those two separate sheet in a dashboard and you're able to show that. But how do we show this together in one view? How do we do that? So this can be achieved as well using sets. Okay? This feature can be achieved using set. Let's look into this. So I'll create one more set here and let's say I'll keep this with the example of top uh, top. I'll give example here with the products. Okay. So I'll just show which are my top 10 products and the bottom 10 products. I want to look at those. Okay. So we'll create the set based on the products. So here's the product name and I can go and create one set which is top 10 products based on, let's say I use the here profit, top 10 based product based on the profit. Okay. Top 10 products by profit. Okay. Top 10 profitable products. I got this set. Okay. If I need to view top 10 top 10 products, I can easily see that I can bring products into the rows and profit onto the column, sort the results in the descending order, and just apply this as a filter. Top 10 product by profit. I'm able to see the top 10 products. But how do I see bottom 10 as well within the same worksheet? That is the challenge. Top 10 I can see or bottom 10 I can see, but together how I want to see that. So what we will do here is we will create another set, a separate set first of all for the bottom 10. So once again on the product name, once again go and create a set which is instead of top, this time I'm going to use bottom 10 by profit and click OK. Sorry, I need to rename this properly. Bottom 10 products by profit. Okay, we got this. Where did it go? Okay, it's here at the top, very top. Okay, so we got the bottom 10 product by profit, we got the top 10 product by profit. And now using these two independent sets, we can make a combined set. We can make a combined set that whatever the members which are part of set 1 and whatever the members which are part of set 2, I want to merge them together and make a new set. Okay, this is called combined set. We can make combined set. So to make a combined set, you can select set 1, then press Control key and select set 2, which is this. Okay, so just select both of these, set 1 and set 2, right? Select both of these and then right click, and you'll see an option of create combined set. Okay, very simple, right? Now we'll create combined set. In combined set, you will see this kind of window where you see this two sets here, and you get a choice of how you would want to combine these two sets. Okay, how you would want to combine these sets. So there is, these are called the Venn diagrams, right? Venn diagram. This is similar to what you have seen when we applied joins, right? You have those full join, left join, inner join, right join. This is similar to that, right? So if we want to make a new set which includes member in both the sets, then the first option. If you want to make a set which is only the common members in both the sets, then you can go for this one. If you want only the ones which are part of first one and not the part of the second one, or which are part of the second one and not part of the first one, so you can choose which type of combining you want to do. In this case, I want to see both top and the bottom together in one view. So I want to make this first option, which is use include all members in both the sets. So this would be a new set, top and bottom 10 products by profit. This is a new combined set, top and bottom products by profit. Okay, and now we got this new combined set. Now, instead of this visual getting filtered for the top 10 products, I would now filter it based on this combined set. Okay, top and bottom. And I want to include, just a second, why is it not showing? This should be bottom 10 products by profit. Okay, this looks correct to me. Why is it? This is showing the top 10 products only. For the combined set, always remember that the combined set always work on the same dimension. Okay, same dimension. For example, we have created these two sets. These two sets are both applied on the products. Okay, if one set is on product and another is on, uh, let's say, customer, and you want to do a combining of two sets, that doesn't work. Okay, it would always be on one dimension only. Okay, remember this part. Okay, so let me save this Tableau workbook. Now we'll move to the next uh, topic, and that is calculation. Okay, so let's move to that one. Let's move to understanding calculations in Tableau. For calculations, I want to start new. I want to open a uh, new workbook. We'll use the same data, but we'll open a new workbook just to make it a bit cleaner. So we'll save this and I'll open a new one. Okay, go to new. We'll use the same data. So just open a new one, but with the same data. So in the new one, we'll go to the data source. I'm going to use the same data, which is the sample superstore. And I'll bring the orders over here. Whenever it comes to calculations in Tableau, the calculations are always applied on a particular level of detail. Okay. Always remember this word. This is very important when it comes to Tableau. Okay. Calculations are performed at a level of detail, a level of detail. Remember this term, level of detail or LOD. level of detail. So calculations are always performed at a level of detail. Now, what is that level of detail? It can be, let's say, if I am looking at uh, row level data and I want to apply something at a calculation that needs to be performed at each row of my table. Okay. So that means there the level of detail is at each row level. Okay. At each row level, I want to apply a calculation. Or in some other case, let's say I want to do a calculation which needs to be applied at a level of customer level. Okay, customer level. So this calculation needs to be applied, aggregated at the customer level, not beyond that, not below that, at the customer level. So there, the level of detail would be that it will be at the customer level. Or in some other case, it could be, let's say I want to calculate something which needs to be at the date level. So there, that would be the level of detail. So whenever we perform calculation, there will always be some level of detail which would be there in the context. Okay. So in the calculations, typically you have these four type of calculations. One is the row level calculation. Okay. So you have the calculations levels or level of details. So one is you have row level calculation. Okay. Row level calculation, as the name suggests, row level calculations, which means if I create something, a calculation needs to be performed on each row, right? Similar to how we have row context, we have in Power BI, we have the row context, we have the all the DAX calculations, DAX columns that you create, those are all row level calculation. Similarly, you have a row level calculation here. Then the next is in the just before we move forward here, in this row level calculation, just remember that whatever that you're doing, a row level calculation that you're doing, those calculations are always resulting in storing some field physically in the data model. Similar to the columns in Power BI, you are increasing your data size, you are physically storing the data. Same thing happens here as well. So here as well, row level, which means that the calculations are saved calculations are saved in the data model, and the new calculated fields can be reused whenever, any number of times whenever you want to use. So there will be a distinct field basically will be created when we do a row level calculation. Versus you have the next one, which is aggregate calculation. Aggregate calculation. Aggregate calculation, like if you are doing sum of sales, sum of profit, average of uh, average of orders, right? Count of customers. These are all aggregate level calculation. Okay, these are like sum, count, max, average, right? Those are all aggregate level calculation. These are calculations are used whenever you want to derive a new measure. When new measures are needed, or when measures, or let me put it this way, this is used for measure calculation. Let me put it this way, used for measure calculation, any measure. So measures, you eventually, whenever you apply aggregation, you convert them into a measure. You'd want to do a measure calculation. For example, we use that customer count, right? Customer count. So we did use the customer ID, which is a dimension, but we converted it into a measure by applying these aggregate function. So we did count distinct of the customer. So that became a measure. So we use aggregate calculation for the measure calculation. We derive measures. Okay. Now these ones are up to you whether you want it to be you want to use it on the visualization on the fly, or you want to save this calculation in the data model. Okay. Can be created on the fly or can be saved in the data model. Okay. For example, whenever we are using sales, it is converting into sum of sales or uh, sum of profit. So that kind of measure calculation is doing on the fly. We are not saving any new field into the data model. But if we want to save a new field with the value as sum of sales, we can do that too. That can be a new measure calculation that we can do. Okay, so you can do it and you can save it, or you can just create it on the fly. These are the aggregate calculations. Third type of calculation, which we have also seen so far in some places, which are called table calculations. Table calculation. The level of detail for the table calculation is whatever that you see on the worksheet, that becomes the context at which the table calculation would work. Okay. So here you can have things like you can calculate running total or percent of total. Okay. Or difference from previous, something like this, right? So you have these table calculations which has this level of detail of the fields used in that worksheet. Okay. So whatever that you have on your worksheet or on your canvas, those becomes your level of detail. Canvas is the level of detail here. Okay. On that level. In the table calculations, you also have certain functions which are not available directly on the quick table calculations. You can use some table calculation functions can be applied, like windows, window function, like window function. We'll see that there are some table calculation function that you can do. The fourth type of calculation level is that once your aggregation is done, then on top of the aggregation, you can do certain statistical inferences of your data. Okay, those are called post aggregate calculation. Let's say you calculated something and then you are doing some kind of statistical calculation on top of this, like whatever output that you have got from this result, you want to find out whatever is the median of that output that you are getting on the visual after the aggregation, or what is the average value, or some minimum maximum of the total that you see after the aggregation. So you can do on top of that, you can apply some statistical calculation on top of the aggregated calculation that you see in your canvas. Okay, so these are the few calculation levels that we do: row level calculation, aggregate calculation, table calculation, and then you can do some post aggregate calculations too. Let's get started and let's look at some of the examples of the row level calculations. Okay, so in row level calculations, now looking at our data, we want to create some row level calculation. Now I want to calculate a calculation which is simply very simple. I want to calculate what is the, let's say we, if you remember, we did the, let me go back to here. Now, let's say I want to calculate, um, let's um, let us say that we have in our data earlier we had done the split column. We learned how we can do the split column directly in Tableau, right? So you have this option of split column, correct? So on any column, let's say you have this customer name. Okay, you want to do a split column on this. You can do a split, right? Similarly, so what did this split did? Okay, let's say I do a split column over here. Okay, what it did is it generated two columns, one for the first name and another for the second name, right? We got this first name and the second name. These two are calculations, okay? And calculations can be, like here we are able to see these calculations by this equal to sign before this type, whether it is a measure or at a dimension, but there isn't this equal to sign too, okay? And this equal to sign represent this calculation. You can also see that this is of the type calculation. Now let's say I rename this over here from this to first name and this one to last name. Okay, first name and last name. We got these new calculations. If we go to the sheet, we have these new calculated fields, the first name and the last name now coming over here. And if I want to know exactly what calculation was applied over here, I can go and see what is the calculation by go to this drop down and see in the edit. So any calculated field, if you go to edit, you will be able to see what calculation was exactly applied here. And the calculation was this. It used a split function. Okay, it used a split function. What does split function do? So of course it splits the text value into multiple parts. So it uses the first parameter is which field you want to use for this for doing the split. Then it asks for within this which is the delimiter at which what is the criteria upon which you want to split. So here we specify the delimiter, which is at the moment, which is the space, and then on which occurrence of this delimiter you want to split. So the first occurrence of this delimiter, based on that, I want to split. Okay. So this is how we can see this formula over here. This is the calculation. Okay. Now let's look at some other row level calculations here that we can apply. So I want to do in my data, let's look at the data once. So if you want to just quickly look at the data, what all do you have um, in this data? You can go to this view data over here, this small uh, icon over here, and this will let you see your data over here. Okay, view data. Now in this data, I have the sales. Okay, I have the sales and I also have the discount. Okay, I have the discount. Now, if I want to calculate discounted sales, what is the discounted sales that we got? Okay, so this is the sales, but I want to know what is the discounted sales that we got. So I need to do a row level calculation here. So I want to see at each row level, what is the discount that is being applied. And this discount, if you see, this is in actually percentages, but it is shown in number over here. If you see the value of this, um, which is if you describe this column, you will be able to see the value of it. We learned about this describing part too, to data source, this discount. Let's go and describe this. Okay, describe. Okay, so this shows that the minimum value is 0 and the maximum value is zero point 0.8. So this zero point 0.8, you will not provide a, you know, 8 80 cent of discount. That would not be the case. So it has to be percentage. So minimum 0% to 80% you have given discount in your orders. Now let us calculate a new field, which is a discounted sales. So go to your sheet. I want to create a new calculated field. Go to this drop down over here. One way is that you go to the small drop down and create a calculated field. Go to this drop down, go to create calculated field. Okay, it'll open a calculation pane over here, window of calculation. Okay, I want to calculate discounted sales. Discounted sales. Discounted sales is, I need to use the field directly, the sales field. So just start typing sales and it'll give you the this again. The intelligence feature will let you give you the fields or the function name as you start typing. So I want to use sales field. Okay, sales field, and I want to multiply this with 1 minus discount field. Okay, so sales multiplied by 1 minus discount, that will give you the discounted sales. So let's do this. Click OK. We got this new measure here, which is discounted sales. We can use discounted sales in our analysis as we require. So we've got this. This is how we can calculate a row level calculation. Now there will be this discounted sales, which will be at the row level. You will have the information. But this will not show the calculated field over here. Let me see. Discounted sales. Okay. This is, this could be sorted. Yeah, I can see actually discounted sales is available here. I'm able to see this discounted sales. So wherever we have this discount, now I'm able to see row level information for the discounted sales. Similarly, now I want to calculate what is the profit percentage in each of these transactions. Okay, what is the profit percentage? I want to calculate that. How will I do that? How will I calculate the profit percentage? So I want to know what is the profit. Okay, what is the profit margin? You can call it profit margin as well. What is the profit margin? So I want to calculate profit margin. So profit margin is simply profit divided by sales. Okay, profit divided by sales. Okay, now I've got this profit margin. I want to view this profit margin in my in the in the visuals, right? And I want to, let's say I want to see the profit margin by individual subcategories. I want to see the profit margin by subcategories. So I'll go and use subcategory in the rows and the profit margin onto the column. Okay, profit margin onto the column and sort it in the descending order and put the, let me keep it like this. Okay, so this is how I'm getting the profit margin for each subcategory. Can you all do it? Can you all create it? Let me know once you have done it. Okay, now here this calculation that we have done, there is a big problem here. Can you all see what is the problem? There is a big problem here. What is that? Negative value is not a problem. If your profit is in negative, you can have negative values. What is the problem in that? Okay, Neha, got a point. Profit margin is not shown in percentage. That's correct. What else? Anything else? Think more. There is a fundamental problem here. Very big problem. You're talking about very minute things. There is a very big problem here. Okay, let it be. You're not able to get this. I want you to think through, think about this. What is the range of values that we are seeing here? Profit margin of the range of 50, 100, 150, 200, all the way going to 500. Can profit as a percentage of sales be greater than 100%? Is that even possible? Can profit as a percentage of sales, can you get more profit than the sales that you got? Is that even possible? Okay. So that is the biggest problem over here, that we are not showing the metric correctly over here. What we are doing here is for each row, we are calculating the profit margin. Okay. Something like this. So for first row, your profit margin is, let's say, 80%, or we write it as 0.8. For the second row, it is coming as 0.4. For the third row, it is coming as 0.2. Okay. And the fifth row, it is coming as, let's say, 0.5. What we are doing here is eventually we are showing sum of profit margin. So in the output, we are just summing all these values, 0.8 plus zero point 0.4 plus zero point 0.2 plus zero point 0.5, which is adding up to about 1.9, right? 1.9. This is coming around 1.9. Okay, if my math is correct. So this is not how you should be aggregating it. Okay, if I, so sum will give you this. What about average? Should I do an average? Would that give me correct result? If I, instead of doing sum, if I do an average, what will be the average of this? Let's say if I do average, okay, so average would be 1.9 divided by 4. So average would be around point, what would be 7.5 or 9.5? Sorry, not 9.5, but it has to be point 6, sorry, 5.95 something, 5.5, 5.75, 0.575, something like this. Let's see. You can help me with this. 4.75. Yeah, 4.75. Yeah, not 5.75, 4.75. Anyways, that is still a better figure. That is still a better figure than this value, right? Because 4.75 is still closer to my actual profit margins that we have. Okay. So if I convert this from sum to average, go to measure instead of sum, Instead of measure, which is by default sum, if we change it to average, that's still better. Okay. Now this is showing at least in the proper ranges. Okay. At least it is coming in the proper ranges. Is it still correct or not? We'll figure this out. Okay. I think that it is still not correct. Okay. Think about this. Still, it is not correct because we are still doing an average of the values, but these are not truly the actual profit margins for the subcategory level. Okay. So Zaldus, you're saying that we need to do it from the total value, total profit divided by total sales at the subcategory level. That is what we should be doing, right? So yeah. So here the problem here is also that we need to do a we are taking an average of percentages. Okay, average of percentages never gives you the correct result. Okay, so we are not supposed to do an average of percentages here. If we do average of percentages, then there can be some categories where the uh, absolute value of the profit and the absolute value of sales is negligible, but because just the percentage wise their profit margin is very high, they will shift the average, you know, upwards or downwards, right? Okay, let me show you like explain you this with an example. Let's say for the category, let's say tables category, we have three rows of data. Okay, tables. First having profit of 50. Okay, let me write it like this, or let me okay, let me category. Okay, row profit, sales, and profit margin. We have these, let's say these are the data that we have. Let's say we want to only analyze the data for only tables, and I want to see for row one, let's say row one, profit is 80. Okay, sales is 100. So what becomes my profit margin? 80%. Okay, 80%. I have another row, once again tables. This is row two, and I did here my profit is 4, just $4, and sales was $5. What is the profit margin? 4 divided by 5 into 100, 80%. Even here the profit margin is 80%. Okay, let's take a row, another row, tables, row 3. Okay, here once again you have, let's say your profit is once again, I think with these two rows it will be much more clearer. It will be much more clearer. You will understand this example. What will be the, if we just apply average of these two rows, what will be the output? What will be the average? If we simply apply average of profit margin, what is the output? Write it in the chat. What will be average of 80 and 80? 80%. 80%. Okay. But the true profit margin of tables is sum of profit divided by sum of sales. Okay. So it should be 84 divided by 105. Okay, 84 divided by 105. So here it would be, actually here also it will come quite close to 80% only. I probably should have given another example like this. If I had taken, let's say I should have given this example. Okay, this will be much more clear. If I had $1 of profit and by this sales, it would have been 20. Okay, this would have been 20. What will be the average of this? Average would be 50, right? 80 plus 20 divided by 2, right? And here in the sum of sales and sum of profit, here it would have been 81 divided by 105. What will be that? That will be around 80 only, or 79, correct? 77, Julius, perfect. Now which one is correct, 50 or 77? Okay, it is 77 which is correct. And what we are showing in this visual, we are showing 50 in this visual, correct? Because we are simply taking the average of each row level value. Okay, so whenever you apply any calculations and you see those calculations in the visuals, always remember what is the level of detail at which that calculation is applied. So in this case, the calculation is at the row level, and you need to be careful when these row level calculations, how these needs to be aggregated. Okay, so for now, let's live with this average value. Okay, and I'll later on, once we discuss the level of detail calculations, we will calculate the correct calculation on this. Okay, so let us get back to you. Let us get back on this one in some time. For now, let's use this as it is. Now, the other formatting part that you're talking about, yes, we should also take care of this, but that is just the formatting part. Fundamentally, there is no problem, just the formatting part. So now, whenever I want to use this profit margin field, okay, I should always want to see this in the form of percentages. Okay, I always want it to be in percentages. So what you do in those cases, whenever you want to change the uh, property, the default property of that measure, what is the, in what aggregation it should show the value. Okay, you can apply, you can change the default property of that measure. So how you do, go to this small drop down, okay, and go to default properties. Go to small drop down, go to default properties. In the default properties, go to the number format, okay, and change its format to percentage. And you can keep 2 decimal places, that's fine. Okay, now this will be in percentage. You can add the label on top of these values. They will always come in percentages. Okay, so you just click on the small drop down, go to default properties, go to number format, change that to percentage. Okay, now we know that this is profit margin is not the actual profit margin that I can use directly in the fields. So I would probably go ahead and rename this a bit more appropriately. So I'll just change it to profit margin per row. Let's say I give this name. This will be more appropriate because we are calculating this at the row level. Okay, so profit at each row level, we are calculating profit margin. Let's change the field name to profit margin per row. Now I will just make some, I'll show you some of the formatting here that you can also do when you have to display anything related to the profit margin. The ideal way to show these, we'll also work on showing these figures correctly. But whenever you show only the profit margin, it is ideal that you also show the what is the sales value, Okay, the sales value that you have. So you should always think about those details. You can add sales as well onto the label. Okay, you can add sales as well onto the label, and you can add the profit margin onto the label too. So both you can show on the same label. Okay, and this one, instead of sum of the sales, we will once again change it to average. Okay, so we are showing the sales and the profit margin over here. And let me actually, this bar would be better to show with the sales. I'll just change it and show sales instead of the profit margin, and sort this based on the sales value. Okay. Okay, now there is nothing negative here because we are showing this by sales, but I also want to show whichever has the whichever has profit margins, all these different profit margin values. Okay, and I will simply also color this with the just the profit margins, where the profit margins are high, low, right? Those kind of details. So what this is showing, this is telling me multiple things. Okay, this is telling me that there are there is phones, chairs, and storage having the higher sales. But when it comes to the profit margins, then paper, envelopes, labels, copiers, those have higher profit margin as compared to phones. So they have better profit margins as compared to the ones which are having high sales. Whereas tables, binders, machines, they have very high sales, but they are loss making. They are loss making subcategories. Although we are selling more, but we are making loss in those. Okay. So this, and one more thing that you can do just for the representation purpose here. We added sales and the profit margin onto the label, but this label is not visible for all of these. And the reason why this label is not visible, because when we added both of these labels, they're coming one below each other. And because of that, this label, we don't have enough space to see all the labels. Okay. And that's why this is not visible. Just to make it visible, you can just make this label position side by side, both the sales value and the profit margin side by side. That will be better for just the viewing. So you can go onto the label formatting, go to the label, and here you can go to these three dots to see what your labels are here. Okay. So here, first one shows that the profit margin per row. Second one shows sum of sales, here, the calculated values. I can go and change this position of these in one single row to make it visible. So I can copy the sum of sales from here. Okay. I can click on the first row and add maybe a divider, and I can paste this sum of sales before this. Okay. So something like this. They both are coming in the same row now. And I'll also reduce the size of these, both of these, to 8 and click apply. Okay. And now see, both of these are visible in the same row. Okay. So let us look at one more row level calculation. So we started looking at the row level calculation. We'll look at one more row level calculation here. So we have here data for orders. Okay. And we have information like when the order was placed. So we have the order date, and then when the order was actually shipped. So we have a ship date. Okay. So there will be some days difference between the order date and the ship date. Normally, the lesser the days it takes from order receiving to ship, the better it is for the businesses. Okay, so businesses always try to work on this efficiency, how early they can ship the orders which is received. Okay, so this becomes a very good metric to measure the overall operations efficiency of the supply chain department. Okay, so you can calculate the days difference between the ship date and the order date by using row level calculation and with a function called date diff. Okay, so we'll create a new calculation here. My calculation would be create new calculated field. Here it would be, let's say I call it days to ship. How many days does it take to ship? Okay, so for days to ship, I will use the function here date diff. Okay, date diff. Now here I've started using this function and it tells me some information about this function date diff. So this requires a date part, then the start date and end of the date, and then there is an optional start of the week parameter. Whenever I need to use any functions in the calculations and I want to see more details about the function, you can see there is a small arrow at the end at the right here. You see this small arrow, okay, in this calculation window. If you click on this arrow, you will be able to see additional details here, and you will be able to see details about the functions, all the functions that are there, as well as the function that we are using, that we have selected right now, and what all details, like the parameters and some details about this function. So this returns the difference between two dates when the start date is subtracted from the end date. Okay, the difference is expressed in the units of the date part. So you define what units you want to keep in the date part, and if the start of the week is omitted, the week start day is determined by the start day configured for the data source. Okay, so basically here is an example. If I want to see date diff in the form of months, I can put a start date, I can put an end date, and then this day start of the week is an optional field. Okay, so let's calculate the days difference here. So date part, let's say I want to see this difference in the form of days. So I can put day in the date part, day in single quotes. Then the start date is order date, the first date, order date, and the end date is ship date, the second date, ship date. And I can close my function with this much. Okay, so calculate this measure days to ship using this formula. Let me know once it is done. Zildas, this is not DAX. Okay, this is Tableau's own formula language. Okay, this is its own formula language. This is not DAX. Okay, so we calculated this days to ship. Now I want to analyze days to ship and I want to see what is the average days to ship, like how much time does it take on an average for me to ship the products. Okay, and I want to see this across the different states that I have in the data. So let me create another sheet over here. Okay, and this time I'm going to use a map visual. So I'll put country into the detail and state onto the detail too. Okay, and I want to use the days to ship on the map as a measure. Okay, so days to ship. Let's say I will this time I'm going to use a filled map over here. So go to show me and use a filled map instead of this. And in the filled map, I will color this based on the days to ship. Based on days to ship, I will color. Okay. Now this is, if you see, this is sum of days to ship, and currently this is coming as sum of days to ship. So whenever it comes to days to ship, what should be the default aggregation that we should keep here? Days to ship. What should be the default? What do you think? What should be the default aggregation for this? Should it be average, sum, count? Days to ship, what should be the default aggregation for days to ship on the data? No, all of these are incorrect. Why would we take a count of a value? So days of the ship, this is telling me how many days does it take for an order to ship. So in each row, I'm seeing the number of days difference. And if I need to know overall across the data how my performance is, okay, for multiple orders, for multiple instances, in general, what is my performance? So I should be taking an average. Average is the much better aggregation here, not count. Count is very bad response. Please focus on what we are learning. Understand, think about this, right? Days to ship. So for each order, we are able to see how many days does it ship on an average, like across multiple orders. If we need to see, we use average, right? On an average, how much time does it take for it to ship? So we will go and once again make the default property directly of this. And in the default property, I can go to aggregation and I can change it to average. Okay. Why did I change the default property to average? So that every time whenever I select it, I don't need to convert it from sum to average. By default property, whenever I bring it to the color, it will always be average that it will consider. Okay. So now you can see the average days to ship. The minimum value is 2.8 days and the maximum value is 5.7 days. So in an average, it takes between these dates. Okay. Now, whenever we use this color coding, right now we have used this color coding, and normally the color coding will by default will come in this gradient range, which is having the lighter color with the lower value and the darker color as the value increases. But here in this metric, average days to ship, what is a better number? A lesser number or the greater number? Low value of days to ship is better or high value of days to ship is better? What is better? If low value, less is better, right? If it takes less number of days, isn't it better? Okay. So we should adjust it accordingly. So we should be keeping these kind of things in mind whenever we are creating visuals, that they should be all intuitive when users look at the data. So we'll go ahead and edit this color. Okay, we'll go ahead and edit the color, and in the colors, we will just switch this from um, just switching it, and we will make it, first of all, we'll choose some other range here. Let's say we take a range of from red to green. Let's say I want to keep a range from red to green. Okay, red to green I have taken. Okay, now here the lower is coming in red, but actually ideally the lower should be green, right? So the lesser is better. Green always represents good value, red always represents not good values. So if we have something which is going from green to red, that would be better. But we do not have any. We don't have any. Um, so what you can do here, whenever you have this palette and you want to just do the opposite of this, then there is this feature called reversed. So I can just simply do a reverse of it, and it will just convert. This will just convert from green to red, red to green to green to red. Okay, just do the reverse and click on apply and click OK. Let us also display these values onto this map as well. So we will bring this days to ship as well as the label here. And maybe I'll just reduce the font size a bit. Another thing here is that this number with up to 3 decimal places, I don't see any use of this 3 decimal places. So I will also reduce the decimal places on this. Okay, so we'll once again go make this change in the default property for this days to ship. Go to the default properties, go to the number format, and number format, I would want to it to be a number in the custom with only 1 decimal place. That's all. 1 decimal place. Okay, so I hope everyone has done this. Now, here I'm looking at this um, chart. I have done this formatting. Now, I want to make sure that when I uh, look at these figures, I don't get confused um, by these color coding. Okay, so if you look at right now, let's look at this and tell me which state is the best, which state is having the best days to ship. Okay, which one is this? North Dakota. This is having amongst the best sales, sorry, best average days to ship. Correct. Then followed up by Louisiana. Then you can see West Virginia is also good, right? These are the values. But if we apply any other filters on top of this range may change and these results may also change. Okay, this range may change and this result may also change. So let's say if I just go and add a region filter on this, I apply a region filter. Okay, and I select all of these, apply, and I want to see this filter here. So I will just select show filter. Okay, so we have all these regions. When we select all the regions, then this is the insight that I'm getting. Correct. Now here, if I look at all this data, it looks like here we have South, South doing really well. Okay, South doing really well, right? Okay. Now if I apply a filter only on South, see what happened now. It was doing really well earlier, but what happened now? Everything is coming in red. If someone goes and apply this filter only on a specific region, then these ranges of this color coding will reset based on what the high and the low value that you have on that region. And it may give you a completely different picture. Here, if I have selected South, everything is appearing in red. Whereas when all the regions were there, this was amongst the best region overall. Okay, so it's just the context at which you are looking at things. Sometimes it can be a bit confusing, and it can make like people uh, around 3.8 and above, they are all looking bad, but that's not the case if we look at overall data. Prerna, the range resetted. That's why it happened. Filter is not showing different result. Result is same, value is same. The color coding is changed. Earlier the range was from 2.9 to midway. So midway would be around 4, 4.5. It is all green. Okay. But now when we only select south, our maximum is only 4.4, which means overall everything is good. But among the good, there are also some not so good being highlighted too poorly over here, which is something that you should consider whenever you're creating. And you should, in that case, instead of leaving this to automatically adjust every time, you can consider giving some threshold which can be a indicator of good value. Okay, so what we will do in this case is we will adjust our color coding slightly to make sure that this does not happen and people don't get confused. So once again, go to edit colors, and this time I'm going to give a threshold value where till when till that threshold value we will be able to see everything as good. So go to advanced, okay, and give a center to it. Now I know that center is 4.2. Let's keep it hard coded to 4.2 here. Whatever that you want to keep, 4.2, 4.3. Let's say I hard coded to 4.2 should be your center, and this is hard coded. And you can apply this hard coded center now. What this would do is, now moving forward, even if I select only south, this center would be there. So now the range is from 3 to 3.4, but my center is at 4.2. So this will still look good. Okay. So everywhere this color condition, this conditional formatting, this would not change. Okay. Is this clear, everyone? Why we are doing this hard coded center in the color code? Okay. Let me know once you're able to do. Okay. You don't have this advanced. Okay. There should be some other way to do it. Anyone wants to share your screen? I may just want to take a look at it. Anyone wants to share? Okay, go to the edit color. Where are you going? You need to go to that color legend at the right. No, not here. Where are you going? Edit color. Yes, 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 yes. Yes, that was it. Yes, center. So just choose center automatic. You have the drop down, center automatic. Go to the drop down and go to custom and put the value 4.2 there. That's all. It is there. Okay, it's just the newer would mean that there would be more options. There would not be lesser options. There would be more options. It's just the UI would be slightly different. Okay, everyone, let me know once you're done. Okay, now let's. So this is how we can apply row level calculation. These are all these some there's the examples that we have covered. These are happening on individual rows. We have applied row level calculations. Now the second type of calculations that you can do is aggregate calculations. So any calculations that needs to be performed with some aggregation. Okay, those will be aggregate calculations. So let us create an aggregate calculation in this case. So now we will once again go back to that same example, profit margin that we calculated, but this time we are going to do it with the aggregate calculation. Okay, so this time let us also create one more calculated field and let us call it profit margin. Okay, this will be an aggregate calculation, which means that I need to use some aggregate function and then do it. So earlier in the profit margin, I simply divided profit column with the sales column. But here I need to do first the aggregation and then do the division. So it should be sum, okay, sum of profit divided by sum of sales, okay, sum of profit divided by sum of sales. This type of calculation is an aggregate calculation. Okay, so please do this aggregate calculation, this profit margin. Let me know once this is done. Okay, so we calculated profit margin here, and now we will just look at how different would this be as compared to the earlier profit margin per row that we have calculated. Okay, so once again, let's say if I calculate it for the subcategory level. So this time I'm going to put subcategory onto the column, and first profit margin per row that we have calculated. This is the value that we were getting, profit margin per row, and we took the average of this, right? We took the average of this, correct? This is the value that we were getting. Accessories 21.82. If you remember in this chart, accessories 21.82. Okay, and so on. So we have got these profit margin per row coming like this. Now the new profit margin, which is has the aggregation and then doing the division. Let's use that and see what value do we get here. And we'll just put them just together. Okay, I'll also make the default property of this as percentage. So let me make it default properties, changing it to percentage. Okay, and let me put these side by side. Okay, just choose this side by side chart so that these values we can compare side by side. Okay, now this is the output here, and this is interesting. Okay, this is interesting. So if you see here, now we are able to see this. Let me remove this too, just to see all these values. So we are able to see these two. First one is profit margin per row, the one which is coming in blue color. Okay. So here accessories is 21.82, but actually the profit margin was 25%, 25.05. This is an This is more accurate because here we are taking the sum of the profit first and then dividing it by sum of sales. Appliances, which was coming in negative, is actually positive if we apply the right calculation. Okay, so this is showing minus 15.69%, but actually the correct calculation would have been 16.87%, and so on. You'll see some values have lesser deviation, some values have much bigger deviation, some values are pretty close by, but some are very far off from negative to positive. Okay, so that's why you need to be conscious of what kind of level of detail your calculations are. Okay, so this will give me correct result, and now I should go ahead and update this with not with the average profit per row, but the correct, let's say, or let me keep this to updated with profit margin over here, not profit margin per row. This is the correct, this is the correct result. This is how we should be making it. Okay, I'll just quickly do this, no problem. What did we do? We wanted to compare these two calculations. Okay. Now let me show just these two calculations by um, let me show it at the category level. That will be simpler to understand. Category, we have three categories. Okay. What are the two measures? Average margin per row. Let me also change it to default property to average so that I don't need to update it again and again. This is average. This is what, let me actually show it at the subcategory level. You'll be able to compare the numbers. Okay, this is the data. Accessories at 21.82, appliances at negative 15.69, so on. Let me also compare it with the new profit margin that we got based on sum of profit divided by sum of sales. Okay, these are the two. Right now, this is coming on two separate rows because I have added one measure, two measures in the rows. That's why two separate rows over here. I want to show these side by side. So there is a way to do it. Just go to show me panel and switch the visual to side by side, side by side. Just switch the visual to this. Just do this and let me know if you're able to see the same result. Okay, so this is how we can get the correct profit margin calculation. Let's move forward. Okay, next up, I want to see how I can calculate some basic table calculations. Okay, some table calculations. I want to calculate that. So we will just apply some table calculations here. Let me do a simple view to look at how the uh, let me look at just how the sales is across the different region and how they are aggregating. Okay, and we'll apply a table calculation over here. So we'll use region. Let's say I want to see region wise total sales. Okay, region wise sales. Okay, this is coming like this. Correct. I want to see this along with the different um, different categories too. Let me add the categories as well. So what I'll do here is I'll add category onto the column before the sum of sales. Okay, so I have these individual category. Now just to visualize this better, I'll convert this into a this text table. Okay, so add category region sum of sales, convert it into a text table. Okay, let me know once you are able to see the detail like this. Okay, now I want to just see how the percentage of total looks like. Okay, so let me just change the view first of all to fit the entire width. And I want to see how the percentage of total would look like on top of this. Okay, so and actually let me reverse this. Let me put region here and category over here. I want to see region wise categories. Okay, so this sum of sales that we have, I'll go and I'll switch this to a table calculation as a table calculation. And here I want to apply a table calculation, which is percentage of total. Okay, percentage of total. Now, if you see percentage of total, if this calculation, if you look at this calculation, this percentage of total is currently on the table across. So when this percentage of total is calculated, we can choose how this computation should be, in which direction this computation would be. At the moment, this is set to table across, which means that this percentage of total would be at the row level, and you will be getting at for each region from the total where total sales, you are seeing the percentages for each of these categories. Okay, let me close this. Let's keep it to this percentage of total table across. If we do it like this, then you see these values. So actually, let me keep it standard only. You see these values. So furniture, office supplies, technologies. These three are coming as the percentage of total 100%. And if you add these three, it will add up to 100%. Okay, this will add up to 100%. So in this case, when we apply percentage of total, that will be at the row level, table across. Okay, if you try to aggregate these values in the column level, you'll see that 32%, then 30%, then 20%, 9%, then 34%. If you add these ones, then these will be greater than 100%, right? So this percentage of total is not actually happening at the column level. This is happening at the row level. So individually for each row, it is adding up to 100%. Okay. Let me also add the totals in this view for to make it visible even better. Okay. So how can we add the totals over here? So you can go to analytics pane here and click on totals. Double click on totals. Double click on totals. And this will add the grand totals. Okay, now you can see this value. This is happening, the percentage of total is happening across the values. Okay, so this total is 100% in this row level, and you are seeing the percentage of total across these values. Okay, whereas at the column level, it is showing the grand total, which is nothing but overall for individual. When we do not apply any kind of region filter, then the overall furniture is at 32%. Overall uh, office supplies are at 31%. Overall technology is 36%. That also totaling to 100%. So this totals are at the row level over here. Okay. If in case I want to see these, all of these as percentage of category totals, not percentage of region total, but percentage of categories. So furniture overall 100%. What percentage is central? What percentage is eastern? What percentage is south? What percentage is west? If I want to see like this, then I just change my table calculation. Instead of table across, I'll calculate table down. When we do it table down, now you see your 100% is at the column level. Okay, this percentage distribution is table down in this direction. So now you will see the percentage of region contribution onto the category totals. Is that clear? What does table across and table down mean when we calculate these percentage of total context? Okay, Anthony, how did I add the totals? Go to the analytics pane here, analytics, and double click on totals. In the summarize, double click on the totals. Now, if I want to see just the percentage of overall table, then I can go and edit table calculation. Simply take the table. Simply take the table. This will become the percentage of overall total. Okay. Now everything is just percentage of the overall total. What is the contribution of furniture in central region? 7.31%, 13%. What is the contribution of office supplies in the eastern region? 8.95%. So now this is at the overall total table level. What is the contribution? Okay. So we can see this percentage of total, or basically all the table calculations. When it comes to table calculations, we can see them in the context of table across, table down, or overall table. Okay, let's move forward to the next calculation. Now, this is the basic understanding of the table calculations and how these overalls are calculated. So let's call it table calculation direction. Now let us also use one of the function that is used quite often when it comes to the table calculations. It's called a window function. What does window function do? Window function lets you perform some table calculations on top of the canvas and what all fields you have in the canvas. Okay, so let us go one more sheet here, and once again we'll use the regions over here, region in the row and sales in the column. And once again we'll make it a table visual here. Okay, now I am able to see the total sales over here, but let's say I want to compare it with some average sales among these. Okay, I want to find out what is the average of these each region level total sales. Okay, if I want to do so, then in that case I can apply a window function and I can choose from which value to which value I want to consider to create a average calculation. Okay, average or any kind of aggregation calculation that I need to do. Okay, so this is the window at which I'm looking um at the calculation right now in the canvas, and on top of that I'm applying a windows calculation. Okay, so once again I'll go and create a new calculated field and I'll call it average sales windows. Okay, now here, um, For each region, my sales are somewhere around, you have values. This is 500,000, 678, 391, 725. If I take an average, it should be somewhere around um, between 450,000 to 500,000. Okay, that's how the average should be coming. Let us do that. Let's see what value we get. So what we need to do here, we use window function. Okay, window functions lets you perform any kind of aggregation on top of what which window you are looking at right now. Okay, so window, we will apply Windows average over here, window average. Okay, and here my expression is I want to take the average of total sales value. Okay, so aggregation of the sales, I want to use that and I want to make an average of that within the selected window. So selected window means I choose that take from first to last value in that window. So I can use this function first and I can use the function last just to select all these range of value from first value here to the last value. Okay, which is center to west. Okay, first to last. Here you can see even this, you can see the explanation as well on this just to understand a bit more, but this will do the same thing. So this is kind of index that we are giving for this window, right? So example, the current row index is from 3 to 7. So last you will have 4 over here. Okay, anyways, so we got this Windows function. Let's calculate this and let's see what value we get over here. Okay, Windows save function. Let me add this on top of this, see, and see what the average value is coming. Okay, this coming above 500K, about 574.30. So we are getting this value. Now this is coming same for all the center region because this is now a calculation which is giving us an average of among all these regions. So it is not now filtering the value for each of these regions. This is just telling you what the average is across these region. Okay. Can you please add and see if you can see the same result? Let me know. Okay, so this calculation happens at the canvas level. On the canvas, what all fields we have selected, it takes those into the context and performs the calculation. Now, let's say now I want to just highlight whichever regions have performed above average and whichever regions have performed below average. Okay, so we want to do that. So that can be done by using another field just to identify those performance below or above average. So you can go create a new field. Okay, new field, and let us call it. Okay, sales performance. And here we can use an if function to write a formula. So I'm going to use an if function here. So we can write an if function. In the if function, let us look at the syntax over here. So this syntax is slightly different. Okay, how does this work? So in the if function, first you specify the expression, then you put the then and if else condition, and then end it with an end clause. Okay, so my first expression here is that if the sum of sales is greater than the Windows average function that we calculated. What was the name? Average. This field that we just calculated, average sales windows. If it is greater than this, okay, then you can return then the output should be just this tag and put it in the single quote above average else put below average and close the if condition with an and clause. If sum of sales is greater than Windows average, then above average, otherwise below average. Okay, this is the calculation for sales performance. We can apply this, and now I can use that as an indicator in this region wise sales. So I can simply add this new field that we got, which is sales performance. Okay, sales performance, and I can color code it based on this. Color coded by sales performance. Above average is coming in blue, and below average is coming in orange. Correct. I can get rid of this Windows average as well directly over here. If I don't need it, I can get rid of this too. And I can simply see which region are performing above average and which are performing below average. Now we can look at this for any kind of field now. If I want to see this result for the subcategory level, okay, I can bring subcategories over here, okay, and I'll be able to see at the subcategory level what my results are. So for the subcategory level, overall sales, individual sales are these, and average is coming this one single value, and we are able to see that we can find out easily which one are above average, which one are below average. Okay. There is no history of the steps here. You don't see that all the steps history. Okay, so if I need to see something like this, let's say I remove this above average. If I want to see just quickly, if I want to see just, let's say I create this visual, I want to see which of the subcategories among these which are performing above average and which are performing below average. Just I can do it using this Windows calculation. I can find out the Windows average, and here I will be able to see just clearly. So not just the top 10, top 20, top 30 that we were able to do earlier, but here we can do based on the actual Windows average which is above average, or other types of aggregation that you can apply with the Windows. Okay, so this is about the Windows calculation. I hope this is clear with everyone. Okay, another thing with which you can look at your data is if you want to simply see how much up or down you are from the average sales, right? Just that data, if you want to see, you can also look, you can create that using this. Okay, so just another calculation that can be helpful is that what is my, you can calculate the sales index versus average sales. Okay, sales index versus average sales. So here it would be simply sum of sales divided by the average of Windows function that we did. So this will become your index. Okay, if you calculate like this will become your index, and you can add that as well onto the label here. So we can have this sales index versus average. What is that? This is all of this is how many times the value is bigger than the average value. So here we can see that some of these values are 2.4 times. Okay, 2.4 times, 2.4 times, right? All the way 1.1 times. And these are the ones which are just below this. So how less they are. So 0.85 times of the average and so on. So these one, all of these will be lesser than one. These ones all will be greater than one. Okay. So this kind of analysis can be used when you have, let's say you have uh, let's say you have a retail store and there are multiple stores, multiple retail stores operating at different locations, and you want to just see what is the index of each of those as compared to the average values, right? So on an average, my overall all the stores perform at this level, but you can see the index, which one is very high versus average, which one is very low versus average. Those kind of comparison can be done. All right. So next up, I want to take up the level of detail calculations. Okay, level of detail calculations. These are also important calculations that helps you sometimes analyze the data correctly and in the correct level of details, which you cannot directly do directly even with these the calculations that you have explored so far. You will not get the correct output unless you apply the level of detail calculations. Okay, so level of detail calculation, this will take some time for me to explain, and let's keep that in the next class. So we'll take the level of detail in the next class. Along with that, we are going to take some more use cases on the calculations, and then we will move to the some other visualizations where we will apply the post aggregate calculations. Okay, so let's keep our learning to this much today, and we'll continue on this next week. If you have any questions so far, let me know. Do give your feedbacks. Okay, so our LSM has already shared the survey link for today. Okay, so we started looking at the table calculations and we looked at some of the examples like how we can apply a Windows calculation here, right? How we applied a Windows function, and with the Windows function, we were able to just calculate what is the average in the selected canvas. Okay, and for against those average, we could calculate which one is performing above average, which one is performing below average, right? And we have just color coded those going above average or below average. Yes, Alder. So the Windows calculation, you want to see the Windows calculation. So we did it using very simple Windows average function with this sum of sales and first and the last from this window. Okay, let's take one more example for the Windows calculation here. We'll take one more example here. Now this time I want to calculate what uh, my monthly sales are, and I want to compare those monthly sales and see what the rolling average, Windows average, moving average um, calculations, moving average sales are. Okay, if I want to do something like this. So how can we do that? How can we do that? So let us try this out here. So I'll create a new worksheet here, and we want to just calculate. We want to calculate some firstly monthly sales here. Okay, monthly sales. So we can go and bring order date onto the row shelf, sorry, the column shelf. So order date onto the column shelf and sales. on the row. Okay, let's do that. Order date to column and sales on the row. Okay, currently this is showing the yearly sales. I want to change this aggregation and I want to see this result by month. So you can go and change it to month over here, change it to monthly result. Okay, now this is what monthly the sales look like. So there is quite a lot of deviations, some fluctuations. Some months are going really up, some months are suddenly going down. So when you have this, then you can see that there is some fluctuations, very heavy fluctuations in your data. But if you look at this trend in general, it looks like the trend is moving upwards, right? Trend is moving upward. It looks like my trend is somewhere like this, right? It is in this direction, correct? So the average, if we see the average, it is going in the upward direction. Okay, so now let me clear this. And now I want to create a calculation which will tell me what, instead of looking at each month as individual, I want to see what the moving 3 month average looks like. Okay, moving 3 month average looks like. So when we look at moving 3 months average, that data would be, that would be this, would be slightly uh, smoothened. These uh, increase and decrease, certain spikes that you see in the data, that will get smoothened as we apply the moving averages. Okay, so let us calculate that. So for moving average, I will once again use the Windows function. Okay, so let's go ahead and create a new calculated field. And let's say I call this 3 month moving average sales. 3 month moving average sales. Okay, and here I'm going to use Windows average once again, Windows average. Okay, and for the Windows average, my expression is, because I want to use the sum of sales. So once again, we'll use sum of sales, and the start and end date in this window, I want to give a relative start and end date. Okay, so relative, if I want to see previous 3 month moving average, then I can do, my start would be just going 2 data points back. Okay, and my end would be in the current month. So I'll just put -2 and 0 over here. Okay, -2 and 0 over here. And click on OK. So once this is done, this calculation is added. I would want to see this, let's say this, how this would show me the result. I want to see that in the same chart just to compare how this looks like. So we'll drag 3 month moving average onto the rows and it will create a new row for the 3 month moving average. Now, these are two trends, right? We can see the two trends here, two line charts. Can you tell me which one looks smoother, the above one or the below one? Which one is more smoother, above one or the below one? Okay, it is the below one, right? All of you agree the below one looks smoother, right? You have less sharp edges over here in the below one. Now, what is happening over here in this 3 month moving average here is that the Windows calculation looks at the level of detail of this visual, and in that level of detail, it just goes 2 data points back and it takes those data points and take an average of that. Okay, so if we are, for example, if we are looking at March month, then it would look at the sales of January, it will look at sales of February, it will look at sales of March, and it will show the average of these 3 months. So March sales value is actually the average of January, February, and March. That's how this is working. So for example, here, if we see the third month over here, that is the month of March 2014. Okay, the sales here is 55,691. Okay, but the moving average sales is 24,816. Okay, so the moving average is much lesser because in the preceding 2 months the sales were lower. So the in February it was only 4,500, and in prior to this it was 14,000 something. Okay, so it is basically moving average. What it is doing, it is summing 14,237, 4,520, and 55,691, right? So if we just roughly take sum of it, this is 55,000 plus 5,000, that is 60, and plus 14, so that is 74,000, right? Roughly 74,000. If you divide 74,000 by 3, it will be almost 24,000 something, 24,000 something. And that is exactly what we are getting over here, 24,816. It's exactly the average of last 3 months sales. In the first 2 months, it did not have significant sufficient historical data. That's why this moving average is just based on whatever data is available. So January's moving average last 3 months is same as the January sales. February is considering only January and February. From March onwards, you get the actual data available for the last 3 months. So that's why you see the true average, moving average over here. Okay. Now, normally in some businesses, they don't want to see like what is happening in 1 month. That may not be a true increase in the business, but on an average, what is how the business, like the trends look like. So there you can look at these moving averages. What the moving average tells you, how good it is. So typically moving 3 months average is quite like commonly used as a measure when we are looking at the rolling averages, how they look like. If we just superimpose these two on top of each other, we can make this dual axis too. If I make it dual axis, then it looks something like this. So the moving average one is this blue line, and blue line is kind of somewhere kind of averaging where the values are. So it is nullifying all those spikes. Wherever there are these sudden spikes, it is nullifying those. The more you increase the moving average window period, the smoother the trend is. So if I change it to not minus 2, if I change it to -5, you would see that it will become even more smoother. You see, this becomes even more smoother. But normally we don't do it that much of smoothing. We just look at the rolling 3 months. All right, so let's look at another example. Now we have looked at the moving average, but if I want to also see what my uh, month over change in the uh, sales are, then I can do that as well. So for that as well, you can use table calculation. So let's look at that too, an example of this. Once again, I'll use date in the column and sales over here. And once again, let me show this to monthly results. Okay. Now this time I want to show what the month over month change looks like for the sales. Okay. How much is the sales difference? over period. Okay, so I want to just show this, the actual value of sales as well as what is the change from the previous month. Okay, previous month, what is the difference in the sales? So for this one, I will convert this sales, sum of sales, directly into the windows calculation. Here I can, sorry, not the window, but the table calculation. You can go here and you can go to table calculations here. Okay, table calculation. And this time we will use the table calculation, which is just show the difference. Okay, difference from, and here you can choose the relative value. Okay, difference from, right? So you can choose just the previous value. Okay, show the previous value. Okay, we just do this. Now see what it has done. It looks similar. There is no much change. Still looks like this line fluctuating. But if you see difference in sales, now this is coming in these percentage value. Okay, difference is coming in percentage values. So what the difference from previous month is showing whether it has gone above or below zero, how much it has increased from the previous month. We can see that. Okay, to give this in more perspective, let us also add this sum of sales with this table calculation onto the color mark too. Okay, so the same thing, I will add sales onto the color mark. Okay, and this also I'll change it to the table calculation, which is difference from the previous over here. And you will see that whether separate one. Okay, actual sales over here, and the actual sales I can simply not put here the color. Okay, so this is the actual sales. Okay, and we can, once again, we can use the dual axis here too. So I can make this one a bar, something like this, and along with this, I can pick a color. Let's say this is the bar, and along with this we can show the difference from previous, whether it is up or down. So difference from previous, I can just make these dual axis so that I can see both the absolute sales, right? Absolute sales. Okay, how the absolute sales looks like, and along with this, the how the percentage difference, sorry, the difference from the previous, whether it is going in the negative or the positive. You can also change this color to the range which is more of diverging from red to green. Okay, so what do we want to see? We want to see, first of all, what is our monthly sales? Okay, we want to see that. Along with the monthly sales, I also want to see what is the month over month, what is the difference between the values? Okay, how much is the difference between the values? So I want to see that. So I'll put first of all monthly sales. So bring the order date onto the column. Change this to monthly result. Or let me do one thing. It becomes too crowded. Let me keep it to quarterly, just so that it is not too crowded. Quarterly sales. Okay, this is quarter over quarter sales. Okay, very easy. Now I will add one more sales measure onto this, another one. And this one, the second one, I want to convert it into a difference of from the previous month value. Okay, so change it to table calculation. Okay, or just apply a uh, whether we have a difference. Okay, let me, okay, add table calculation over here. So by default, the first one, it may be a difference from for you too. So just keep it to difference from. and relative would be previous, not the next, not the first or the last, just previous. Okay, difference from and previous, and apply. Okay, so this one shows what is the difference from the previous value. Okay, what is the difference, whether it has gone up or down, positive or negative, you can see the difference. Okay, you can also convert this into a bar. Let's say this difference from previous, I can convert this into a bar over here. Okay, so now you can see how the values are changing. So for the second quarter from the first quarter, of course, there is an increase. So you can see the increase. From the second quarter to third quarter, there is again increase, and there is quite significant increase. Okay, so we can see that. In the third to fourth quarter also there is an increase. Okay, there is increase. So it still shows the increase, but increase is slightly slower, slightly lower, right, from the previous. Then there is a decline. Okay, then there is a decline, and then decline is quite sharp. So that's why we can see a huge negative over here. So you can see where the values from the previous month has gone down compared to the previous month. Wherever there is a decline, you will see the negative results. And if you want to show this, we can show this in the form of colors too. So you can put the sales onto the color shelf too here, and you can make this just this as well as the table calculation, which is this one. Okay, difference from previous. And you can identify where it is going lesser from the previous month, previous quarter. Okay, so wherever there is a decline, you will get that identified from this negative bars. Somehow I'm not getting any of your images. I see that you're trying to send, but I'm not receiving any of the images. Well, there is a difference. So it's not so table calculation that we are applying. So those table calculations needs to be uh, like depending on what we are, what where we want those table calculations to be applied. Okay, that we need to see whether those are being applied or not. For example, here there is this chart that we want to show, right? So here this chart I want to show. So whether in this chart, in this bars, these bars, whether I want table calculation to be applied here. So if I need to apply that, I need to add the table calculation here, right? So for this bar to show like this, there needs to be table calculation. Then whatever the output of this value, if I want that to be color coded as well, then if I add it in the color, there also I need to add the same table calculation. Only then it will color code the value based on what these numbers are. Otherwise, it will color code based on just the same sum of sales, which will be positive in all the scenarios, right? Sales is not negative, correct? So if I color it by, let's say, if I color it by just sales, not the difference of previous sales, then it will be like this. Sales are all positive. If you see the color code, this is all positive range. So if I want this color coding also based on this negative to positive range, I need to color code it based on the table calculation. Then only it will be there. So you need to apply both with both areas. Another way you can use this is, let's say I just create a duplicate of this. I'll create a duplicate of this. Now, another way that you can use this is not showing the difference from the previous, but you show the percentage difference from previous. So instead of this table calculation being just the difference, you can go with the percentage difference from previous. What is the percentage difference from the previous? Okay. So you can change these into, instead of the absolute value, you can change it to the percentage differences too. Okay, how much percentage it was up, how much percentage it was down, and so on. Okay, So those as well you can show if you want to show it in the form of percentages, not the absolute. This is also percentage difference also is something that you would want to sometimes look at, just how much in terms of the percentage, how much it is up or down. So these are some of the ways with which we can apply table calculations interesting, very easily, very quickly, and get some very meaningful analysis. Okay, very meaningful analysis here. Okay, now let's look at another type of calculation, which are level of detail calculation. Okay, these are called level of detail calculations. Okay, so these are also type of calculations only. Okay, these are type of, you may call them that these are also somewhere the table calculation category only, but they are like uh, they are differently, I would say, always mentioned because they are important, and they are, if you talk about someone asking about Tableau, they'll talk about these calculations explicitly, like, do you know about level of detail calculation? There will be questions like this: what are level of detail calculation? What, how many types of level of detail calculations are, how to apply those, things like those. So that's why we'll cover them separately. These are called level of detail calculations. Okay, level of detail calculations, or in short form, LODs. Okay, LOD calculations, level of detail calculations. What does level of detail calculation do? So we know that everything in Tableau, when it comes to calculations, there is some level of detail that comes into the calculation. Okay, so here also we have uh, these calculations, that there you can define at which level your calculation should be applied. Okay, so what it does is, the level of detail calculations, this allow you to save your calculations at a specific level of detail within the data model. Okay, so when you are using work, let's say the workbooks, okay, any worksheet for example, and in that worksheet you select a dimension, you select a measure, that calculation, if you apply sum of sales or sum of profit, that result will be based on whatever level of detail that you're keeping in that visual. Okay, in that visual, whatever level of detail. For example, here if I'm calculating, um, let's say, um, this one, right? These calculation, which is percentage of total sales by region. So level of detail here is regional level calculation, or regional and furniture, like the category level, region and category level. That is the level of detail that we are eventually getting these sum of sales into, right? So automatically the sum of sales is getting into this level of detail, whatever that we are keeping in the worksheet. But if I want to save my calculations in the data model at a particular level of detail, then I can use these level of detail calculations. Okay, this lets you save the calculations in that level. Okay, so let's look at this example, this with some examples over here. So first is level of detail here. Let's let's assume that I want to apply uh, a level of detail which should remain fixed, which should not change irrespective of which all fields I use in um, my canvas. I want to fix what my level of detail for a calculation would be. So the first type of level of detail calculation is LOD expression. So there are three types of LOD expression. There is fixed LOD, fixed level of detail. Second is include level of detail. And third is exclude level of detail. Okay. Okay. Fix level of detail, include level of detail, and exclude level of detail. These are the three level of details that we have. What happens in the fixed? Okay. So let's talk about fixed here. So in fixed, so with fixed, you explicitly set the level of detail to the specific dimension regardless of the fields selected in the canvas. Okay, so we are explicitly setting the level of detail regardless of what the dimensions that we are selecting in the visual. So here, when do we need to use this? Like, if we think about it, where do we need this? So of course, as the this fixed also suggests that it sets the level of detail to a specific dimension. So whenever we want any calculation that needs to be logged at that dimension, okay, whenever we want it to be logged at that dimension, then you use this level of detail. Okay, then you use this level of detail. For example, for example, or let me take an example here. Let's say my objective is that I want to know what is my uh, total sales per customer. Let's take this example. I want to know what is my total sales per customer. Okay, I want to know that. So here, the sum of sales that I would apply that at that constraint of that it needs to be whenever it needs to be uh, looked at, it would always be at the customer level. Okay, customer level. So let us understand this with this example. Or let me give you another example. Let's say I want to know what is the uh, average customer order. Okay, average customer order. Okay, I want to calculate average customer order. Okay, what is on an average? Sorry for changing the example, but I think that it will be clearer with this. You will be able to understand it better. So you have data like this. You have data like this. You have, let's say, this is your region. Within the region, there is customer. Within the customer, there is order ID. Okay, and then you have the sales. Okay, sales. Although we have other columns as well, but this will be good enough to understand this. Let's say you have the East region, and within East region, you have customer A who has placed some order, okay, order, and it generated some sales, let's say 1,000. Okay, then once again, in the East region, okay, there is once again the same customer has ordered, okay, and this is another order, order 2, and here the order value was 500. Okay, then another, let's say within the same region, you have customer B, and that customer B ordered another order. Let's say the order ID is here, order ID 3, and here the order value is Let's say 100. Okay, this is the 100. Now, if I need to, let's say it would be easier to calculate if I keep it 300. Okay. Now, if I have to ask you, what is the uh, uh, average order value within this region? Can you calculate it? What is the average order value within the East region? What is that? What is the average order value at the region level? It is 600, right? It is 600 because we are keeping all the sales orders here and we are summing them, dividing them by 3. Total number of total sales divided by total number of orders. That is 800, 1800 divided by 3. Now, let's say I want to know what is the average order per customer, average order value per customer. What will be that? What will be the value for A and B? You will get two different. What will be the output? Average order per customer, average order value per customer, average order value per customer. Average order value per customer would be, so you will get this per customer. So you will be having, let's say we are making some calculation that has the level of detail at the customer level. So it will separately calculate for the customer A and separately calculate for customer B. For customer A, it will be 1000 plus 500 divided by 2, that is 750. For customer B, there is only one order, so it will be 300. Okay, 750 and 300 for these two customers. Now, if I need to show what is my average cost or average now the regional sales for the average customer value based like the regional average regional sales. Okay, what will that be? So then I will be applying another averaging on top of the this customer level value that we got. Okay, so then it will be for this region, for each region, what the I want to know for each region, what is my average customer value sales is, right? So then it will be then applying this average of the customer value sales and then applying another average. So it will be 750 plus 300 divided by 2. This will be an average of these two values. Okay. So what is the value that we are getting eventually over here? So eventually we are getting here, this will be approximately 550, not approximately, exactly 550, right? 750 plus 300 divided by 2, 550. Earlier, when we took just the directly, what is my average order value? Then I got 600. Now, when I want to show an intermediate level of detail calculation, which is at the customer level, I want to keep. Okay, at the customer level, I want to calculate what my average order value is, and that LOD, whatever that customer level calculation is, that I want to reuse in some other level of detail, then I can use that. Okay, I can reuse that. Okay, that is what level of detail calculations allows us to do. So it sets any calculation and saves that calculation within the data model. Okay, and then let you use any other aggregation over here on top of that. This can be a bit tricky to understand, but it'll get clearer. Okay, let's say I want to calculate regional level, regional level sales. Okay, let me show this to as a table. This is what regional level sales would be. Okay, now I want to see the average sales. Let's say if I want to look at the average sales, I can change this aggregation from sum to average. What is my average sales here? This average sales right now, this average is basically doing the average on all the rows that we have where we have the sales, but just it'll do the average of all the rows that where the region is central, it shows that value, right? So it doesn't, if I want to see region wise, what is my average customer uh, sales are, I cannot do it. Region wise, if I want to know average customer sales, I cannot do it. If I do it like this, simply average, it takes all the rows that are there and it'll show the average of those. I don't want to do that. I want to calculate at the customer level. So what I need to do, I need to calculate one more field which lets me store the level of detail calculation. Okay. So here I'll, let's say I created as, I want to first of all keep the customer level average sales. Okay. Let's say first of all I'll show you what the customer total sales by customer is. Okay. What the total sales by customer is. So total sales per customer calculation I want to keep. Okay. So here I want to use a level of detail because I want to show keep the total sales at each customer level. So I will use, whenever you use level of detail, it starts with the curly braces and then you type whichever level of detail expression that you want to use. Here we want to use fixed. Then you choose your dimension at which you want to keep your level of detail. Let's say I want to keep it at the customer level. Okay. We can keep customer ID. Okay. I want to keep my fixed level of detail at this level and then put a colon and type whatever measure that you want to keep. Let's say sum of sales. Okay. Sum of sales. Okay. And end it with the curly braces too. Okay. This will give you total sales per customer. Okay, let me use this. So I have created this total sales per customer. Let us see what result it gives us. So if I put it over here, let me convert this into the text as well. Total sales per customer. Okay. This is what we are getting as the this level of detail. So um, okay. So this one that we got this measure total sales per customer at the moment, the aggregation for this one as we added here is also sum. Let me change it to average. Change the aggregation to average over here. Okay. And now you see the result. You will see a drastic difference between what we see here in the first row and the second row, right? So the second one here, we are seeing here what the average sales per customer level is. Okay. So it is aggregating the total sales values for each customer. And then for each customer, whatever the aggregated sales values were, we are seeing the average of those in this. Zuldas, can't you see the this calculation window here for total sales per customer? We created a new calculated field. Yeah, so we just brought that onto the table. And we changed the aggregation to average. Just remember to change the aggregation to average here. How I change it to average, just click on this fill and change the measure to average here. Are you sure this average, this total sales per customer, this is coming in the measure shelf over here, not into the dimension? Zeldus, can you check and tell me? Now, Zildus, you're not following what we are doing here. So the example that I showed you where we were showing three orders. So for customer A, the order value was 1,500, correct? 1,500. So this sum of sales over here in this fixed level of detail is summing up those values, 1,000 plus 500. So 1,500. Okay. So two data points, total value is 1,500. But if the output of this, if I'm changing it to average, then it will be doing the average of those 15. So 1,500 dividing by 2. That is what being done. Okay. Now to understand this better, let us look at this with an example over here. So we have this customer name. Okay. Customer name. And I have calculated this total sales for each customer, total sales per customer. Okay. This is the value that I'm getting, total sales per customer. This is the value that I'm getting. Okay. If I simply look at the sales, let's say after the customer, let's say I also want to see by category. Let's say sales by category. Okay. What I did here, I added another context in this level of detail in this worksheet, in this canvas, right? I added another context, but what is my total sales per customer? This is returning the same value across these categories. So this total that I have calculated, this total is fixed at the customer level. It will always show the total which is at the customer level. That's why these values will always repeat for each customer level. Okay, that is what this level of detail calculation does. It locks at which level my calculation would be performed, right? So this is what the level of detail does. It locks your calculation at this level. And we are taking the average of the customer in the previous example. Okay, now let's take another example, another useful example. My question here is, let me clear this chart over here. My question here is, show the average order value for each state. Okay, show the average order value for each state. Okay, now average order value for each state, we want to calculate this. So can we do it directly showing, and directly if we show the value, would it show the correct result? Average order value. I want to see the average order value. So here also the problem would be that I would not be able to directly apply the average here. Okay, I will not be able to apply the average directly. So what will happen here, if I, let's say if I go and choose state onto the rows, okay, and if I simply take the sales, let's say sales, and drag it on this, make it a table, This is the result that I get. Let me also sort this. This is the result that I get. Let me make it an average because we are looking at the average sales value, right? This is the result that you get. Once again, let me sort this. This is the result that you get, average sales. But is it the average order value that we are showing here? Can you tell me yes or no? Is it the order value, average order value? And why is it not? What is the problem here? So you're saying that the what is the problem here? You're saying we need to fix it by customer. This is not, this is the average per state. No, this is not average per state. This is average of the sales. What what this does is this does the average of the sales on individual row level. Okay, individual row level. So for example, here if I exclude the state over here, what is my average of sales? 229.9. Now this is not the average. I mean, this is not at any state level. So whatever record that I have row level, it's basically taking the average of that. Total of sales. Okay, let me show this. Total of sales. This is the total of sales. Then total number of rows. Okay, I simply just added these all in the text. What this is doing, total number of total sales that we have across all the data, total number of orders that we have, total number of rows that we have is just showing the value of this. Can you manually calculate and see if the division of these two, the bottom two, gives you the first one? Now, what I will do here, let's say if I want to see this at the state level, so I'll bring state onto the rows. Okay. And now you see the result. For example, Alabama, there are 19,511 total sales, and total rows for Alabama in our data are 61. So the 19,511 divided by 61 will give you 320, right? That's what it is giving. So when we apply any kind of aggregation, and uh, directly it will be applied on the entire data, so all the rows that we have. It is not when we apply average of something, it is not that it is applying average based on the state or the customer. No, it is on the entire data. And then if we apply any state in the field, then those averages would be for all the rows belonging to that dimension. Okay, so that's what we were showing earlier. So let me remove these last two once again and show it. So this is the result that we were seeing earlier. Alabama 320. Okay, we sorted this result in the descending order. So Wyoming was coming at 1620, highest average sales. Now this average sales is that at the row level. Okay, row level. Our objective is what is the average order value per order? What is the average sales? Now here for each order there may be multiple lines. Why? If we look at our data, if we go to view data, look at our data, what is the level of detail of our raw data? Our raw data has the level of detail of order ID. Okay. And if you see this order ID is repeating on multiple rows, because the level of detail is within the order at which product are being purchased. So if in one or five products are purchased, when we apply an average, it will just take average of all the five values that we have for each line item. Okay. So I'm just showing you the level of detail of our raw data. So our raw data is not at the order level. Our raw data is at the product level. So if there is one order and within one order there are five products purchased in the same order, then you will be having five lines. Okay, five lines. And if you simply apply the average, those average will be applied for each line over here, right? Each row over here. And we don't want to do that. We want to know what is the average order value in an order. How much average value do we get? So earlier in this example, let me once again elaborate this example with the same thing. Total sales, total sales, total sales was this much. Okay, for each of these. The average that we are directly getting is this. Now let me also show you total orders that are there. So I can simply take this order ID and keep them in the measure, add it over here in the measure. But I want to convert this order ID. I want to take a count of this, right? I want to take a count of this. So order ID, I will take a convert this into a measure and I'll take the count distinct of this order ID. Okay. I will add one more field over here, which is the total row numbers. Okay, total row number, which we earlier also had. So the orders, this table count, row count, and let us add that too. And let me add that between the sales and the average sales. Okay, this drag in between the average sales and the sales. So basically what is happening right now, this is the total sales. This is the total number of rows. If we divide total sales with the total number of rows, we get this output, right? This is what we were seeing earlier as well. However, our objective is not to see this number because my objective is show the total average order value per state. Okay. But for each state, the orders are different here. Orders, if you see, order here is 34. So this value must be divided by 34 to give you the average order value. This 35,282 must be divided with 108 to get to the average order value. Okay, and so on. So at the moment, of course, this is always be the true that the number of lines will always be greater than or equal to the this value. So my average sales here, this would be higher than what we see here. So we need to do this. So now to do so, we can apply a fixed level of detail here as well. So what we need to do here, I want to fix my average sales calculation at the order level. Okay. I want to fix my average sales at the order level. So what we need to do here is I'll create a new calculated field, another calculated field. Okay. This will be average order value. Okay. Average order value. And once again, we are going to apply the same uh, way of LOD expression. So curly braces fixed. At which level I want to fix my calculation at the order ID level, order ID. Okay. For the order ID level, I want to take sum of sales. Okay. Because I want to first sum all the sales at this order level. Okay. In this example, I'm going to make one more tweak to what we were earlier doing. So earlier, we were just calculating the total sales directly in the measure, and then we were taking the average from the this. When we were using the pills on the pill, we were changing the measure from sum to average. But here within the calculation, I will just whatever output that I will get of this, I will apply a wrapper aggregation, which is average. So whatever the output would be, I will take simply the average of that. So average of this value. Okay. Average of fixed LOD for the sum of sales. And that will be the average order value. Okay, let us hit apply and let us bring that average order value measure that we have onto the this shelf. Okay, and see what the output now looks like. And so this average order value for Alabama now moved to 574. Okay, is 574 correct? Can you do 19,511 divided by 34 and see whether it is the right output or not? Okay, I hope everyone got this. So this is how you can apply the level of detail in this scenario. And there will be many scenarios where you will use this fixed LOD in your output. Yes, Sally, of course, it is rounded off value. So that's why it is 574. Now it is up to us how we want to show it. I use this table to explain how these calculations should be. But whenever we are showing the results, maybe we can simply use a map visual, and on the map visual, we can simply show the average order value from each of the region. And along with that, the total sales that we are getting from each region, both of these to identify that there are some states which are having high sales as well as high order value, or some states where the sales are lesser but the average order value is higher. So basically you can find different types of insights with this average order value uh, measure. Okay, so um, this is about this. We will continue more on this, but let's take a break at this point. Okay, let's take a break at this point. um, so during the break, our LSM will reach out to you. There is some announcement that our LSM has to make. So let's just wait for that. Okay. Now let's take another example here. Let's say now I want to calculate how many. Um, my objective is to calculate how many customers have placed, um, how many orders, um, or let me put it this way. You have the orders information at the customer level. Okay. So from the order information at the customer level, from the order information from the customer level, I want to know that how many have, like, in the occurrences of the number of orders placed by the total number of customers. So basically, I want to know that there are how many customers who have placed orders only once. Okay, how many customers are there who have placed orders twice, or how many customers are there who have placed orders thrice, and so on. Okay, so I want to know this. Okay, so order counts and the customer count by the order of number of orders. Okay, let me write this down. So LOD fixed to, and within this, my objective is how many number of orders are placed by most of the customers. Okay, how many number of orders are placed by most of the customer? What I want to see here is orders. Okay, and then next to that, count of customers. Okay, I want to do something like this. So one order is placed by 100 customers. Okay, two times orders, 150 customers. Okay, three times orders, 500 customers, something like this. So I want to see this number of orders placed by most of the customers. So this is not straightforward. This cannot be done without the LOD expression. We need to use LOD expression. Only then we can do it because it requires calculating at the multiple levels. We need to first count total orders placed by customers. So LOD, which is at the customer level count of orders, customer level count of orders. So I'll go ahead and do that. So now you know if I need to do this, I can use a new field with, let's say, number of, or let's say orders by customers. Okay, orders by customers. So this is a fixed LOD. I can do a fixed LOD by customer ID, and I want to do a count distinct of order ID. Okay, so what this will do, this will count how many orders are placed by each customer. Okay, orders by customer. So first thing that we need to do is this. Okay, so everyone, please do this. Let me know once you're done with this part. Count and count distinct is, in count distinct, you do not count duplicate. If there is a customer order, if an order ID have duplicate rows, it will be counted only once. Okay, so we got this. Now here, if I just simply take customers, let's say the customer name in the row, and I'll add all members, and the count of orders by customer into the column over here. Let me convert it into a table. So I do see these values. So Aaron Bergman has orders 3 times. Aaron Hawkins have ordered 7 times. Aaron Smaling has ordered 7 times, and so on, right? So all these customers, we can see how many distinct count of orders are there associated with each customer. Okay. Let me sort this in the descending order. Okay. Now we see the result like this. So customer name and count of orders that we received from each customer. Okay. Now my objective here is I want to know how many number of orders are placed by most of the customers. So which is the common, like in my business, how many on an average, what is the most number of orders that a customer places? Okay. So I want to see result something like this. I want to see result like this. I want to see result like this. So on this axis, I want to see orders, right? So one time order, two time order, three time order, four time order, five time order, 6 time order. And for these, I want to see how many customers are there. So for one time placing order, we have these many customers. For two times placing, we have these many customers. For three times placing, maybe there are more customers. Four time, maybe there are even more. Five times, maybe some less. Six time, even lesser. Something like this. So I want to know that whether four is the number of orders that is placed by maximum number of customers. And most of the customer places at max like 4 orders in general, right? We can find which are the customers who are loyal, who are repeating. So here we can see that information over here, directly over here as well. We can see the list of the customers who are ordering frequently. So that answer we can get from here as well. But here, my question here is that I also want to know that in general, how many total number of orders that a customer places. Okay, can I increase that? Can I even engage for the in general, if the customers are making 4 orders, can I push them to make 5 orders or 6 orders in general? Can I do something like this? Right? So let's see how this can be achieved now. So now this measure that we got, which is the LOD expression of count of orders that we have, I want to convert this values, because this range of this value is from minimum there can be 1 order and maximum I have sorted this. So maximum is 17. So at max 17 orders are placed by one person. It is not more than that. So I want to create this measure directly as the into my dimension. Okay. And I want to see these unique values by this measure. So what I can do here is I will remove this, and this measure orders by customer, if I put it in the column, and I will, okay, this is a measure right now. I need to convert this into a dimension. Let me make it, no, not the discrete. Um, it is ought to be continuous. I want to make it into a dimension. So what the best way that you can do is, when you have any numerical result and you want that to be converted into a dimension, you can make bins out of that. So you can make bin basically of the total values, or you can create multiple bins out of it based on what range of values you want. Okay, so this is a measure output. Now I'll convert this into a bin. So total orders by customer, this I will go, and I will go ahead and convert this into a bin. So what you can do here is, you have the option of creating bins. So go to orders by customer and convert this into a, or let me, I think you can also make it a dimension as well. Let me just make it a dimension. Convert this to, sorry, Control Z. I will make it a dimension. I think that would also work here. So I'll convert this into a dimension. Orders by customer. Okay. So see now, I don't need to convert this into bin. I'll just convert this into a dimension. Okay. And I will now show the count of customers that are falling under these orders. Okay. So just customer ID, I will use this into the rows, and I want to convert this into a measure here, which by just simply taking a count distinct now on the customer ID. Okay. So I took orders by customer, convert this into a dimension, and I converted this count distinct customer. I showed count distinct of customer. So how many customers falling in these values? So you remember, there was only one customer having 17 orders. It still shows one customer, right? For the customers who were having 13, there were actually 7 such customers who ordered 13 times, and so on. So now with this chart, I can now see that majority of orders are 5 that my customers place. This is the majority number of orders that my customers place. Okay, closely followed by these 6 or 7. So it is 5 to 7, you may say. Let me show the labels here. Can you see whether you see the same result or do you see some other result here? Okay. In this, the row that you have selected in your window, why are you taking count distinct of order ID? You are supposed to take count distinct of customer ID. Okay. Another scenario that you can use is whenever, let's say, you have data like this and you want to identify um, the number of days it takes a customer to place their second order. Okay. So sometimes what happens is you promote something, you give some promo, some discount, you attract customers, they come and they make the first purchase, but then they vanishes. Okay, they never come back. So there are many times that dropouts happen after the first purchase. So businesses also want to know that how many times, how much time does it take for customers to come back? Okay, how much time does it take for customers to come back? So on an average, how many months does it take for a customer to make its second purchase? Okay, so let's see how this can be calculated. Okay, so how we can get the second purchase? So for this, we need to first identify what is the first purchase date for a customer. Okay, first purchase date. So here the first purchase date is the minimum of the order date calculated at the customer level. That becomes the first purchase date. Okay, so let us calculate this. So LOD. Why I'm covering more of fixed LOD? Because this is the most important one. Most of the time you use fixed LOD only. So we'll cover more examples here. Fixed LOD is 3. So here I want to show time to time taken for second order. Okay. So I want to first of all calculate which is the first purchase date for each customer. So very easily you can create a LOD here, which is first order date. Okay. First order date. So first order date is fixed. Fixed at the customer level, because not the first order date for all the customers, but at the customer level, customer ID level, minimum of the order date becomes your first order date. Okay. So minimum of the order date becomes the first order date. You can hit apply. Okay. Now I can see for each of these customers, what is the first order date? Okay. If I show it in the form of date, exact date, it'll be like this, right? So for each of the customer, you will get the first order date. Okay, so we got the first order date. Now I want to calculate the second order date, and then I want to calculate the difference between those. Okay, so what we will do here is I'll now calculate the second one, create another one, which will be second order date. So second order date would be just the next one after the first order date. Okay, so here I'm going to use a condition over here that return the fixed of customer ID, but in this expression, I will need to use an if condition. So return the minimum order date, but only that where if the order date okay, is greater than the first order date that we just calculated. Okay, if the order date is greater than first order date, then return the order date. Let me just write it in multiple lines. Then order date. Okay, and else I want null, so I can also end it directly over here, and I can end the fixed statement too. So minimum of the order date and minimum of the order date for those orders where the order date is greater than the first order date. So if order date is greater than first order date, then pick the order date, else no value. So we'll get the second order date if we apply. Okay, second order date with this, and I can bring second order date as well next to this. And we can see this as well in the form of day. So now we have the first order date, we have the second order date. Okay, and we just simply need to find the difference between the first order date and the second order date. Okay, so I will create another field here, which is, let me calculate this in months rather than days. Months to second order. How many months it takes for the second order. So here we can use the date diff function, the difference between two dates. So I want result in the form of month, and the two dates that I want to choose is first order date and the second order date. And that's all. And we can bring on to this value. Okay, so here you can see, right? So where the customers are returning within the same month, within the 30 days, they are part of the 1 month. Okay, and sometimes it is going almost greater than 20, 30 months as well. So first we calculated the first day of first order date, then we calculated the second order date. Okay, second order date formula is this, second order date, second order date. Okay, and then you need to calculate this, the months to second order. Okay, months to second order is simply the date difference between the first order and the second order in the in months. Okay, date difference in months between the first order and the second order date. So just why can't we bring month to second order to rows? It's because that it is a measure. It is a measure. It is a measure. But you know how we can show even measures and show the labels, right? So you have this option of going and using the measure names in the filter. Give me yes, no in the confirmation. Have you got this? Not got it? You have any questions? Give me confirmation, everyone. Okay. All right. So here as well, later on we can go ahead and show this data in the same way how we have shown the number of orders that each customers have placed, how many, like usually how many orders does it each customers place. So similar kind of analysis can be done here too, where if we need to, let's say, know how many customers are there who are returning in 1 month or in 2 months or 3 months. If we need to do same thing, then we can do this month to second order. We can convert this into a dimension, convert to a dimension, and then add it to the column, right? And then we can simply add the customers who are coming within this time frame. Okay, so customer ID converted into distinct count of them. Okay, so this is how we get. So in general, it takes 1 month for the customers to come back. Okay. Okay. So this is how we can use the fixed LODs. So once again, going back to the what we learned here in the fixed LODs. So fixed LODs explicitly sets the level of detail to the specific dimension regardless of the fields being used in the canvas. So if we are aggregating anything at the customer level, it will be aggregated there. If we are aggregating anything at the product level or the order level, it will be aggregated there irrespective of which other dimensions being shown in the canvas. The second type of LOD is called include LOD. Okay, include LOD. Okay, what does include do? Include means that this works similar to fixed, but it's a bit more dynamic in nature. Okay, so it include adds an extra dimension, adds an extra dimension to the aggregation. I should not say n, but they can be multiple. Adds extra dimensions to the aggregation regardless of whether they are in the canvas or not. Okay. So if you want to add one more level of detail into the calculations, then you can use include. Okay. It adds that dimension into the aggregation, whatever aggregation that you're doing. Okay. So how is it different than fixed? Let's look at this with the example that we did. So with fixed, we calculated orders, we calculated the total sales per customer. Remember total sales per customer, how was it calculated? Fixed customer ID and total sales, right? This was a fixed LOD that we applied. So what it did with the fixed total sales per customer, when we did something like, let's say, at the region level, if I used total sales per customer over here, this give me this information, total sales per customer. So let me change it to average. Okay, this was the output that you are getting here, correct? So for each region per customer sales, first we are totaling it at the customer level, and then we are from the customer level, we are going to the average at each region level. Within this, let's say if I add another detail from region to, let's say, the category level. Okay, we did it category level, but your average here is at the, this is actually going at the customer level only. So it will still be if there are customers who were uh, who has purchased multiple categories, then only it will not show the revised calculation for the total sales per customer. It will still show that aggregated because it is fixed at that level. Let me show you with a better example here. Let's say I'll put customer over here and show this average sales per customer, right? Okay. Now if I add any other field over here, this average of total sales per customer would not change, right? If I add category next to it, okay, so this does not change because my level of detail is fixed at the customer level. It will aggregate it at the customer level, then take the average. So it will be same because here we are seeing the data for each customer. So this total average, both are same. Okay. If we had used include instead of fixed, then it would still use this dimension for the LOD, but it will also apply this additional dimension into the calculation. Okay. Okay. So let us recalculate this, but this time we will use include. So let's create this total sales per customer underscore include LOD. Okay. Using the include LOD. So this time we will use include customer ID. Same thing, sum of sales. Okay. Instead of fixed, we used include. Hit apply. Okay. Now we have this one, next one. So we had total sales per customer. This was fixed. This was having include. Okay. Now if I bring this into the calculation, right? And let me, you can already see that the output is changed. Okay. So let's see what difference did we get here. Now you see when we applied customer level fixed LOD, it is all fixed at the customer level 886, 886, 886. But when we applied include LOD, include is also considering the customer. But if I add category, then it will further include this dimension into the calculation. So now for this customer, for furniture, this will be the average sales per customer within furniture and so on. So it will consider that additional dimension as well when you are using include. Okay, this is the main difference between fixed and include. If I remove category from here, then both give the same result. It's identical. It's only when we add additional dimension, this changes. Okay, so include is more dynamic in your calculation rather than fixed. It allows you to add more dimensions in your calculation when you want. So basically, fixed would keep the calculations fixed. Whatever context that you provide in the canvas, it will ignore that context. It will remember only its own defined context. Whereas include, it will also create the calculation at the defined context in the include function, but at Additionally, it will also include any additional context that we add on the canvas and then apply the calculations accordingly. Okay, so include becomes more flexible when you are changing your visuals. There, it can be more flexible. But if we are calculating things like now, it can be like you may wonder, like, why do we need to use a fixed? Correct. If we can get it done through include and it is more flexible, it always remembers the context, right? But some of the calculations there you need to put hard coded context. Only then they are correct. For example, the first order date and the second order date. If I had used include function in getting the first order date and the second order date, and if I put any categories and let's say the products onto the field in the canvas, they will show it will my first order date calculation will change to the first order date when that product is purchased or that category is purchased. But that's not what we are interested in. We just want to know what is the first order date irrespective of what was purchased, right? So there you go with fixed, right? But if let's say you want to calculate what is my average customer value, but you may also want to see that flexibility. Show me this region, this result for each region. Show me this result for each of the category. Then in those cases, you can use the include function. The so rest of the scenarios would be same. The examples that we have covered, those similar examples can also be understood for the include as well. So most of the time in LOD expressions, you are going to use either the fixed LOD or include LOD. Most of the time, you are going to use these two. There is this third type of LOD, which is exclude LOD. This is the least used LOD expression. Like very rarely you use it, but let's just cover this as well. Exclude LOD. Now, as the name suggests, and so far what we have learned, this would be the ones that you want to, and if you want to ignore any dimension from the aggregation, even if they are in the view, then you use the exclude LOD. Okay, then you use the exclude LOD. So it ignores specific dimensions from the calculation or from the aggregation, even when they are in the canvas. Okay, even when they are in the canvas, you even then you want to exclude those. Okay, that's what exclude LOD would do. It no, exclude is not fixed. Exclude will simply exclude that dimension that you specify in the aggregation calculation. Okay, so for example, let's say I want to know what is my um let's take this example. I want to calculate with exclude. I want to calculate what is my like what is the total sales, and uh, I want to exclude the subcategory level aggregation over here. Okay, I want to exclude the subcategory level aggregation. Okay, and I would use this to identify what is the uh, what is the each subcategory, how much each subcategory is contributing to the category. Let's say if I want to do that, then I can use exclude LOD in those cases. Okay, so let me show this with an example. It will be clearer. What I want to do level, I want to look at what my subcategory level sales are. So subcategory level sales. Okay, I'm able to see subcategory level sales over here. Now, I also want to see what is the sales for each category. Okay, what is the sales for each category? So what I want to do here is, if I add this subcategory level sales and I want to I would get category, subcategory, okay, category, and then subcategory. Now, let's say I want to calculate some sales which exclude subcategory, okay, into the context. Okay, so I'll create a new calculated field. This will be, okay, total sales excluding subcategory. So I will simply use exclude over here, exclude subcategory when you calculate. So total sales, sum of sales. Okay. So exclude subcategory when total sales is calculated. Okay. If I use this over here, okay, this is what you see. So if you see over here, this result that we see, this is excluding this. Okay. This is excluding this. So here, basically, in this view, I'm excluding this. Now there may be multiple ways with which this can also be achieved. Now what I want to do here is, let's say if I need to know what is the percentage of subcategory contribution, each subcategory's contribution in the total category level, then I can do this. Okay, I can get to what is the percentage contribution in each of these subcategory level. So if I need to do this, then I can go and apply this, something like new calculated field, which is, let's say, percent of category, percent of sales contribution. Okay, if I want to do something like this, so here it would be the sum of sales that we have directly coming. Okay, and this I can divide with the new expression that we got, which is excluding the subcategory. So the new measure that we have, total sales exclude subcategory. If I divide it by that, okay, I may get the, why is it giving error? Cannot aggregate. Okay. So this is not aggregated. I did not apply any aggregation on this. That's why it is giving this error. Let me also up to a sum of this. Okay. Now, if you see, if I add this percentage of contribution and I add this as well into the measures, why is it not coming? So this output that we have got in the exclude, let me do a sum of this here. Okay. And percentage, this one, I don't need to do sum now. Let me create it again. So we have the category, we have subcategory, percentage sales contribution. Okay, so we're getting the percentage sales contribution, and we can see what the values are for the total sales and sales excluding subcategory. Okay, whenever I'm adding it in this context, it is all turning into 0. This is appearing properly. As soon as I'm adding the exclude here, no, even this is coming properly, right? So as soon as I'm adding this, it's not coming up. It should work. I don't see any problem. Okay, I see where the problem here is. I think I see where the problem might be coming here. So instead of creating a separate field, when if I do the expression here, I think it should work. If I put an expression here of exclude subcategory and then do sum of sales, this should work. Okay, this is not working. Okay, I'll look into this, and maybe tomorrow's class we'll discuss this. Why this is not working? I am not sure exactly why this is not working. But the point here is that this is specifically exclude is specifically used if you want to exclude any of the context from your calculation, from your aggregation, then you use exclude. Okay, I'll look into this one, this example, why this did not work. But let's say if I need to calculate, for example, here we use the total sales excluding subcategory, and we were getting this 742 or 719. So those kind of aggregation that we are getting, this can then be used for other type of calculations too. Like if I want to do any, let's say I want to do any calculations where I want to, uh, let's say any calculation needs to ignore a particular level of detail. Let's say you have uh, once again, I'm coming back to the same example that if you want to consider uh, let's say if you want to consider the minimum order, right? Minimum order date, and you still want to keep month into the context in your uh, canvas, then it'll exclude those. I'm thinking of some other example. Actually, exclude is not used that frequently. We don't rarely see. So I'm struggling to find some good example here. Um, let me give you one example here before we end today's session, and let us just try this. Um, so let's say I want to calculate an uh, so we have data at the city level too, right? So if I want to exclude in my average calculation, let's say the average of regional sales, I want to exclude city into the dimension, and I want to just whenever I'm calculating any average, those will be applied at the level ignoring the city. Okay, so then I can put that into the consideration. Okay, for example, let me put let me just quickly show another example here. I just want to make sure that this is clear. We're not keeping anything open. So let's say I want to calculate regional average sales. Okay, regional average sales, or let's say, let me bring region into the canvas, average sales excluding city. Let's say one dimension I want to exclude, not include, exclude. Okay, so once again, we'll do the exclude LOD city dimension, and I want to exclude into my from my average calculation, average of sales, or let me do the sum of sales first. Sum of sales, we'll average it later. So exclude city, exclude city from sum of sales. Okay. Now, if I want to do any kind of regional level average sales, okay, regional level average sales, it will exclude the city. So if I bring city now into this context, you'll see these are being excluded. So if I want to do any kind of average or any kind of data that needs to be ignored in the dimension, right? Then you can use exclude. So any kind of detail that will be excluded that you put here will be excluded. So automatically these details are not used. Okay. Now, most of the times you do not use the exclude uh, LOD. You most of the time use either include and fixed, and most of your work gets away with it. So very rarely we see this, but this is how, if ever you require, we can do this exclude to exclude anything from the dimension. Okay. So I hope that we did not cover very good example here, but I hope that this part is clear what exactly exclude do.
Hello and welcome to our presentation on Tableau interview questions. My name is Michelle and I'm with the Simplilearn team. Today we'll be going over answers to common interview questions for Tableau positions. First question is, what are the data types supported in Tableau? We have string, date and time, numerical, Boolean, so true or false, and geographical. In Tableau, you can tell what kind of data type you have. So when you're on the data source tab, you can see that this is numerical and this is string. Here we have a date. We don't have any date times here. That would have the little clock icon. And we also have geographical. These are set by default and you can change them by clicking on the icon and say we wanted row ID to allow text, so we'll change it to string. And you can see the icon changes there. The next question has to do with how well you understand dimensions and measures. So a key thing to remember is that dimensions are qualitative and measures are quantitative. And if you can remember those particular words, it helps convey what the interviewer is looking for. So dimensions are qualitative and you can use them to categorize your data. So for example, you can categorize your data by what country it comes from. And measures are quantitative and can be aggregated. So you can do a sum of sales, or you can do the average profit. Did you know that Tableau automatically assigns each field a data type and a role, and that it automatically aggregates your measures using sum? But you can change what the default aggregation is. Question 3. What do you understand by discrete and continuous in Tableau? So we have discrete values and continuous values. Discrete is represented as blue and continuous is represented as green. So let's look in Tableau. When we go to our worksheet, you can see that all of the dimensions are automatically blue and all of the measures are green. However, you can have a continuous dimension and you can have a discrete measure. So we have discrete dimensions, which is a blue dimension, but also continuous dimensions, and date is a good example of that. Let's take a look. So we pull on order date. We right now have year, and it's making categories instead of a continuous axis, so it's making a finite list there. But we can change it to be, you can see now it's marked as continuous here, and it's green, and we can change it to be an axis. Instead of different categories, it would be a continuous axis. So you can also have discrete measures, which are blue measures, and continuous measures in the green. So for example, let's say we had a visualization that had the region and sales and profit. But instead of having an axis for profit, maybe we just wanted to have a number for the profit listed right next to the region, and then we could have the sales visualization. So what we could do is change it to a discrete value and put it next to region, and now it's part of the labels. And that's an example of having a discrete measure. Did you know that continuous is infinite and discrete is finite? Those are some key words that you could use also to describe the difference between continuous and discrete. And also just remember that discrete is blue and continuous is green. The next question, number 4, is what are filters? And name the different filters in Tableau. So filters are a way to restrict the data that allows you to only see the data that you want to see in your workbook or dashboard. And there are these different types of filters, and they also have a specific order. So if you can remember the different filters, that's helpful. But also if you can remember what order they apply in, that'll get you some definite bonus points in your interview. We have extract filters that filter the data as it extracts, and it will affect how big your extract is. We also have data source filters here, which will filter the data out of the data source. However, the extract will still be the same size. So let's take a look at this handy visualization that Tableau has on their website. We have the order of operations, and in blue we have our filters. So extracts is first, and it filters down your extract to just what you've selected. Then we have data source filters that will apply to the entire data source. So any visualization that uses that data source will have these filters. We also have context filters, which are next, which come before some of these level of details. That's the major difference, is that it applies before some of these sets and conditional values. And then you will do dimensions and then measures. So any filters that happen on dimensions happen before any measure filters. The last type of filter we have is a table calculation filter, which happens after all of the rest of them and basically just applies to your visualization, just the one visualization. Question number 5. There are 3 customer segments in the Superstore dataset. What % of the total profits is associated with the corporate segment? Perfect. So in some Tableau interviews, you may be asked to build a visualization. For our examples here, we'll be using the Superstore dataset, and if you don't have access to the Superstore dataset, just comment below and somebody on the Simplilearn team will help you get access to that. Also, this is a fun opportunity to pause the video, and then you can work on this on your own, and then come back and see if what you did was the right thing or how we did it differently. Also, you can comment below on what your answer is, and we'll see if we can all get the right thing. So let's build this. 3 customer segments in the Superstore dataset. What % of the total profits is associated with corporate segment? Great. So we're going to bring on our segments, and we have consumer, corporate, and home office. And let's bring on our total profit. So I just did that by double clicking. And now it's just bringing on the sum for each of those by default. But we want to figure out what percent of the total each of these are. So we can change this to be a table calculation. We can click add table calculation, or we can do a quick table calculation and find percent of total. So let's go back to our question. We wanted to know the percent of total profits associated with the corporate segment. And the corporate segment has 32.12% of the total profits. And here's our solution with 32.12%. So did you get it right? Comment below if you got that. What are the different joins in Tableau? Give an example. So in Tableau, you can join your data. So if we wanted to look at orders and tie it to people, we can pull on people and it will give you this visualization, and you can see all the different joins here, and we'll discuss those in just a second. You also have the opportunity to union information, which would be if we had maybe 2 Excel sheets that had orders information. Perhaps one of them had 2012 and one of them had 2013. Then you could take your orders and pull it. So you see that pop up, drag table to union. And that's another way to add more data. And so those are all worth mentioning. Let's take a look at the different kinds of joins. We have our inner join, which will only give you the values that have matches in both tables. Our left join, that will give you all the values in the left table and its matches in the right table. And then the right join, which will give you all the values in the right table and its matches in the left table. The outer join, also known as a full outer join, will give you all the values in the left and the right table. And then as we discussed the union, you can see it's represented by a more vertical join, and what it does is it adds more rows. All the rest of these are about adding more columns, but this will add more rows in the same columns that you had before. If you have the opportunity to draw out the answer to this question and make these Venn diagrams, it's a really helpful way for you to explain your point, and it really portrays that you know what you're talking about. What is the difference between a join and blending in Tableau? So I just showed you how to make a join here, and we are joining an Excel sheet to another Excel sheet, all within the same connection to that Excel file. So when you're joining data, we'll look over here at the joining side, that's when you're bringing 2 or more tables within the same data source, and that's how you join it. And so we're all inside of a data source here, which, when I go to sheet 1, just has one data source here called orders, whatever we wanted to call it, and that is all within one data source. However, let's say we already had 2 different data sources in Tableau, and we wanted to bring together 2 of them. So in this case, it's an Oracle table, and we brought in an Oracle table, and we made a data source, and then also an Excel table that had a second data source, and you can blend it together to get your combined data set. So the major difference, what you're going to really want to take away from this, is that blending is from 2 separate Tableau data sources, and that joining is all within one data source, and it ends up just being one data source in the end. In blending, each data source contains its own set of dimensions and measures, and when you join, it will combine it into one set of dimensions and measures. So let's go back to our example here. Let's bring on people. It is automatically said we're going to join it on region, and we're going to do an inner join. That's fine by me. And so we come here, and now we have just one set of dimension and measures under orders. However, if we were to add a second data source, which we will, it'll be an Excel file, and it will be based off of this rank example. We'll open that up, and now when we go to sheet 1, we have 2 data sources. And if we were to blend this data together, we would still see 2 separate sets of data, only we would be able to pull in from this set some information, and we'd pull in from this set some other information. So that's a visual difference between blending and joining. Question number 8 is, what is the difference between a live and an extract? So first we'll talk about live, and we'll say that your dashboard is connected live to a database. And so a live connection will query that database every time you open up the dashboard or visualization so that you're getting the most recent information each time. and it's useful for if you need information that's a little bit more real-time. However, it can be slower, especially if your queries are complicated. With an extract, it will run the query beforehand and store the information on Tableau server or on your local machine, and so that it's faster to get to. However, it is not real-time information, so if you had a refresh of your extract that runs every day in the morning, and then during the day somebody has made a change to your database, they won't see that change on your dashboard until the next time the refresh runs for your extract. In Tableau, you can set if you want the connection to be live or extract when you first are making your data source. And this is in Tableau Desktop. In Tableau Public, you don't have that option. Did you know that the reason that extracts are faster is because Tableau doesn't need to access the database each time it builds the visualization? And did you know that you can set up a refresh schedule on Tableau server in order to be able to see your extracted data update? Question 9. What is a calculated field and how will you create one? So if we look at our data set here, we have the opportunity to see the difference between order date and ship date. So to create a calculated field, you click Create Calculated Field with this drop-down arrow at the top, or you can right-click in white space, Create Calculated Field, then you give it a name, and we're going to call it Shipping Delay, and we are going to do a date diff. So if you don't see this dialog box here, you can click this arrow to see that. Our date part is day, the start date is order date, and the end date is ship date. So to remember how to create a calculated field, it's by clicking this down arrow and clicking Create Calculated Field, and then writing your query here. And a calculated field is an additional field made up using the data that you already have. So we've made a new field here, and it has the equal sign at the beginning. That might be worth mentioning, how to tell if it's a calculated field or if it was an original field. And then we can bring shipping delay here, and we can see the number of days that it took between the order date and the ship date. We could also duplicate a calculated field. So now we have shipping delay copy. And we're going to call this average shipping delay. And we're going to encapsulate it inside an average function. And now if we take off the order ID, the order date, and the ship date, it's automatically summing up those days, but we can bring on our average shipping delay. And you can see on average how many days it took. And let's change our number here to include decimal places. So a calculated field is a new field made from existing data. It can be used to create more robust visualizations, and it does not affect the original data set. For example, we made our average delay function here using data from our original data set. Question 10. How can you display top 5 and last 5 sales in the same view? You can show top 5 and last 5 sales for a same dimension by creating a set. So let's take a look at doing that here. We have our customers. So let's bring on customer name. And we're going to do it based on profit. So now that we've done it on profit, we can see these are our top 5 profit, and I've sorted it by profit. And here's our bottom 5. And we can create a set by coming and clicking on the dimension that we want the set to be based on. We'll right click there, and we will come to create and click set. And we're going to call this top customers. Top by field, top 5 by sum of profit. And now we have a set. It makes a set section here. Now we're going to make a second set off of customer name. Create set. Bottom customers. bottom 5 by sum of profit. We'll hit OK. And now we're going to combine these two sets. So I'm going to control click, and then we have both of them selected. And we're going to click create combined set, top and bottom customers. And we're going to have it include all members of both sets. And now we can pull top and bottom customers onto filters. And you can see our top 5 and our bottom 5. So if we control drag profit onto color, then it's colored by that as well. So key thing to remember is that you can use sets to show both the top and the bottom in the same visualization, and that you can combine those sets. Is there a difference between sets and groups in Tableau? The answer to this is yes. You can describe a group as being simpler and using only one dimension to determine the group, whereas a set can be more complex. So you could say sets are more complex, and you can use conditions to create the sets, and you can also use multiple dimensions and measures to create the sets. For example, here we create a group of subcategory. So we grab all of these things together and can group it, and that we'll have copiers and envelopes, and then we'll have one group of all of these together. Over here, you could create a set that looks at sales and profits to create a set. So the best way I can describe this is by looking at what we did here. And so we were able to use dynamic filtering here to create our sets, and where it will look at the top 5 or the bottom 5. And let's do the same thing we did there, but use a group. So for a group, we could see that these, we've sorted it, and we can say 1, 2, 3, 4, 5. This is the top 5. So we could create a group. That's this paperclip here. And now we have a group of the top 5. And it's added that group. It makes a new group, customer name group. And it put it on the color for us. Now let's go to the bottom. And we're going to go 1, 2, 3, 4, 5. And we'll create our group. So now we have a top 5 group, a bottom 5 group, so let's name them that. And we'll do that by clicking Edit Alias, top customers, okay, and we'll come here and we'll rename that, bottom customers, okay, and we'll put our top customers on top. And then let's hide all of the others, so we'll click Exclude there. And now we have a similar visualization as we had before for our sets, top, bottom. However, a key difference here is that we had to go through and select the top 5 and the bottom 5. So let's say that maybe Cindy, or let's say Henry Goldwyn has suddenly had much more positive profit associated with them. If that changes, he's going to still stay in our group. This group is just using these customer names to determine who's in the group. So the group is Henry, Sherelle, Luke, Grant, and Cindy, no matter if their data changes. So say tomorrow all of this data is different, it's still going to put these people into the group. However, the sets, as you saw before, is based off of the profit, the sum of profit, and who has the top 5 and who has the bottom 5. If Raymond suddenly has a lot less profit and falls out of the group, then the groups won't pick it up, but the sets will. So that's one thing to remember, is that it could be based on conditions. And then you saw how we took 2 sets and put them together into our combined group. You could also have a set that is based off of 2 different dimensions or 2 different measures. And that's how you could put those 2 sets together and get dynamic sets. So the major differences, as we saw, is that a group is just based off of 1 dimension, and a set can have conditions and be based off of other dimensions. Also, you need to know that groups cannot be used in calculated fields, but sets can. Question 12. What is a parameter in Tableau, and give an example? A parameter is a dynamic value that a customer could select, and you can use it to replace constant values in calculations, filters, and reference lines. So, for example, here we determined we wanted bottom 5 and top 5 customers. But let's give them some options. So we'll create a parameter, and we'll call it select number of top, bottom customers. And we're going to let it be a range with a minimum of 5 and a maximum of 20 and a step size of 5. So we'll let them go 5 at a time. Okay? Now if we click show parameter control, we can see our parameter control, and you can do 5, 10, 15, or 20. But since it's not in any of our calculated fields or sets or filters, then it's not making any difference. So let's put it inside of these. We'll edit our set, and instead of top or bottom 5, we'll click bottom, select number of top bottom customers. So now it's taking our parameter and inserting it in to our set there. We'll do the same thing with top customers. Okay, and now right now we see top 5, bottom 5. If we change it, now we see top 10, bottom 10, 15, and there's our 20. So it replaces a constant value and allows the end user to select the value. Question 13. What is the difference between tree maps and heat maps? So let's first talk about what each of these are. Heat maps compare categories using size and color. I think the biggest thing about heat maps is the color. Size is somewhat optional, so let's build this visualization quickly. So we have region, category, and subcategory. And we're making a heat map, so we want to bring profit onto color. And you can see we've got hotter and colder. In this case, for a heat map, we might want to change. So in this case, what it's doing is hotter is negative, but we could reverse that, and then hotter is positive. And so hotter maybe means this is where more activity is. We can also double click on profit. We can also bring profit onto label, and we'll change this to square, and now it's marked at what everything is. So a heat map will use color to draw your eye to the places where there's heat or maybe activity. We could also use size in this case. So it's not just defined by color necessarily. Maybe we want the size to be defined by sales. So we get things that are bigger but they're blue, which means that they are bigger in sales but their profit is negative. And it draws your eyes to technology. So machines in the South are doing a lot of sales, but they're not having positive profit necessarily. Also, you can see some things that have darker colors but are smaller. So high profit but not a lot of sales. So that is a heat map. A tree map is used to represent hierarchical data. Now, hierarchy is the term you need to remember when you're talking about the difference between a tree map and a heat map. In the heat map, none of these boxes have to do with the hierarchy with each other. Whereas with a tree map, you can see that this box has a thick white line between it and the other ones. And that means that that section are all connected. So these are all technology. And the bigger this section is, that means the bigger the, size is based off of profit. So this bigger section means that technology has more profit than furniture. So let's build this one. When I build tree maps, I like to use our Show Me tool. So here's a tree map, and it says 1 or more dimensions or 1 to 2 measures. So we're going to grab category, and we're going to control click subcategory, and we're going to control click profit and sales. And we'll click on our tree map. Perfect. And so the darker the color, that means the more sales there is. And that's pretty similar to our heat map over here. So the color indicated, in this case it was profit. So the color indicates the difference and the size indicates the difference. And that's true over here. The color indicates a difference and the size indicates a difference. However, there is a hierarchy to it. Over here you can see that there is hierarchies because we have furniture, and then that puts that all together under furniture. And then here's the subcategories. However, if you were trying to compare furniture to office supplies, it's really difficult to tell which one has more sales. But if we go over to sheet 7 that has our tree map on it, you can see really quickly that office supplies has much more sales than furniture. In this case, office supplies has much more profit than furniture. Biggest difference is that tree maps have the hierarchy. Question number 14. What is the difference between TWBX and TWB? So these are all Tableau file formats, and the TWBX contains all of the necessary information to build a visualization. So it's called a packaged workbook, and it compresses it all together. However, the TWB just contains instructions about how to interact with the data source. So when it's building a visualization, Tableau will look at the data source and then build the visualization. With an extract, it contains all of the information that you need, so all of the data is wrapped up inside of there, and there's no connection that has to be made between Tableau and the data source because it's all right inside. Whereas with the TWB, it has to connect to the data source or else it doesn't have the data to build the visualizations. It just knows, it has the instructions of what to do with that data. So the biggest difference is TWBX has the data inside of it, whereas a TWB only has the instructions. Question 15. Explain the difference between Tableau worksheet, dashboard, story, and workbook. Perfect. Here's a breakdown and explanation of each of those. And in Tableau, this entire thing that we've been looking at, all of these sheets, is a workbook. However, this sheet 7 is just one worksheet. All of them together is a workbook, and sheet 7 is a worksheet. The big difference between worksheet and a dashboard is that the worksheet is just one visualization, and so it is only one set of columns and rows here. And a dashboard could contain multiple visualizations. So if we wanted to see our heat map and our tree map on the same page, that would be a dashboard. And then a story is somewhat similar to a presentation mode. And so you can have different pages. And so we could say, here is our heat map. And then we could make another page and look at our tree map. And then look at our heat map. And then we could duplicate that page. And we could say, let's focus on furniture. So we're going to highlight furniture. And then, so if we were to go through these one at a time, we would say, here's our tree map, and then we would look at information there, and we would say, here's our heat map, and then the next screen we'll say, let's focus on furniture. And you can see that it highlighted furniture for me when I went to the next seat. So a story can show you things one at a time. It's like a presentation mode. So the differences are the workbook contains the sheets and the dashboards are the stories. The worksheet is a single view. Dashboard is multiple views. And a story is a sequence. A sequence is a good keyword to remember when you're describing a story. And did you know that the only place that you can access the dimensions and the measures and custom fields we've made is on a worksheet? So when you're looking at a dashboard, so on a worksheet we see dimensions and measures. When you're looking at a dashboard, you no longer see dimensions and measures. What you do see are all of the worksheets. Similarly, when you look at a story, you no longer see any dimensions and measures, but you do see all the worksheets and the dashboards. Question 16. What do you understand by blended axis? With a blended axis, you can use two measures that share an axis, and that means they necessarily have the same scale. So let's build something with a blended axis. So we can make a visualization that looks at sales over time. We'll bring on order date. And let's just do order date by month. There we go. So we can see sales over time. And say we wanted to also see profit. This is two visualizations that have two different axes. But if we wanted them to have the same axes and just the same marks card, you see how I made two different marks cards? We could bring on measure values and take off all the measures that we don't want. We just want. When we take them off here, it's creating this filter here for measure names. And let's take off these two extra visualizations. And now we have a visualization that has a blended axis for sales over time and profit over time. And you can see that they necessarily have the same axes. There is no second axis. What is the use of a dual axis? And how do you create one? Perfect. So a dual axis allows you to compare measures, and you can have two different scales. So if we had this same visualization, that same information that we wanted to see with, again, profit and sales over time, we'll do, okay, great. And we wanted them to have the same axes. We could right click on the second pill of the measures and click dual axis. And now you can see that they do not share the same axis. And you can see profit is much higher here, right there. And so the use of this would be, sometimes you need things to have different axes. If you come here and you click synchronize axes, you end up getting a pretty similar visualization, but you do get two separate marks cards. So a key thing to bring up if you are asked the difference between a blended axis and a dual axis chart is, one, that the blended axis uses the same scale and a dual axis could have two different scales. And two, a dual axis has two marks cards. So let's say we wanted our profit to not be a line chart, but to be a bar chart. That gives you that option. When you go to the blended axis, we only have one marks card, so we change it to bar, everything is bar. But back over here, we change it to circles, and we see the circles. So if we wanted to show sales by year and profit ratio by year in the same view, that's where two different scales could be handy. Let's build that visualization. So we'll make a new chart, and we'll bring on sales and profit ratio over time. That is profit. I still did profit, so I'll drag profit ratio right over top of profit. There we go. And you can see that they can't use the same scale because this is a percentage, and so if we had them on a blended axis, 20% is really 0.2, and it would just be so tiny. But if we wanted them on the same area to apply to the same space here, we could dual axis it. That you can still see useful information there. But otherwise, this would just be in such a tiny, tiny space. So our profit ratio would just show up right here, almost like a straight line. Question 18. What will the following function return? Left 3, Tableau. Here's the question again. And here are the potential answers. Tab, or EAU, error, or none of the above. So just take a moment and see if you can answer this question correctly. Go ahead and pause the video, and if you get the answer, you can comment below, and then we will discuss. We've taken some time to answer this question, and let's go ahead and see what the answer is. The answer is it will return an error. That's because the syntax for left is that the string must go first. First you say left, then you put the string, and then you put the number. So let's talk about what left does. It returns a specific number of characters from the left, and if you had done it correctly, the left is this side. So if you had done the string first and you said you want 3, the result would be TAB. There's also one called right, and that would come from the other end and go EAU. So that's where these answers came from. Question 19. How do you handle null and other special values? Tableau is unable to plot null values or zeros or negative values on a logarithmic axis. And so it will display an indicator in the lower right corner, which looks like this, telling you that it is unable to draw those 2 points. So when you click on the indicator, you can choose from the following. First, you can choose to filter the data, which will exclude the null values from the visualization, or you can click Show Data at the Default Position. So we'll look at both of these. So you click on your indicator and it will say, what do you want to do with these 2 values? If we click Filter the Data, then you can see that it has filtered that blank space and drawn a line connecting those dates in between. Even though there is no point for the 29th or the 30th, it goes straight from the 28th to the 31st. So what's happening on our visualization is it's adding this filter. If we press the back button, we see that filter disappears. If we come down and select filter the data, it adds a filter here that then only includes non-null values. So those are all removed from our visualization. And up to this point, you can see that we have 1 point per day, the 21st, the 22nd, the 23rd, the 24th. But then when we get to the 28th, we don't have a 29th or 30th, and it just draws that line to the 31st. Assuming that during that time period, what we want is a straight line. Now the other option would be, we could also make the assumption that whenever there is a null value, that actually means 0 sales have happened during that time. So that's when you would click Show Data at Default Position. And now it draws those 2 points at the 0 line. And when you hover, it still shows sales null. So, and when you hover here, you can see the actual amount for sales during that time. So if a null in your data means 0, then Show at Default Position is good for you. And if it doesn't necessarily mean 0, then you can filter the data, or you can leave it disconnected like this. Question 20. Find the top product subcategories by sales within each delivery method. Which subcategory is ranked number 2 for first class ship mode? If you'd like to pause the video and work on this on your own and then see if what you did matches what we did, then you're welcome to now at this time, and comment below what your answer is. Okay, so we want to know by subcategory and by ship mode which subcategory ranks the highest for each ship mode. So in sales. So if we take sales onto the visualization, we can see that by the ship mode, it's already split up, and we could see that maybe this one for standard class, it would be chairs. You can kind of look through and kind of, oh, it's not chairs. Chairs isn't number 1 because we have this one, it's phones. So to make it easier, we're going to change sum of sales to a rank table calculation. So we're going to come here and click Add Table Calculation. And we're going to change the calculation type to rank. And it's going to rank them in order of sales. So, but right now, we can see that it's highlighting. That's called Calculation Assistance, helping us understand how it's ranking us. So if I unselect Calculation Assistance, then it gets rid of it. But you can see right now, it's ranking it across the table. So it says accessories has most sales in standard class, then second class, then first class, then same day. And that's not what we want to see. We want to see it up and down. We want to see for first class which subcategory has the highest sales and second highest sales. So let's turn back on our calculation assistance, and we're going to click table down. And you can see now it's going up and down. Within first class, what are all the subcategories ranked? So that's what we want. Now, as soon as you click things in the table calculation, it applies it over here, so you don't have an OK button. So you can just close that out. And you can see now we have a rank up and down for the subcategory. So back to the question, was which subcategory is ranked second for first class ship mode? Here's first class. Let's find number 2. It's chairs. Question number 21. Find the customer with the lowest overall profit. What is his/her profit ratio? Let's go ahead and build this visualization. Customer profit. And we're going to bring all of our customers on, and then we're going to bring on profit. Let's do it as a visualization, so I'll bring it onto columns. And then let's sort smallest to biggest. So Cindy Stewart is the one who has our lowest profit. And now to figure out her profit ratio, we need to make a calculated field, which I've already made here. So in this calculated field, we take the sum of profit and divide it by the sum of sales. We do this so that it will sum up all of the profit per row. So for Cindy, we want to take all of her profit over all of her transactions and divide it by all of her sales instead of doing it row by row, profit divided by sales, and then summing that up at the end. So we'll take our profit ratio and put it on the label, and we can see what her profit ratio is. And since it's a ratio, here I have it in a percent. If you don't have your profit ratio set up as a percent, it will look like this, negative 1.65. Question number 22. What is the rank function in Tableau? We got a look at the rank function earlier when we figured out our top product subcategories by sales and what was rank number 2. So I'm sure you're familiar with what ranking is, which is assigning something a position like first place or second place, usually within a category and usually based on a measure. So Tableau is able to rank in several different ways, where you can do rank or rank dense, rank modified, or rank unique. And we'll take a look at these in a visualization here and talk about the difference. But if you are asked about the rank function in Tableau, it's worth bringing up that there are several different ways to rank, and going into a little bit of detail on those different ways will be helpful for you. So let's build off of this rank example instead. So we're going to bring on our store, and we've got store A, B, C, D, and E. And then we'll bring on our sales. And store A had $10 and E had $40. So now let's create a calculated field. We're going to call it rank. We're going to do a rank calculated field based on sales. We're going to do a rank calculated field based on sum of sales. Perfect. Okay. We'll double click on rank, and we can see first place is the one who had the most sales, and fifth place is the one with the least sales. Now, we had a tie here at 20, and it gave them both third place, and then it skipped fourth place and went to fifth place. And that's how the basic rank function works. So if we duplicate it, and we edit our copy, and we're going to make this one rank dense. You know what? Let's do rank modified second. Okay. And we bring on rank modified. Let's have this happen in order. So sum of sales, then rank modified. Now you can see it's similar to rank first, second, but then it skips third and goes to fourth, and then fifth. So over here it gave them a higher number when there was a tie, and over here it gave them the lower number when there was a tie. So if you could remember that rank gives them the higher number and rank modified gives them the lower number, that will be helpful for your interview. Now we're going to take a look at rank dense. Rank dense, apply. And rank dense doesn't skip a number. So it goes 1, 2, 3, 4, and it condenses the ranking without skipping any numbers. And now let's do our last one, which is going to be rank unique. Okay. And with rank unique, it refuses to give two the same rank. And how it determines when there is a tie is it will look at the dimension that's in the visualization and do whichever one comes first in ASCII. So it goes 1, 2, and these are a tie, and since capital B comes before lowercase c, then it's doing B first, then C, then A. So in your interview, it will be really impressive to talk about the different versions of ranks and how they all work. Question 23. How can you embed a web page in a dashboard? So we're just going to build this and then explain it. So I have here my map by sales, and we're going to build a dashboard. We'll bring on, first we'll change our layout so I can fill up the screen. Then let's bring on my map. And I've added the state name and the sales on the map here. For an embedded web page, you can grab it from the objects section, the web page, and then you could put a URL right inside of here, and then that will embed that page underneath. So if we wanted to do Wikipedia or something, we can hit OK, and it will take you to Wikipedia. But what we're going to do is make this page dynamic based on what state you select. It'll look up that Wikipedia page for that state, so you could maybe look at some population data. We'll close that, and we'll try again. We're going to bring on our web page. It's going to ask for a URL, but we're just going to hit OK and not provide it with a URL. And then we'll use this dashboard action and create a URL action that then contains our URL with our state appended at the end, which is how Wikipedia formats their URL. So we'll hit OK. Oh, I forgot one more thing. Let's do it on select instead of on menu. So whenever we select something, it will run this. OK, OK. And now when we select Texas, it brings up the Texas Wikipedia page. When we select Nebraska, it'll change. So the major points to know on how to embed a web page is you bring it in from the objects section, and then if they ask how to make it dynamic, you use dashboard actions and a URL action.
Question 24. Design a view to show region-wide profit and sales.
So one way you could do this is by bringing on region and then bringing on profit and sales. And that's a pretty simple view of profit and sales by region. However, one thing that interviewers may be looking for when asking a question about region is your mapping capabilities in Tableau. So what we could do is, region is not a geographic location, so it takes a little bit of creativity, but if you bring on state by double-clicking it and it maps out the states, you can make it a map here and it fills it in, and then you can bring region onto color, and that splits it up by region. And then if you bring on profit and sales on the labels, and let's also bring on the state onto labels, and then you can look at your profit and sales inside of their regions, inside of their states. And so that is another view where you could look at profit and sales by region, and it's a little bit more, takes advantage of some of the mapping capabilities in Tableau. It may be what your interviewer is looking for. So you could discuss multiple ways to look at it, but here is one way that we could recommend it. Question 25. How can you optimize the performance of a dashboard? There are multiple ways to optimize the performance of the dashboard. Some of the things that you might mention is that you could exclude any fields you're not using from your visualization, just keep them off, or you can use extract filters, and if you recall, extract filters will remove out rows of data from the extract, and so only focus on the data that you need. Another thing you can do is try and limit the amount of filters that you use, and when you do use filters, avoid using quick filters, and you can use action filters and parameter filters instead. Filters cause your queries in the database to be a little bit more complex and can keep them from running as efficiently as they could. Use min and max instead of average because average functions require more processing time than min and max. Also, you can try to use Boolean and numerical calculations because computers do better with integers and Booleans than they do with strings. So quick things to remember is keep your data simple, use fewer filters, and when you do use filters, use parameters or actions. Avoid using average, use min and max. And avoid using strings by using Booleans and numerical calculations. Question 26. Which visualization will be used in the given scenarios? Here we have 3 scenarios of opportunities that you might want to visualize, and there is no perfectly exact answer for these, but there are some visualizations that tend better for certain types of data. However, there sometimes could be different ways to visualize it, and it doesn't mean that these are the very best ways. However, if you want to take a moment, go ahead and pause the video and go through and figure out what your 3 answers are and comment below, and we can discuss what we think the best ways are. So first we want to show aggregated sales totals across a range of product categories and subcategories. We want to show the duration of events or activities, and we want to show quarter-wise profit growth. So to show aggregated sales totals across a range of products, subcategories, and categories, you could use a tree map. The reason we bring up a tree map here is that they are known for allowing you to show a visualization using hierarchies. So let's take a look at that. We're going to show aggregated sales totals across a range of product categories and subcategories. So if we come here and make a sheet, and we want to see sales across control click category and subcategory, and then we click a tree map, what happens, it's showing it based on size and color. And so it shows the size, the bigger the size, the more sales, and the darker the color, the more sales. And the reason we choose a tree map over just a normal heat map is that it makes a category here. So we can compare this box that has all the technology in it, see how all of these are technology, to this box that has all of the office supplies. And you can quickly see that technology has more than office supplies, but you can also see that phones has more than art. And it breaks it up as a hierarchy and breaks it up based on your sum of sales. And question 2 is show duration or events, a duration of events or activities. And you would use a Gantt chart. Gantt charts are used to show duration. And each of these lines is a duration. So it's got a start date and an end date basically. And it shows you how long everything takes. And the last one is to show profit growth, and you can use a waterfall chart. And that looks like this, where you can see how the profit changes across every period and if it's going up or down. And each one of these show you how much up or how much down they go. But as we said, there are potentially other answers to this question. So if you have any questions about why we didn't say this chart or that chart, go ahead and comment below and we can start a discussion. Question 27. What would you do if some countries or provinces or any geographical entity is missing and displaying a null when you use map view? So when you start to map the geographical fields that you have, sometimes Tableau is unable to map them because their locations are unknown or ambiguous, meaning a lot of states have a city called Springfield, and it won't know where to draw that city. So for example, let's look at here. So we've taken city as our detail, and it's drawn a lot of cities. However, it's got a lot of unknown values here. So if this question comes up, you've got to remember these 3 things. You can edit locations, filter the data, or show data at default position. Edit locations allows you to correct the locations by putting in their unique names. We'll show you an example of this. Filter the data means just keep them off of the view, and show data at default position means show it at 0, 0 on the map. So edit locations. Here we can say, here's all of these cities that seem to exist in multiple locations. And we could say, well, we know what state they're in as well, and that should help you answer the question. So you could choose a field that will define the state. So here we're saying the state is from the state field, and we hit OK, and then it can draw the rest of those cities. Sometimes you want to keep them off. Perhaps maybe they spelled city names wrong, and you just want to exclude those. And the last one is show data at default position, which is 0, 0. 28. What is a level of detail expression? A level of detail expression, or an LOD expression, is maybe the way they will present it to you. And LOD stands for level of detail. So obviously it helps you get to the level of detail that you want in your visualization, but it also is used to run complex queries at the data source level instead of all in the Tableau interface. So we're going to take a look at an example here, which is adding a dimension to an already calculated aggregate field. In our case, we're going to exclude a dimension from a calculated field. So here we have a visualization that I built, and right now it's just looking at sales by category and subcategory. But say we wanted to look at the total sales for furniture and not break it up by the subcategory. So if we take off subcategory, then we get the total sales for furniture. But if we want a side by side, and so that you can see the total sales for furniture and you can see it broken up by subcategory, you can use a level of detail calculation. This, I already made the field for it. I've called it exclude subcategory, so that's right here. Right now it just contains sales, but we're going to use the level of detail calculation exclude. And we're going to tell it what to exclude, which is subcategory. And then we're going to do sum of sales so that it will sum it up for us. And once I apply these changes, it should change it here and our labels. Perfect. So now we can see that it's ignoring the fact that this is chairs and this is tables and this is bookcases. It's just doing the total for furniture and just ignoring these because we told it to exclude. So level of detail helps you to be able to define the level that you want to in your visualization, regardless of what else exists on your visualization. It also moves some of the logic from inside of Tableau to the actual database. And there are 3 level of detail calculations. This will be an important thing to bring up in interviews. They might give you brownie points when you can remember all 3 of the level of detail calculations, which are, we looked at exclude, but we have exclude, include, and fixed. So include, exclude are pretty easy to remember, and just always remember fixed as well. Question 29. How do you calculate daily profit measure using level of detail? Here's another opportunity for you to pause the video and take a look at calculating a daily profit measure using level of detail. We are going to get started. Profitable level of detail. So we want to have a daily profit measure, and I already made a place for it, profit per day. And we want to look at the profit for a day regardless of what else is on the visualization. So we're going to use a fixed instead of an include or an exclude, which will only take into account whatever you put in for include or exclude. Fixed will take into account everything. It will ignore everything else on the visualization and only look at what's in your list here. So we're going to fix it by day. And you have to put a colon. And we're going to do a sum of profit for each of those days. And close it off. So now we have our profit per day. And we'll hit OK. And now we're going to make a KPI, which for our purposes, if profit for a day is greater than 2,000, then that day is highly profitable. If it's less than 0, then it's unprofitable. Otherwise, it is profitable. So we're going to go if our profit per day is greater than 2,000, then we're going to call it highly profitable. Else if we're going to do less than or equal to 0, then profitable. Else, otherwise it is profitable. You always have to end with an end. Great. Okay. So now we're going to make some visualizations, and it's going to look at it by year. Now it all fits in one view. We can rotate these labels to make it easier to see. And we're going to bring on order ID. But now it's showing like a lot of orders. And so we actually want it to be used as a measure, and we're going to do a count distinct. Great. So now we can see how many orders were on each day. And so that's helpful for us to see how many orders are on this day each day, but we want to see the orders on each day that are highly profitable versus unprofitable versus just profitable. So we're going to use our level of detail and break it up into different sections. So we have highly profitable, profitable, and unprofitable. Let's also bring this onto our color. Highly profitable, profitable, unprofitable. And now we can see that the profitable ones are going up. Unprofitable ones seem to be going down in 2015, and that's nice, but they are going up. And highly profitable is not very many. Oh, in this case we did area charts instead of just line charts. To make that change, you change it from automatic to area, and that helps you see some of that spatially as well. Comment below if you were able to make this visualization on your own. Question 30. How can you schedule a workbook in Tableau after publishing it?
So when you publish a workbook in Tableau, if you've used an extract, you're going to need to refresh that extract. So in Tableau, when you create a Tableau data source and it's an extract version of the data source, it will no longer update if the data from your database updates. So somebody's made some changes to your database or your Excel file, and you want to see that in your Tableau visualization. Well, you're not going to see it, but you can see it if you make a refresh. So you do that on Tableau server, and you can remember that you have to get all the way to your data source. So you can go to your data sources or to your workbooks, and then you look at the data source on your workbook, and you go Actions, Extract, Refresh. And then you select Schedule a Refresh. So that looks like this. You can press these three dots next to it and click Refresh Extracts, or you can go to Actions. And then here you click Schedule a Refresh instead of Refresh Now. And then oftentimes in Tableau you'll have several different options. You can choose daily at 7 a.m. or every 4 hours. If an interviewer is asking you about how to schedule a refresh, it might be worthwhile bringing up the fact that you only need to schedule a refresh if you are using an extract on your data source, and then that will help them know that you know the difference between live and extracts if they didn't ever ask that question.
And with that, we have come to the end of our course. If you have any doubts or questions, ask them in the comment section below. Our team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn.